him. Please, could you tell us a little bit about... And welcome back to Tech Days Online, Day 2. I'm Christina Warren, Senior Cloud Developer Advocate at Microsoft. And we're kicking off, as I said, the second day of Tech Days Online. We hope that you were able to join us yesterday. We know that this is the thousands of you were watching yesterday on YouTube. We got the sound issues fixed today. Tech Days Online is in its 8th year, and you know, it's a great opportunity for us to show really great tech content. And what's great about it is that this year it's happening in conjunction with London Tech Week, and where Microsoft is a premier sponsor. And so we've got a video just kind of show what Microsoft and what was happening at London Tech Week yesterday. Check it out. So much fun, so many cool things happening around the city. I'm so glad to be here. If you've been seeing cool things at London Tech Week, let me know, hit me up on Twitter. Speaking of Twitter, if you have any questions during the sessions, you can use the chat on YouTube, but you can also use the hashtag TechDaysOnline on Twitter to let us know your questions, and we'll try to get those answered. Want to just kind of go through what our agenda is going to be. So yesterday we covered containers, microservices, and mixed reality. Today it's all about AI and data, and then tomorrow we're going to be doing stuff on quantum computing. So we've got a great content coming up for you today, all about data and AI, which I know everybody really cares about. In addition to the content that we've got on Tech Days Online, we also have a roaming reporter around London Tech Week, our own Emily Bile, who has been going around asking people questions and trying to get more insights into what is happening in the London tech scene. So check out this video from Emily.
We're here in the heart of London, kicking off London Tech Week at CogX. Let's go have a look inside. So we've got our first interviewee here today. Can you tell me a little bit about yourself? Virtual or augmented reality?
Augmented reality.
Augmented or mixed reality?
Augmented.
And why is that?
Well, I work at Cognitive Scale, and we do augmented intelligence. So for me, augmented equals everything.
Have you used an augmented reality app on your phone?
Not an app, no.
What have you used?
I've used some sort of surgical augmented reality, so you practice doing surgery where you get haptic feedback. Yeah, and that's pretty cool because I wasn't the surgeon, and they're much safer practicing on dummies than they are on real people.
Do you remember your first hologram?
No, unless you mean the ones that you made a funny scratchy noise and you could wobble them around from a cereal packet.
The first hologram I remember was used in Star Wars, and it was Princess Leia saying, "Help me, Obi-Wan Kenobi."
Probably when Tupac Shakur showed up in that one concert years ago.
Have you ever used a virtual reality headset?
I have indeed. I created a soundtrack for an organisation called Gorilla Science. It was for a space travel app where you get to travel around planets. So I provided a soundtrack for the Moon and for Mars and for Pluto, I believe, yeah.
Do you think the future involves wearing some kind of glasses or eyewear?
I know that there's quite a lot more hardware coming out like that at the moment. I think it would depend on how easy people will find to integrate it into their daily lives and their daily looks. So I think design is key to something like that.
Have you ever done a conference call with mixed reality?
I haven't. I'm looking forward to it.
Yes, I have in my current stroke previous employers. Yes, I have. And it's quite an interesting experience, but it saves a huge amount of time. And I think it also provides that opportunity to sort of feel as if you're involved in more than usually a Skype or anything like that. So yes.
Are keyboards going to be redundant anytime soon?
You know what? I think the keyboards might change, but I don't think they'll be completely redundant. So maybe they'll be on-screen keyboards rather than physical keyboards, but I can't see it going away, although famous last words.
Perfect. Thank you very much.
I still think that we're going to need some form of way of cueing what we want to say and how we want to say it. Ideally, I think we'll just talk to machines and they'll just type or send the message that we need. I think they'll still be needed, but I'm not sure they'll be as such a heavy reliance as they are today.
Do you think virtual reality is just hype?
No, because I had my first fully immersive experience with a Microsoft partner the other week, and it was mind-blowing.
No, I think that there is a lot of hype, but it's not just hype. It's going to become very important in the very near future, which is why I'm here.
When do you think mixed reality might become mainstream?
Hasn't it already?
What does AI mean to you?
Well, artificial intelligence is really talking to robots, but is it what just humans put into robots, or is it what robots think for themselves? Who knows? And who knows what will happen in the future?
I said it before, I'm going to say it again. I want Emily's job. I want to interview robots. I love it. And stay tuned. Throughout the day, we're going to have actually more content and more interviews from Emily. But right now, I'm joined by Andrew Fryer, who is kind of the champion and kind of the lead behind all the AI and data content we're going to have today. And Andrew, tell us about what sessions and what content people can expect to see today.
Yeah, we've got some people you may have seen on Tech Days Online before, Christina, but we've also got a lot of new faces based around some of the current work that's bubbling up in the data science world. And we're going to kick the day off by having a look at something very close to my own heart, which is where data science meets the world of DevOps. We often end up siloing disciplines, and I think it's really good when we can blend stuff together. I talk about carbon and iron not being that much use, but put them together, we got steel, which is really useful stuff. And then from there, we're going to go into looking at multi-model management. And rather than just getting one person to make a decision, would we make better decisions if we've got a group of people to make decisions? So why not use a group of models to make a decision? What would that look like if we did that thing? And then we're going to make it real. We're going to get the Ordnance Survey to come along and talk about how they've been using AI and data science generally to do mapping and taking some of the repetitive tasks out of that, becoming up with some new insights and the huge wealth of data they have. I think they've got the third largest geospatial data repository in the world, despite the fact England's a bit smaller, the UK is a bit smaller than other countries. And we're then going to have a look at what's happening in communities. So I think it's quite interesting that we want to start celebrating the work that's done in communities, the networking that goes on, and the inclusion in those communities. Getting people who are maybe a little bit nervous about maybe changing a role or getting into technology can be super hard. So it's great to be able to talk to some other people about that. And then one of my personal favourites, Cosmos DB, this big planet-scale database. I've got an old friend of mine coming on to talk about that. And then I thought it'd be good to actually look at the world of bots, and because they sometimes are the front end to AI. So we've got an example with Bournemouth AFC and how they've used it. And finally, somewhat interestingly called Hidden Figures, because I think we have Alexa and we have Cortana, but let's listen to the voices behind those. Who happen to be ladies as well, doing data science and seeing what they're up to. And then finally, we cut to a chap I have huge admiration from, CTO of Services for Microsoft worldwide, Norm Judah. We've had to send our roving reporter to go and get him because his diary is just rammed, as you can imagine. So going to be hopefully be a really interesting day for everybody.
Fantastic. Well, we're going to have great content, and I know right now you're actually going to go on stage and join Ben, who's going to talk to us about DevOps and data science.
Yeah, let's do this.
Let's do it.
We are selling a product, we are selling also the excellence in supported services.
Customer support and customer service is a huge priority to the company. We have over 600 million contacts per year. Microsoft's advanced AI gave us an opportunity to look at better ways that we could scale. The virtual agent that's guiding them and answering their questions, trying to get the proper context around what the issue is. If the virtual assistant can't solve their problem, that information is automatically passed to a live agent so they can continue the conversation.
Artificial intelligence may be able to boost significantly the productivity of our agent.
It's going to cut down on call handle times. It's going to cut down on the actual overall wait for the customer.
The dashboard is critical. We're able to understand direct customer feedback, see key metrics around how the system is performing and whether or not it's resolving customer problems.
We were addressing maybe 15 to 20% of issues. We're now expanding that to close to 70 or 80% with artificial intelligence.
Microsoft's advanced AI capabilities is a win for any organization. And the platform that they are delivering allows you to get the scale and capabilities that are needed in order to implement AI in your business. We're looking at what other areas that we can apply this technology throughout our ecosystem as part of our digital transformation.
Give me a tool that allows me to say yes, definitively and effectively, this is going to fix your problem. Bring it on, let's do this right now.
And I'm now on stage with Ben. Ben, what are you? What do you do?
So I'm the founder of a company called Katacoda. Katacoda is an interactive learning platform for software developers. And so you can learn all of the great tools which we're going to talk about today, such as Docker, Kubernetes. How do you get started with DevOps and data science and all of these amazing new things which are happening.
And your background, have you come from a data science background or a DevOps background?
This is an interesting question. I have come from many different angles. I started life as first-line tech support and then grew into infrastructure and looking at that. But the world is evolving, and very similar to this topic of the talk, everything's converging. And so I've naturally been gravitated into the world of data science just because it's an interesting topic and it's gaining a lot of interest at the moment. And there's a natural crossover to the infrastructure space, which we're going to talk about.
Indeed there is, yeah, and I think it's this blending of different skills together.
Exactly.
That's super important when we look at this. So, what have you got for us?
So today I wanted to see how we can look at DevOps, but actually not just DevOps, but how data scientists can take advantage of the technologies which are happening, which historically is in the other side of the CAM, the infrastructure, the operations side.
Right.
But actually when you embrace that as a data scientist, what benefits does that bring? And what can we achieve together?
Yeah.
And so if we take a step back and we look at what DevOps is quite a broad remit. It's got many different variations, many different people's got different opinions about what it means. But for me, fundamentally, it's about joining together different conversations and historically joining together the developer side and the operation side and making sure that they're communicating and coordinating releases and software together. And I think that is what we are trying to achieve. We've had to have new skills, new technologies, new ideas coming to the forefront to help support that communication and making sure that we're not just going like, hey, Andrew, I've just built this amazing software for the last 12 months. Can you go to deploy it for me now, please?
Yeah.
And so,
we've got a third dimension here because you've talked about operations and developers, but we've also got the data science guys now coming into the mix, and perhaps they're not even less interested in infrastructure than perhaps the developers are. So we have a bit of a challenge here.
Exactly, and so it's an interesting kind of angle where we've got different people with different priorities. Data scientists may be coming from different backgrounds, they may be focused on different aspects of like their focus. It may not be so much of the code, but actually what can you do with the trained models and how do you build those models in the first place, which we're going to talk about later on. So it's interesting to see how we can still make those techniques and those approaches and the patterns which have been great over the last couple of years within the developer and DevOps side and making them available to data scientists without them needing to be coding experts or
Yeah.
actually at the forefront of these disciplines.
Yeah, because they want to do what they're good at. And let's face it, everybody I know is trying to hire data scientists. And
Exactly.
if you tell them they're not going to be doing data science anymore, you're going to really annoy them, aren't you?
Completely. And that's kind of what I wanted to be talking about today. Like, how can we take what data scientists are producing and what their focus is? So training models, building models, serving them and making them available, and how they can continue to focus that on those disciplines without having to be so concerned with what's happening under the covers.
Yeah.
However, I think it's important to realize what the potential is. Like, why are these new technologies interesting? Why do they exist? And how can people start becoming familiar with them so that when they're having conversations, they have the right touch points and the right things like, oh, you're mentioning Kubernetes. Okay, I have an understanding of what that is and why that's important to me as a data scientist to serve my goal of training models, serving models, etc.
Yeah, so we need to be gentle with these data science guys, and let's explain some of this, these key terms to them.
Cool. So fundamentally, over the last 5 years, the biggest transformation has been around containers. Containers have transformed how software has been deployed, packaged up, deployed, and scaled out, more importantly. And so this is where I think we need to start our journey. And so one of the biggest technologies at the moment is around Docker. Docker has been at the forefront of packaging up this technology of containers and making it available to the mainstream developers and making it available to everyone. And so you can start building and encouraging and getting started with them. And the viewpoint of a container is about packaging. How can we take our machine and run different software which are all independent and all isolated from each other? And what this means is that we don't have to be concerned with interactions and interference between different parts of the software. And so if I'm running a particular version of Python, I don't have to worry about other versions which may be using an older version or a different version or something else which would need to be configured and run on that traditional virtual machine or traditional laptop running somewhere. Instead, what we can do is slice up the machines and make sure that everything is isolated within its own container. And now it means that we can upgrade different parts of the software, we can release new versions independently of each other and gain more flexibility.
Just to be clear, you've got some examples of stuff that we're running in here. If I was a data scientist, I'd probably be interested in two things, R and Python. Would they fit in this model?
Completely. So everything which you're generally running on your laptop, so Python, different versions of Python from version 2 to version 3 and now 3.6, all have got pre-built images which have all been packaged up and made available. And so there's a concept called the Docker Hub. This is where the container images live. These container images have been built and configured so that you can just go, I need Python. And you can go off to the Docker Hub and that has the version of Python available that you can then run as a container.
Great stuff.
And it's the same for R, it's the same for all of the major languages and also some of the more interesting edge cases which may come across. And also, it's not just the languages itself, it can be the frameworks which are building on top of those. So the TensorFlows, which can be then built on top of the Python live Python image. TensorFlow can be configured, and then you just say, I TensorFlow configured and set up, and then you can run your model from that.
So yeah, you just got me thinking here a bit, because if we've got, when we do our development environment, we typically set up a virtual environment for Python, like Anaconda, and so on and so forth, and we can have different isolated environments now. But we could do that with containers now, because there are cross-dependencies. If I want to run like I want to do named entity recognition, for example, understanding the text in the presentation we're giving today, then I'm going to use a framework called Spacey, and that in turn is going to rely on certain versions of other libraries. So this container would capture that and isolate that.
Exactly, and it makes it so that you are building against a stable, consistent environment. And so you can be confident about what versions you require, that configuration, how all of these scripts are put together. Once you get that working on your laptop, you can then scale that out and run that anywhere, be that on production infrastructure or in the cloud on something like Azure.
So that's actually going to help data scientists, whether or not we actually end up taking something like a model and putting it in production, that's just going to help them with their day-to-day job. So surely this would be in sort of mainstream use anyway now.
Exactly, and that's where containers have kind of taken such a world by storm, because it can reduce all of the trial and effort and to get something working on your laptop just instantly becomes removed. Instead, you can focus on what do you need in order to get your job done, instead of worrying about how do you install and configure R, for example.
Excellent. And presumably if a team prepares a container with all the dependencies in that a particular organisation has, you can copy that, make copies of it, and you could store it somewhere. And so if I've got, you know, like we've got the Ordnance Survey coming on later on, for example, if they created a container with all the stuff they need to use, like Keras or whatever it is, then they could just clone that, and everybody, when they start new, they could just have one of these and get going.
Exactly, and that's kind of the benefit of having things like the Docker Hub. And so it becomes this central place. The Docker Hub by default is public, but you can run something like the Azure Container Registry.
Right.
And so you can store all of your internal models, your internal workloads privately in your own sector of Azure. And so then you can share them internally within the teams, and you can make available what other people are working on and what other people are building, so that not everyone has to start from scratch. Not everyone has to reinvent the wheel in order to get to this well-known, good state of configuration.
And I guess we could have some sort of version control on this as well. We can label them up, and I think you can tag them as well with
exactly.
That sort of thing.
And so what you're seeing in the middle is these are the different versions of the .NET. Slightly older version, which I need to update of the screenshots now that 2.0 has been released. But no matter what version you go to, whether it be Python or whether it be Erlang or different approaches, you'll see these versions. And so you can be very explicit about, like, I am running a particular framework or a particular library. It depends on Python 3.3, and you can go like, this is where I need to start from. Everything you have is configured and it's set up to support your requirements.
Fantastic. So I guess the $64,000 question then is, how do we do this stuff?
Yeah, so the first stage is you need to package up your application or your model as a container. And so it's great that you can take these things off the shelf, but we always want to customize something at some point in time. And it's always nice to go like, actually, I want my application to be deployed as a container so that I can run it wherever I need to do. And so let's see how we can start building our own particular container image so that we can run something somewhere. And that starts life as a Docker file. And a Docker file is a list of instructions which goes down and it defines how your application needs to be configured, or what needs to be there in order to support the running of your script or your Python file. And so in this case, it's .NET. This is what I had to hand. And so we're starting with our from. This is defining our dependencies. So we're talking about what image or what Docker image and what versions do I need in order to successfully run my script. So in this case, we've done .NET 1.1. And then everything which we do runs through and tells us how that application needs to be configured and how it needs to be structured in order for it to run. So in this case, we're copying over different files. We're running different commands. In this case, it's doing .NET Restore, but this could easily be doing pip install or whatever is required for the different dependencies, different technologies, apt-get install, etc. We then kind of build our software if we need to do a build, like a Java build or Bazel build for TensorFlow. In this case, .NET Publish. And now we have our compiled DLL or jar or whatever scripted file. And then it's important to make sure that our image actually contains everything our image needs in order to be able to run.
Yes.
Because the last thing I want is for me to hand you an image and say, like, can you run this for me? And then you actually have to look inside of it and go, like, actually, what did you do? Like, which languages are you using? How does it work? Where are the different ports which I need to pass data to, etc. And so we can bake that into the image itself. Which means that when I give it to you, you don't have to worry about that. The image itself already knows how to start.
So I kind of get the command there, running .NET, running a particular .NET app DLL. The expose thing, I guess that's something to do with ports?
Exactly. So this is if you're running a HTTP service or things like this, or if you're serving your model over HTTP, or so like which port needs to be exposed to the outside world, or which port is expecting traffic to come in on. And so again, you're just documenting that so that people know, or other systems know, how to connect the dots, make sure that the dots are available.
Yeah, okay. Super cool. That looks remarkably simple.
Yeah, and they all follow a very consistent pattern. You'll see we've got this from statement. It will copy over some code into the image so that the image is there. It will then define how to start it. And it's nice, consistent pattern so you can move between different teams and see how it works. Excellent. And then we can build it, and we can start our image. And this will go through those steps,
so we
run
just got the
all
log.
of the commands.
Yeah. So that's just a log coming out there after we run the docker build command. Sorry.
Exactly. So this is just a log of the command of what happened, where we need to go, and now we have this beautiful Docker image that can run anywhere, whether it be on our local laptops for testing purposes, or in the cloud, or on another colleague's machine.
And that's an important point. So you can run it locally, and then we can throw it wherever we need to afterwards. So
Exactly.
you could do disconnected development, for example, if you wanted to. Yeah.
Completely. And so now we have this, we have the question of like, okay, now we want to run it at scale. And this is where it starts to become more interesting and more challenging. And so in order to support that, there's a technology which is becoming extremely popular called Kubernetes. And Kubernetes is designed to support running containers and other types of workload at scale, across multiple machines, across potentially multiple clouds, in order to fulfill the requirement of how do I successfully run my application.
What's with the name and the logo there?
So Kubernetes is around sailing and around Greek mythology, and so that's where the name has come from. It's an interesting approach.
Yeah, because I've seen names like Helm and Tiller, and there's a whole sailing, yachting thing, but you don't have to be a sailor to use it.
It could help. It could give you some additional free time and some takeaways, but no, you don't have to be a sailor. It's just a theme and something which the community is taking hold of.
Right, okay.
And so the whole idea of Kubernetes was actually born from inside of Google. So Google has been running containers for the last 10 years, which has been great. They produced a white paper, but just producing a white paper isn't good enough. You need to go above and beyond that. And so they started the idea around Kubernetes and having something which is available to run our containers. But again, Google didn't want to just own that and be the focus. They wanted to be able to support collaboration with different people like Microsoft.
Yep.
And so all of Kubernetes and all of the ideas and the patents and all of the code got donated to something called the Cloud Native Foundation. And so this is a foundation which now governs Kubernetes and all of the other related things, like you mentioned, Helm, and so that we have an open governance, so it's not just just one single vendor which is directing and kind of driving the vision of it. It's now an open community.
And I was using something called ISTIO, which I can't see on here, but it's another add-in for routing. So it's a framework that people can plug into.
Exactly. And so we're starting to see all of these different components come together around Kubernetes to support different requirements and different problems. And that's why I think it should be a good time to explore and see how we can start taking advantage of this and kind of get into the details. So when you're getting started, let's say we need Kubernetes. Like having Kubernetes around is a great starting point to start experimenting and playing with something. And so there's a tool called Minikube, which I'm going to have set up here. So Minikube is how you can run Kubernetes locally on your own laptop.
So you actually provide this. I can see you've tattooed the Katacoda site here, which is great.
Yes. So I'm just using Katacoda as a nice little playground. I don't have to install anything on my laptop.
Right.
It can all be driven via the browser, and I can just, I don't have to worry. But I can find out all of the details, see how it's meant to work, and then if it's actually something of interest, I can install it on my laptop and get it set up.
What a great idea.
But this is just a nice place that you can explore and experiment with these. So we've got a version of Minikube. It runs from the command line. And when you do Minikube start, what it will do is actually go ahead and it will initialize a Kubernetes cluster. It will download everything which it requires, it will set up all of the configuration, and then we have this cluster that we can start deploying containers and what we built in the previous example.
Right. So I can see this looks like it's running on some sort of virtual machine under the covers.
Yeah, under the covers, there's always a virtual machine kind of in play.
Okay.
It makes it available for cross-platform. So when I'm on OS X or Windows, I can still use Minikube to get started.
Fantastic.
But when you're running in something like production, we just happen to have my Azure tab open. Different cloud providers have different Azure services, Kubernetes services. And so this is the Azure one. We can just come in and add a new Kubernetes cluster, and then that will help us walk us through actually deploying our Kubernetes cluster and getting us to the same point that we have with Minikube.
Fantastic.
And now we have something which works locally, but also is exactly the same when we deploy into cloud, and we can now start running these commands and deploying things onto it. And so in the previous step, we did the build. And so we have our image, which has been built. And in this case, it's called Katacoda Docker HTTP server. So we're just running a HTTP server. And what we can do is do kube cuddle or kube control, depending on where you're from.
Kube cuddle, I like it.
Run, you give it a nice friendly name, you give it the name of your built image, and say what ports it's expecting traffic on. And now Kubernetes will take that request for workloads, it will take what you want to run, in this case Docker image, and schedule it onto one of the machines. And so in this case, it will schedule it onto our local laptop. If we're running in Azure and we had 1,000 nodes to play with, it would schedule it onto one which is the most appropriate.
Right.
And we can control that. It's interesting if I say, like, I need a GPU and I happen to have a machine with a GPU inside of the cluster, then it will deploy onto that. It will automatically know what the most appropriate machine is.
And obviously suddenly the data scientists have woken up there because they've heard the word GPU, so that means we can take advantage of frameworks like TensorFlow and CNTK.
Exactly. And so while this example is just a HTTP server, it could easily be a TensorFlow workload, which we'll see in the next demo, in order to fulfill that. And so now we can expose our ports, and we can send it HTTP requests, and we now have our workloads running across different systems.
So earlier you had internally the container was running on port 5000. We've now mapped port 5000 inside the container to port 80 out in the world.
Exactly, and we can change and we can configure that.
Right.
And so this foundation, this Kubernetes cluster, now allows us to run different types of workload based on what we need. And it allows us to run more targeted workloads.
Yep.
So in order to support that, again, we don't want to have we don't want everyone to have to reinvent the wheel and understand all of the intricacies about what's happening under the covers of Kubernetes. Instead, we want to make the concepts available, but at a much higher level. And one of the ways to do this is a project called Kubeflow. So how can we run TensorFlow and machine learning workloads on top of Kubernetes in a nice, straightforward, high-level way? And so this is what we're going to do now. So the purpose of this demo is to, how do we deploy things like a TensorFlow model? How do you deploy the Jupyter Hub and other toolkits so that we can actually start serving
Yes, good point. Yes, of course, you can run Jupyter inside one of these as well. Yeah.
Exactly.
So you've got a framework for writing your notebooks.
Yeah. So what we've got a Kubernetes cluster started already, and we already have this Kubeflow library available. And so it's got some key components already baked in, solving the common use cases. It's still very early, but it's still providing a lot of value. And so out of the box, we can deploy the Jupyter Hub, we can deploy different trained TensorFlow models, and we can also start training our own models itself. And so to deploy this, similar to what we did before, we just do kubectl apply, and that will go ahead and now deploy all of the components within to our cluster. And so we just do this once, and then Kubernetes takes care of all of the configuration and everything which is happening under the covers. And so now we can start actually exploring what's happening. So in this case, I've got a TensorFlow application. It's about my limits of data science capabilities, but it's basically for every node within our TensorFlow. It's going over each of those and performing a matrix multiplication and then returning that matrix multiplication back to the calling code.
Yeah, so it's just working out the area of rectangles.
Exactly. So it's nothing too complex, but it kind of puts in on the touch points of this is TensorFlow and these are how you distribute your workloads. And again, we've packaged this up in advance as an image. And so this is our the name of our container image. So it's just a sample TensorFlow, but this has a Docker file. It would have gone through the Docker build process, and it's been pushed up to a Docker registry, container registry, so that we can start serving our model. And to configure it, instead of having to configure the details of how do you connect different parameter servers within TensorFlow, how do you connect to all of the different requirements together, we're letting Kubeflow and Kubernetes manage that for us.
Right.
Instead, we're managing our high-level requirements and our high-level constructs and focusing on those. So in this case, we're saying we have our master, which is running, and we need one master to manage and coordinate everything. We've got one worker, and we've got two parameter servers. And so that's defining how our model is being, how our TensorFlow application needs to be structured.
And so we wrap all that up in a script. This is configurable. YAML is just a standard some sort of markup language, I'm guessing, from the ML?
Yeah, it's kind of semi-human readable, semi-machine readable, and so it's kind of like a nice intermediate. There's different approaches and different variations, like Helm, but YAML is like the one which you'll see most commonly.
Yeah, so it looks to me a bit like Python because we're using whitespace to integrate, where in JSON we're using brackets. So I'm liking that, actually.
Yeah, so it kind of all hangs together nicely. And so it kind of, the aim is to make something which is accessible and something which you can focus on your requirements of like, how do I run my TensorFlow workload, not how do I create this very complex
And so, and also what's key for me here is we can specify how big this thing is, and then it's just taken care of for us.
Exactly.
So we might have a different recipe to go to production than we would when we're just trying out on a limited set of data.
Exactly, and so that's kind of what we want to be aiming for. And so what it gives us is that flexibility based on how complex our model is and how complex our TensorFlow application needs to be. We can change our parameters by just adding more parameterized servers or more workers or more masters in order to quickly scale up without having to worry about, okay, I now need to provision a new machine or now need to go off and add more cloud infrastructure, which is complex. Instead, we can focus on our requirements. And so at the bottom, what I just did was I went ahead and I did kubectl apply. And so this just goes ahead and deploys that YAML file and works out what needs to be deployed where and links all of these systems together. And it brings everything up as required by our application, and in this case, as required by TensorFlow. And so what we should do, see now, we can do kubectl get job, so see what jobs are working on our system. And we can see that the workloads have been deployed. So we've got our worker, we've got our two parameter servers, and we have our master based on what we defined within that YAML file. And we can see the logs. We should see that our master workload has completed successfully, which is always a great sign. And we can see that it's now gone off and over all of the different components within our system. It's run that matrix multiplication and aggregated those results together. And so it's taken our capabilities, it's taken our task, that snippet of TensorFlow Python code which we needed, and distributed that using Kubernetes to manage all of that for us.
Fantastic.
And so this is really cool. Like, this is a great way to get started with running TensorFlow. Something which you can get started with today is like running Jupyter hubs and running Jupyter and Jupyter notebooks. Extremely popular, and this is part of the thing which gets deployed within Kubeflow. And so what we say is we define the notebook image which we want to run. So in this case, you can see based on the image name, it's been built targeting CPU. We could target one building GPU. We could define our kind of like extra resources, saying we need 3 GPUs available in this machine. That would now go off, and that will now start our notebook for us. And because, again, we've taken advantage of containers, this is what we're deploying, everything our Jupyter notebooks needs has been built within that container image. It's been packaged up and made available. So in this case, we have a few different ones which are available out the box, but we can also come in and create new Python 3 notebooks. And I'm sure now this looks something very familiar, but all of the actual execution, all of the workloads are happening within our Kubernetes cluster. And so all we've had to do is say, we want to start this container, we want to start this notebook, and we can have that running. And so what we can do is do copy to clipboard. We can now copy in our simple hello world Python, run our code, and we now get our hello world back from that. And all of that Python code was being executed on our cluster. We don't have to worry about local resources or local availability or how large our laptops need to be. And instead, we can focus actually on just execution of our code and let other teams worry about the ops.
So I guess the key takeaways are here. We can quickly set up an environment for data science. And then also, all you've shown me here is, all you've shown me, it's been amazing, is a bunch of scripts. And that means I can put all that into some sort of repository. I can put it under source control, and I can manage that. My ops team can take care of that code, and I can pass some of that back to the data science team to create a new environment.
Completely. And you can just take that Kubeflow example which I showed you, spin up an Azure cluster, of Kubernetes, and you let Azure take care of all of the deployment aspects, and you focus on starting Jupyter Hub and running your code.
Fantastic. Ben, that has been an amazing introduction to all of this stuff. So, and your site is going to show data scientists how to do and learn and get started on their journey.
Completely.
Yeah.
So we've got different content. We've got content to get you started on the Kubeflow, the toolkit. If you come onto our homepage, you'll see two which are interesting. So focusing on Kubernetes and how to get started. And we're starting to put together actual machine learning workloads. So how can you do getting started with TensorFlow and layers, NLP and Python. Courses are coming available very shortly, hopefully this week. And so we're starting to branch out and help people get started, whatever level they're coming in at, with these fundamental aspects of the new modern way of working.
Thank you very much indeed, Ben. Well, I think that has been a great introduction, as I say. I think what we'll do now is we'll take a short break. Oh, well, okay. But what I wanted, but before we go, you also an MVP?
I am. Yes, I am an MVP. So I've got one more demo which I can show you, which is called. So the next kind of problem is we've got our models working and we've got them deployed, but how do we store data?
Yeah.
How do we persist data? And so there's a really cool tool called .mesh. They're a great way that you can get started, and so that you can start very quickly having your models served in something which they're called .mesh .science. And it's designed for taking your Jupyter Hub and persisting all of the data around that, all of the data which has been stored in a very central place. So what we were showing with Kubernetes fits very naturally into that kind of world.
But you wouldn't store your data inside the containers. You're going to have pointers to
Exactly, and so you're going to store your data in something like .mesh and use their services as that persistence layer.
Okay, yeah, it's a very, very good point because it's data science we're talking about. Right, I am going to stop you there. We're going to cut to a break, and then we're going to see what we can do with this stuff with MVP Terry McCann.
At Macy's, the most critical thing is to give our shoppers the most friction-free, best customer experience, no matter which channel they choose to shop.
In traditional channels online, FAQ or knowledge base makes the customer work and adds a lot of friction into their experience. By adding the Microsoft AI technology onto our website, we're now able to answer the questions she has. If that virtual agent is not able to give her that answer, then we transfer her to a human agent. Microsoft AI technology enables Macy's to connect our APIs into the platform. So when the customer asks a question, such as where's my order, we're able to go look up the order for her and provide back a very customized response.
We use Azure across the board. The way we can actually integrate other data that we have on the Azure platform and drive the chatbot. It could speed up the time to market for our agents to become proficient, reduce the training time, and also improve the servicing rates. What we love about this is the ability for us to pretty much every single day, every single hour, almost in real time, assess what is important for our customers. So we're looking at social media, desktop, stores, also internally in marketing, merchandising. AI is how business would be conducted. If you don't have a strategy, you need to create one. That's how we see it, and that's how we are building our future. But the excitement is enormous. We're very happy that we're one of the first to do this with Microsoft and to be ahead of the curve.
All right, and now, so you've seen Ben's great presentation. Now, Andrew and I are going to talk to Ben a little bit more. So I have some kind of questions for you. So there's a ton of tech that's likely going to be new to data scientists. A lot of the things you went over, containers, Docker, Kubernetes. And the message is obviously that the more tech in general you know, the more valuable you can be. But do you have any advice about how deep someone needs to go into kind of the DevOps side?
That is an interesting question. I guess it's always challenging no matter where you are, no matter whether you're a data scientist coming to DevOps or just a developer looking at infrastructures. How much do you need to be aware of? And I think it's important to make sure that you're aware of, what's possible, and making sure that you're not missing key important aspects, which may in fact, like, I can't solve X problem because I don't know how to run my workload across 1,000 machines, for example.
Right.
So being conscious of, like, okay, there's probably a way to solve that, and these are the potential options, be that cloud, be that Kubernetes, be that toolkits like Kubeflow, means that when you're coming across interesting problems, it's like, okay, I vaguely know that Kubernetes may do something related to this, or I need a more consistent environment, and I know that Anaconda and containers can help solve that problem. And I think that's where it's important to be aware of. And then kind of deep dive when you actually have the opportunity or the requirement to go like, right, I now need to figure out what this is and whether it actually applies to me.
And kind of a follow-up question related to that, and I know that this will kind of depend, obviously, on the project, but can you give any sort of idea of how much, time a data scientist could save by being able to use like best DevOps practices?
That's a hard question to quantify. I can definitely say from my experience of using containers, I save a significant amount of time just my day-to-day, how do I configure my machine? And so if people are just having trouble just getting Python installed, getting TensorFlow set up, they can save a significant amount of time just by looking at Docker and looking at containers and building on top of those. And things like getting Python and R could take days, and that comes down to minutes. And so when you have those problems, you can save a significant amount of time.
Andrew, do you have experience with that? Since you
I'm afraid I have huge amounts of experience of that. I mean, working with many organisations, what I find is also is a lot of environments are locked down. And if you create a container environment somewhere, you've got a known recipe, InfoSec can sign off on that and say, look, this is perfectly safe. You make copies of that. The new starter turns up on day one. Here's the environment. And it's going to look pretty similar to, say, if you've just left college, university, and you've come in, you'll see exactly what you've got. But the other thing I think for me is that DevOps, we talk about technology. We talk about human beings, and even data scientists and ops guys are human beings, a lot of them are anyway, until we get the robots in. And we all work together. So it's the collaboration on a DevOps project that really matters. And so if you've got the ops guy on a sprint where you've got the data scientist working, it's that bleeding of skills across those and building the trust across those so you know who to ask and help and get stuff started. So I think that's just as important, to actually get data science out of the sort of bunker or the siloed little office and into mainstream technology. We've got to work on that as well.
And I think that's a great point, and I think that's probably true for a lot of the different silos we have. Well, what happens when you have a smaller organization and you don't have maybe a dedicated ops person?
Yeah, well, I think then what you can do is you can go and get these repos that are already out there, these GitHub, get my GitHub confused with my Docker. You can get these Docker images off the shelf, already kind of pre-built. So that's a great place to start because you haven't got to do any work installing stuff. I don't know how to install stuff. I used this when at my last company. I didn't set it up, and you can just go and get it. You can probably go and get what you had before. So I think that's very powerful. And a lot of this technology is about making a startup as powerful as a large organization, I think.
Ben, you were talking about .mesh, and I think that was really interesting, for the persistent stuff, especially with machine learning and that sort of thing. Are there other kind of containerized tools that you know of that are really focused for data scientists?
So I say that's probably the one which is kind of popping up and is the most interesting in that regard. I think Kubeflow is also very much focused on that regard of like how can we use DevOps and what's existing in the landscape to support and enhance the work which is already happening. And I think we're just going to see more over time. There's going to be hundreds of companies started up and popping up. There's Theldon just around the corner from here, which is making it easier to serve models and train models on top of Kubernetes as well. And so we're seeing the emergence of these new startups popping up, and I think that's going to quickly become more of a mainstream thing now that we have such fundamental technology like Kubernetes, which can be deployed anywhere and applied anywhere, means that companies can start innovating on top of that.
Let me throw a question back at both of you, because obviously we were talking about, in this context, how data scientists can get more out of DevOps. Let me kind of reverse the question. What can DevOps, people get from data science?
So I'm particularly looking forward to this because there's a significant amount of data which, at the moment, we come from it from like a DevOps point of view. We've got metrics from every single application and every single server which is running. we've got log files which tell us what the application's doing. And for certain applications, they could be millions of lines, which it's very difficult to digest and actually identify how the application's working and how it's responding. And so I think we're going to start seeing more of a DevOps AI kind of movement, where we're taking machine learning capabilities, applying that to our application metrics in order to figure out how do our applications improve? How can we make them cheaper, more effective to run? How can we shift which type of machines they're running on to be more cost effective? Or the locations of where the machines are running, where there's application problems that can be improved. I think there's a significant amount of opportunity for data science having a huge impact on DevOps just by applying a more regimented, trained model against the data which we're producing.
Andrew, do you have any thoughts on that?
Yeah, I think there's the performance improvement. I think there's the audit capability, finding out when things, the bad guy turning up, running algorithms against that, spotting patterns that aren't immediately obvious in this mine of data, to look at security potentially as well. Performance is kind of important, and tuning it and predicting when problems are going to occur beforehand. The classic thing of running out of storage, or we ran. We were running Tech Days online last year. We had 10,000 people. Now we've got Christina on there, where we can predict the uplift by 50%. So therefore, we need to go and stand up some more servers. Might be a good way to do that.
I think that's being a little generous, but I would appreciate it.
Yeah. So it should. Yeah, I think that reverse osmosis, I think, is very interesting. But I do think that this business of being able to code an application and put it to work in containers applied to data science means that we can put models to work, so that they then become invisible inside our application. If we're going to do like a basket recommendation system, where we're going to make a recommendation, you're going to add something else into your shopping basket, it's got to be really quick, it's got to be really, really fast. But if that isn't there, then the system's broken, and so the whole site could break. So it becomes a dependency. So we have to subject it to the same rigor as any other piece of engineering in our sort of inventory that make up an application.
No, that's a really good point. That if that part of it doesn't work, you've got to apply those same principles. So, kind of going back to, I'm going to ask kind of a funny question. How long do you think before we have an AI that can kind of predict our DevOps intentions, basically kind of eliminating the need for DevOps? When are the bots going to put you out of a job?
That's a question for all of us, not just DevOps.
Oh, I agree, 1,000%. I'm certainly someone who could be.
So I'm aware of a couple of startups who would say that's already the case, and if you buy their solution, they would do that. Of all great startups claim.
Of course, and they're all correct.
I think there's definitely going to be support being added. I don't think we're ever in concern of it being replaced. I think our jobs may just shift.
Sure.
Same with like the invention of the cloud. It doesn't mean that we're no longer concerned with infrastructure and machines. It means that we're no longer just building physical boxes. Instead, we let Microsoft do that, who are much better positioned to do that for us.
Right. And we can focus on other things.
And so we can focus on higher level problems and more business focused problems, such as reliability and availability and performance, security, and all of the other critical factors, not just so much about is my machine running or not. Yeah. And I think that's where DevOps and data science can help us lift to another level, where actually we can now start focusing on a different problem, a more interesting, deeper problem than the day-to-day, like, oh, my application's running slow because I need to turn it off and on again every 24 hours.
Yeah, that famous tagline of what do you want to do today? And we'll worry about, the AI is going to worry about how that gets done. I think that's kind of what. Yeah.
Cool. And so obviously this is a little more esoteric, but we've got Docker, obviously Kubernetes. You kind of what do you see as kind of the next big thing happening in kind of this movement?
So they are pretty transformational. Docker has definitely transformed over the last 5 years about how applications are packaged up, deployed, how we install and run things locally, up to how we run and deploy things at a global scale. So we're now seeing that has led to things like Kubernetes. I don't think we're at the point now where we've seen the full potential of what Kubernetes can bring. I think that's now becoming the platform and the foundation. I think what is going to be interesting is what can we do on top of that.
Okay.
And what advantages does that now bring once we have this consistent experience. And so I think we're going to see lots more of people taking advantage of running different types of workloads, not just running your web application, but running 1,000 machines to run training models for 10 minutes, all managed by Kubernetes, and then instantly get teared back down again afterwards when their workload is done. And actually being able to quickly iterate and turn around our feedback time on having these models trained. So instead of it being 30 hours of GPU time, it gets reduced back down because we can build on top of like the Azure capabilities and Kubernetes and our applications configuration and let that work in a much more simplified way without us as DevOps or as data scientists having to worry about the finer grained details like, right, I need to start up all of this infrastructure to do it. We can let the platforms do that for us.
And maybe one day we can have AI kind of on top of that to help with all of that.
Exactly, and that's where that can help kind of support and enhance that experience.
Amazing. Ben, thank you so much for your talk, and we are going to take a quick break, and we will be back with our next session.
It's day 2 of London Tech Week, and we're here at the Excel Arena for Tech Accelerate. Let's go speak to some people about AI and quantum. What does AI mean to you?
Well, AI probably, I'm not a tech guy, but it probably is one of the biggest tech trends. And for me, AI means make a computer equal as smart or even smarter as humans. And so far, when I'm talking to my phone, it's not as smart as a human, but I wish it would be. So I'm hoping on that would be the case.
AI means to me the realm of opportunities to harness computational power or the supercomputers and so on to make decision making faster, more intelligent and more evidence-based.
I mean, AI is essentially a better way of producing services for the consumer. I mean, ultimately, when you look at it from a telco perspective, there is very little innovation aside from the fact that you can offer data for cheaper or calls better. AI offers a bit of a way for the telcos to actually make money without having to compete with the OTTs by some innovations on the network, for instance.
Is AI a force for good or the end of mankind as we know it? A bit dramatic, but...
I think it's a force for good. I think the world is always changing and technology is part of our change and our daily lives, really. So I think it's going to bring greater things. So we have a Pepper in Vodafone that's kind of like, artificial intelligence. So kind of teach her to do new things and everything. So yeah, I think it's a force for good.
It's a force for good. It's one of the best things that'll ever happen to us, I think.
There's obviously a lot of naysayers and a lot of people that are sort of terrified of the prospect of AI, but you look at everything around us, whether it's on social media, it already exists. Ultimately, you've got to look at the idea of a sentient being is so far advanced that it is theoretically impossible for compute power or even the technology that we're putting out onto the market at the moment. So, yeah, I mean, it's in theory good. It'll make a lot of people redundant, but ultimately, that's business.
I think it's not a black or white situation. I think it depends a lot on the people that are doing the solutions and developing behind it. So it depends a lot on us. It can go either way. So that's why we need to make sure it goes the right way.
How do you think AI could help improve your job? Is there any areas that could be autonomized or anything that you think it would help add value to?
Well, I hope not to take too much away so I don't lose my job. But to improve it, yeah, I think maybe with our repair operation, if we had more AI, it'd be able to pick up faults quicker than what a human can. So yeah, I think there's benefits there.
So there's a lot of stuff that we currently do that it's just time consuming and we don't add value to it. I think what a person can add in comparison to a machine is a lot, but if we're just stuck with tasks that take the time off and we don't get to explore the creative side, I think we're missing out on it.
Do you trust companies with your data?
Do I what, sorry?
Do you trust companies with your data?
Yeah, I do. I don't feel like I've got anything to hide, and I don't really care if companies want to contact me. It's fine. I don't feel like they're going to do nefarious things with it.
I'm an old-fashioned kind of geek. I put everything out there. I accept all the telematics. Tick, next, I agree, not a problem. All I do, behavioural again, is I choose what I put out there. What they decide to do with that, that's fine. I don't really have an issue with that. I think what's needed is people to understand that what they say is more important, and the platform of the internet and everything else is neutral. The same as the telephone was when Alexander Graham Bell invented it, or any other means of communication. It is a medium. It is not the beginning or nor the end, and that's what people should concentrate on. I think we're just still distracted by the shiny lights of the medium, will be my answer to that.
Do you think AI can be creative?
Not in the human way that we think of. I think there's always going to be a very unique approach of the human mindset and the human spirit. I don't think the AIs will reach this very soon, if at all. I don't think so. For example, a painter or a composer, I think that's very hard to replicate these types of creativity.
I don't think it's creative now, just purely because I don't think that the power is there and the levels of rational data. Whether it actually can be creative, I 100% agree, because I don't believe creativity is something that comes from the soul or something like that. You know, if you look at the basic concept of creativity, it's creating a novel idea or something that's never existed before. So by the basic definition of sort of data science, AI could evaluate absolutely everything, every book that's out there, and figure out one theme that is missing or not being collected altogether. Yeah, it's a very scientific way to be sort of creative, but ultimately it's achieved the same goal in that it's created something which has never existed before. So yeah, why not? Why couldn't it be creative?
Would you trust an AI, say chatbot, or some sort of artificial intelligence to set you up on a date, to match you with someone for a date?
So as I'm married, no. But in general, if I were younger, I mean, I met my wife online already, yeah? So I met her already through algorithms or whatever. So of course, I trust those technologies the way I did before. So why not use technologies that find even more suitable women or whatever, although now I'm already here, I'm married, yeah, so.
That's the point of no return.
I don't think that would make my husband very happy, but I mean, just for the fun of it, I would say yes.
We've had a fantastic day here at London Tech Week, talked about AI and quantum, but back to you in the studio to find out more.
We have so many people who are non-verbal, but still have so much to say.
I want the exact same information that my hearing friends have.
There are barriers to communication everywhere, but I think it's time we look at the barriers as opportunities to reach out to everyone.
Soundscape fills in a lot of the mental map as you move.
Approaching intersection.
You can just put it in your pocket and go.
With ALS, you become locked in. But we see technology as a way to give back what ALS has taken away.
There's no better feeling than to hear a child say something that they've wanted to say and the look on their face after they've been able to say it.
When it's reading, I see spaces between the words, and it's easy to focus on.
Anjay realized that here was something that could change his life.
Now that I have my phone, I can see exactly what was said, and that's been a huge help to me.
The system is learning as it goes, and the accuracy has improved tremendously.
Students can pick any language that they choose to receive the information. It's like we jumped into the future.
Because communication is very important for all of us, and we just want to be together and not feel left out.
Aider les personnes avec autisme à communiquer, il y a des images.
Je parle, je donne une information à Arthur et elle est traduite par l'application El Picto instantanément en pictogramme et après d'une façon orale.
Va t'habiller et te brosser les dents.
On va pouvoir remettre en place une communication qui est plus spontanée. Je crois que ça aide à recréer du lien.
Both my wife and I are totally blind, and we have a 3-year-old son that's in preschool. He can see, but his parents can't. So to be able to know what's going on at his school is everything. The Seeing AI app has the ability to allow me access to the visual world. Artificial intelligence is beginning to have an impact on the lives of people with disabilities, but it's only going to grow. There is still so much out there to be done.
Hi, and we're back at Tech Days Online. Last session we saw how to get started with Docker containers. And we did talk about some of the wider uses of those containers. But now I want to have a chat with a very good friend of mine, a recently minted MVP, Terry McCann, to see what we can do with some of those containers.
Yep, exactly. So thanks very much for having me here today. Yes, so as Andrew says, newly minted MVP in December last year. So always very grateful for that. So today pretty much we want to start looking at, building pretty much on a lot of the stuff that Ben spoke about and sort of thinking about when you do manage to get that model into production, what happens once it's in production? So that's what this session is. So my name's Terry McCann. I'm from a company called Adatus Consulting Limited. We are an advanced analytics consultancy. We specialize pretty much in anything to do with advanced analytics. That's from warehouses all the way up to managing multiple models in Azure. Cool. So I guess to kick off, one of the things that is a real bugbear for me is when you start looking at any machine learning book, any introduction to machine learning book, they'll often talk to you about the process of machine learning. They'll sort of run you through what they see as the ideal way to go from some raw data into some kind of model. But what most of these books neglect to ever tell you is how you then actually go about taking that model that you've built and putting it up into production. So I think a lot of the work that Ben was talking about in the previous session around Docker and Kubernetes and those associated tools can really help you. But my main problem is, the sort of process that we start seeing with machine learning is people will often start talking about, okay, well, what are the steps? Step one, we gather some data. Step two, we prepare that data. And there's always this sort of horrible statistic floating around that 70% of data scientists' time is spent just sort of cleaning and munging data. And for me, that feels awful. And that is, while that task can be, enjoyable, the problem is that 70% of the time where it is almost put in the wrong place. We don't want that time to be spent there. We want to be using things like Ben's been talking about, DevOps and DataOps, to accelerate that. So once we're beyond that, we have choosing a model. So actually, which model we should start working with. So, working out, are we looking to do regression, classification? What is it we're trying to do? Then we train our model. That whole process of, we take our data and we split it. We use 70% to train our data. We use 30% to test our data and to cross-validate with the intention that, we'll come out with a model. At which point then we want to evaluate that model, and then dependent on the outcome of that evaluation, so we might be looking at the root mean squared error, we might be looking at a confusion matrix if we're doing classification. We might then want to do some hyperparameter tuning and try and really tune that model to get something, get the best out of that model possible. Hopefully, which then leads us to a prediction. And so sort of like this whole process is what lots of books will tell you about. They'll tell you how to do each one of these steps in great detail. Then when it comes to production, when it comes to deployment, they generally sort of peter off and no one really tells you a great deal about what you should be doing. And they also don't really tell you what happens if you do get that model into deployment. Lots of these books almost lead you into a false assumption that once you build a model, it's done and it's deployed and you're ready to go and it's never going to change. And the second that you actually start working with models in production, you quickly realize that that just isn't the case. So many other processes will quote things like CrispDM. So
that's the cross-industry standard process for data mining?
That's exactly it, yeah. So CrispDM is this iterative process. So hopefully what you can see here is indicated by this sort of wider circle with the arrows, is showing that CrispDM is this iterative process of business understanding, data prep, modeling, and evaluation. And that evaluation loops back to business understanding. The intention being, you know, if you've got so far, but it hasn't quite got you the accuracy or the level of prediction that you want, you'll loop back and you'll keep doing it. But then you'll see here they just they skip off to deployment. Yeah. And so they never really talk about, you know, what happens there.
No feedback loop either.
Yeah, yeah, exactly.
Is it working, you know, because you know, if you made a prediction on something, you'd write that back, say, into a warehouse, and then you want to use that again for the next, you know, the next iteration.
Yes. So I think sort of what a lot of these models really neglect is the key problems that you start seeing once a model goes into production. So model decay is a real key one. So at the point that, going back to saying, you know, well, we've got our 70% and we've trained our data and we've tested our data, at the point that we've trained that data, we've created a generic model, you know, that is as accurate as the data that we trained it with. Hopefully it's generic enough that it will fit with all of our data going forward, but it's not necessarily always going to work like that. So if I'm a company that sells stationery and you know, I've got 100,000 customers and I train my model based on their behaviors, I'm looking to predict whether or not they will buy more stationery. And we get a couple thousand new customers come in, you know, hopefully our model is still just mapped to that, it's fairly generic. And then our company, we get a load of money, we decide that we're going to start selling submarines. And so the people who buy stationery compared to the people who buy submarines,
quite different.
Yeah, they're quite different. Yeah. So our model now that we have in production, which is going to predict whether or not you'll buy stationery and now buy submarines, it probably isn't going to work. That model is no longer accurate. So then we need to start thinking, okay, well, once that model, if that model is no longer accurate, you know, do I just retrain it? Yeah. Is that okay? And it's all these sort of problems that really sort of really hinder around this key quote that I found in a book called Doing Data Science Straight from the Front Line. And Schutt and O'Neill have said that the productionization of models is the toughest problem in data science. And I think if you're coming to data science from a completely clear slate, that you might see that and think that that's, you know, that's wrong. That the hardest problem would be your model selection, it'd be your hyperparameter tuning. And while that stuff is hard, it doesn't sort of, you can do that stuff well with a decent amount of knowledge, but the actual productionization requires a completely separate set of skills. And the customers that I work with generally form sort of two camps. You have the really super academic data scientists who have PhDs, who are really high skilled in maths and statistics. But what they don't necessarily always have is a great deal of engineering background. They don't really have the necessary skills to get those models into production, and then also to think about how they handle those models once they are in production. Which also I think Ben's talk quite, you know, nicely sort of aims to try and do that.
Yeah.
Okay, so I guess, you know, what's really wrong with the CrispDM process then? If, you know, we're stopping at deployment and no one's really talking about it, you almost need a sort of separate cycle that sort of spins off after deployment. So what we're doing here is we're saying, once I've deployed a model into production, I need to start monitoring it. And talking again about DevOps and the sort of data ops process, one of the other key problems that you have with the productionization of machine learning models is, for many businesses who are just sort of starting that journey into machine learning, they may be quite hesitant, especially if they've not embraced concepts such as DevOps, to say, as a data scientist, I've built this great model and I want to deploy this R model into production. So typically what can sometimes happen is the operational team will say, okay, actually we don't want you deploying R. Our production language is Java. We're going to rewrite your R model in Java. And we're going to rewrite the data that it's using so it works with our standard processes. And I mean, the problem with that is, fundamentally, that Java model is of no relation to what that R model was. And also, the amount of time taken between that R model being converted into a Java model just, again, means that the period of decay between those models just, you know, really can't work. So we need some way that we can stop that happening. So we have this sort of, let's say, this extra sort of cycle here of monitoring, sort of having a look what's happening, having a look which of our models are being used in production, which ones are predicting, and also which predictions they're coming back with. And almost more importantly, what we want to know is, well, what's being asked of our models? So if our model's in production and we've trained it against those 100,000 customers, how many new customers are we seeing? How do we know when it's a good time to retrain?
Yeah.
And I think that's a really tricky question to answer. So, but once we are doing monitoring, we can start doing our evaluation. We can start saying, okay, we had 100,000 customers. We've had 3,000 new customers. Is that enough to think we should retrain? Has there been some major shift? If there is, then we need to do some retraining. And then again, we go into a complete cycle, and we may even loop back in if we do retraining if our business has changed fundamentally.
So that'd be a bit like InAppDev releasing a version of an application.
Yep.
Where we might go back to the drawing board at some point and come up with a new variant. Would that be
Yeah, exactly. And I think sometimes that gets a little bit missed in data science because lots of data scientists don't necessarily have a traditional software development background. So things, again, going back to DevOps, things around source control and actually versioning your models and versioning your code is really interesting. And it's something that isn't always done by data scientists. So yeah, being able to say that we currently have version 1 in production, we have version 2 in production, again, is sort of seldom really the norm for a data science team.
Yeah.
Okay, so the other sort of problem that we have, and I think really touching on what you said about multiple versions, is we may have had our version 1 of our model, and now we've had this change. We're now selling submarines. We're selling stationary still, but we're still selling submarines now. So I've retrained my model. And so what I now have is I've got 2 models. Yep. So I've got the same one, we're just doing a random forest here. But I've got my original one, which is based on my stationary customers, and my new one, which is based on my submarines and my stationary customers. Yep. But now I'm in the problem of I can't just switch off one because I've got so many business processes hooked around this machine learning model. If I switch this off, I'm potentially going to cause, if that version 2 is incorrect, if for some reason it hasn't been tested well enough, and I start making predictions that aren't right, just by flicking one off and switching the other on, we potentially have a big problem. So we get into a sort of almost an A/B testing scenario.
Yeah. Okay.
And so what we want to do is start thinking, okay, well, how do I handle these 2 models? These 2 models are now in production. How can I handle the distribution of requests to each of them? And so one sort of scenario you'll commonly see, what people talk about, is this idea of almost like a smart load balancer. Yes. And what the smart load balancer would do is be aware of how many models you have in production and say, okay, as requests come through, what I want you to do is start pushing some requests off to my version 1 and some requests off to my version 2. So sort of what we can see here is one request went to version 1, another one went to version 1, one went to version 2, another to version 1, and another to version 1. So we've sort of got this 90-10 split here. And hopefully what we can do over time is we can start moving that sort of slowly over to version 2. If we're not seeing a massive impact by version 2, we've got some assurances then that that model's actually okay. But this sort of works. And I was at a conference a couple of weeks ago where there were a couple of people sort of saying, this is a really good scenario to go with. But my problem with this is what we're only ever doing is we're sending a request to a single model. Yes. We never get to see the output of both of those models for the same request. So we never know if they're making separate predictions, if they're making the same prediction. So it's difficult to see whether or not our new model actually is actually having a positive or a negative impact.
Right. You might have done some testing before you released it, though, to say.
You would hope you would. You'd hope you did some testing. But again, not necessarily. Once it goes into production, you don't always guarantee that, how you've built stuff, how you've tested it, when that is in a live environment, whether or not that will behave as you expect.
Good point. I mean, you might have some test data, but obviously there's nothing like live transactions coming through this.
No, exactly. So what we might actually want to do is have, beyond our load balancer, is this little evaluation guide down the bottom. And instead of sending a request down that 90-10 split, we send both requests at the same time. We send that request to both of our models. And then what we do instead of it going from one to the other is we get both of those answers from both of our models.
Right.
And we have some kind of evaluation service to say, okay, well, you're both saying true. Okay, that's probably good. One's saying true, one's saying false. At which point then, how do we work out which model we select?
Yes.
And so, I mean, that's quite...
And that's just for a two-class classification problem. So
exactly.
If you're doing regression.
Yeah. And so that's, I mean, that's sort of one scenario where we've got a version 1 and a version 2 of a single model. But again, when you're in production, it's not necessarily that you have one single model that satisfies a single business objective. If that business objective is maybe, is a customer going to churn? Customers using my service, are they going to leave that service? I want to do some kind of intervention. That may be Random Forest 1 and Random Forest 2. I might want to see with both of those. I might use that because it's a particularly quick algorithm and I know that's going to work. But what I might have is I might have a third model in there. I might have a k-nearest neighbors or something like that. Now this model always produces me a better level of accuracy, but it takes that bit longer. And if I've got this as part of my application in front of a customer, and say this is choosing which flavor or website I should show them, you know, I can't have any one of these models returning any slower than around about 100 milliseconds. Because it's at that point that somebody starts seeing and noticing that there's a delay.
Yeah.
So I might say, well, actually, in the event that that model takes too long, I want to fall back to one of my other models. Right. And again, you might have various different scenarios where you may end up having even more than that. You may have loads of different models. And this isn't a fictitious idea or anything. This is, so based on the work that I've been doing with some customers recently, this is the sort of thing that we see people trying to do and people struggling with.
Right.
They are finding it quite tricky to actually manage multiple models in production. So a smart load balancer for that sort of scenario just wouldn't work.
Right.
If we're trying to cascade to 6 models at once, then we've heavily diluted that. And handling the percentage changes between that one should get 90, this one should get 1, 2, you know, that's an awful lot of work. Okay, so, but this isn't the only problem. This isn't the only real problem that we see. The other problem that you sort of start seeing is where we've got all of our different models, they might not be written in the same languages. So lots of the customers we see, almost some of them end up forcing their teams just to learn Python or just to learn R. So everyone's working in a consistent way. And while that works to an extent, I don't think it's always the best option for everybody. And so you've got lots of people coming out of university, lots of graduates who are particularly skilled in a particular area. That may be Julia, that may be MATLAB, that may be R, that may be Python, that could be Scala. And then taking their core skills and saying, no, 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 you now need to just learn Python. You're just a Python developer now. Is, you know, isn't the best way really to use their skills. You want to have a production environment where you can work in the languages that you're skilled in and that you're best in and get it deploying in that way. So you might have our random forest models all written in R, and our k-nearest neighbor was in Julia, we had another model in Scala, and we had 2 in Python. So we need some way, when we go into production, handling these multiple models, we need some way that we are able to handle that, but based on any language that they're using.
Because in Ben's model, he was just taking Python, in his container demo, he was just taking the language and exposing it, but that's not going to be good enough here.
No.
Because you've got to call something.
Yeah, exactly. And sort of building on what Ben was sort of saying around that is, so containers are a great way to solve this problem, and also to solve that problem of companies who have, say, a production language like Java. If they're not comfortable with deploying R just on its own into production, being able to say, okay, well, hold on, you know, we're not going to deploy it as it is. What you're going to do is going to package that into a container. It's going to be completely isolated away from everything else you're doing with minimal impact to any of our other services. You know, that sort of reduces that anxiety with those guys.
Yes, and they may be container savvy anyway, so they're not unduly worried about what's in it. They're just going to see that as a black box.
Yeah, exactly. Okay, but I mean, so we've got 4 languages here. And in a recent study by MapR, they looked at, with some of their customers they were working with, they asked the customers who are quite adept in machine learning, what's the smallest amount of machine learning languages you work with, and what's the largest amount of machine learning languages? So not the smallest and largest companies, but how many languages they worked with. And the smallest company, the fewest amount of languages they found were, the one company was using 5 languages. So we had 4 on that previous screen, but the smallest company they worked with were using 5 languages in production. The largest company were using 13 languages in production. So that's 13 separate languages, separate skills that all need to be put in production rather than sort of forcing everybody to use one language. We need some kind of process that just says, look, if you're really good in Julia, cool, then you stay good in that. Or if that's a particularly good language for one particular scenario, then you keep working in that and we'll work around it. But I mean, where do you begin to start with this? And so this was a really interesting one for me. So Andrew, as you'll know, as you've been up to Dundee to Mark Whitehorn's master's degree in data science, I recently finished a master's degree in data science through Dundee. Thank you very much. And I went through so many different ideas for trying to come up with something I could do for my dissertation. And so I wanted some way of almost like working with, I come from an engineering background as opposed to a pure data science background. So I wanted to try and focus on stuff that I know that could try to do something that would help the wider industry. So in a similar sort of vein to Ben's, I looked at applying data ops to data science with the intention of handling multiple models in production. And so when I was coming up with what was going to be my idea, I sort of had a very similar idea to this sort of smart load balancer. And then about September last year, a book came out that I read and fundamentally changed sort of the way that I saw how this should work. So this book was Machine Learning Logistics by Ted Dunning and Ellen Friedman. And in their book, they talk about, so the title is Model Management in the Real World. And I think that's really key here is it's not, it's not a theoretical book. It is machine learning in the real world and how you would handle model management in the real world. And so they talk about a type of architecture called the rendezvous architecture. And this is where we start looking at how we could handle multiple models in production. So using their architecture, this is part of what they came up with. So what we have over there is our raw profile, our features, our input coming in. And that input is being cascaded to multiple models. So we've got model 1 there, model 2, model 3. They're all being evaluated at the same time and pushing their scores off to a score pipeline. Now, the interesting thing that you have here with their architecture is this idea at the top here of a decoy. And so what the decoy sort of does is it sits there looking like a machine learning model, but what it's doing is it's just capturing the incoming requests.
So again, if we writes them out to some store somewhere.
Exactly. So it's going off to some archive. That could be, anything. That could be a database. That could be a flat file. Whatever it is that you're particularly working with. And so the benefit of doing that, of capturing each one of those incoming requests, just means that if we do have that model decay and we're trying to work out what should be a way that we automatically retrain once we go into production, that's a good way of sort of starting to think. You can set levels of change that you might want.
Because you'll have done, in this features profile step, you'll have transformed the data into a shape that it can be consumed by a model. So you don't have to do any further processing in order to do programmatic retraining.
No, exactly.
Okay.
And they do a really interesting thing in this architecture, which sort of sets it apart, I think, from anything like a smart load balancer. So the idea of a smart load balancer would mean that it needs to be aware of all the models that it's distributing to. So the problem with that is when I get a version 3, if I haven't got rid of my version 1, I have to change that load balancer. That has to now become aware of that one as well. But what they're doing here is these lines indicating going off to these models is actually done by streaming. And it's done through a subscriber topic basis. So each one of these models is subscribing to a queue as opposed to being the request being pushed to them.
So that's like we have in event hubs?
Yep, so like event hubs, like
Right.
Stream Analytics, like Kafka on HD Insight or something like that. There's a stream coming in, and that stream is going into a queue, and each one of these models is just constantly monitoring that queue. And when a message goes into that queue, it says, cool, I know I need to run now, I'm going to go away and do my thing. So again, this one might be a random forest, this one might be some kind of decision tree, or it could be something in TensorFlow, it could be running on a GPU. However you wanted to run it, each one of these could be doing something different. Each one of these then gets evaluated and pushes a score off. The benefit here means that if somebody on my team starts building up something else, something interesting, and they think, okay, I've got a really good model, this might be of some real benefit, then they can just set it up to subscribe to that same topic. And now when a message comes in, that also gets fired, and those scores will also go.
So it's on the model, it's on the container, I assume in this case, to watch a queue rather than to, so they're self-aware
exactly.
in a way, to go and pull the stream out.
Yeah, exactly. So, I mean, now we're at the scenario where we've got multiple models all pushing their scores off into one score pipeline. But now we need to think, okay, so I've got 3 responses to my single request. What do I do with that single request?
Yes.
And this is where the concept of rendezvous really comes in. And so we add on to this scenario a rendezvous server, a rendezvous service, which is going to take those scores and try and work out what's the best way I should work with them. And each one of these can almost become a policy. So we could say, my policy is I just want to take the fastest result that comes back to me.
Right.
Whichever one of my models finishes first, I want that response. It could be, say we're just doing a binary classification. It could be I've got 5 different models doing the same type of classification. And what I want to do is I want to capture all of those 5 requests. If 4 of those come out true and 1 comes out false, just say, OK, it's probably going to be true.
Yeah.
We take the basis
of like a democracy kind
exactly.
of thing.
Yeah. So, so you made a comment about, one person making one choice is OK, but a group of people making a choice together is always going to be better.
Well, hopefully.
Hopefully.
I'm not going to say anything about politics at that point.
So where we have a group of models all making their own predictions, and we have some way to sort of say, OK, which one should I take?
Yeah.
But it may be that we trust individuals in that group slightly more than we trust other individuals. So maybe model 1 is our most trustworthy. It's the model that gives us the highest level of accuracy. So we could say our rendezvous service could have a policy which says, OK, if model 1 returns in an acceptable time, that acceptable time could be 100 milliseconds. If it's not in front of a person, if it's just like a batch process, then that time could be larger. It could be 1,000 milliseconds. If that model returns in the right amount of time, give me that one. If that one doesn't, has model 2 returned in the right amount of time? If not, give me model 3. And what model 3 may be is just the default answer.
Yeah.
If it's like an A/B test on a website, it could always be, just give me the vanilla version of our website.
I presume you could do something cute with confidence levels, or the most confident model.
You could do, so that's a really interesting concept around which one's the confident level, and actually almost if you had a good feedback loop, then you could append a sort of like reinforcement type learning onto the back of this, which would be, if we're trying to predict something and we always know the outcome after we've predicted it. So we're trying to say, will somebody churn? And we say, no, they're not going to churn, and then they do churn, and we have that feedback loop. We made that prediction wrong.
Yeah.
So we know that if that prediction came from model 1 and it was wrong, our feedback loop hopefully could then re-infer which one of these models has a stronger weight.
Yep.
It all comes from this sort of concept of a multi-arm bandit.
Yeah.
So the sort of you're in Vegas, pulling the machines, you get the things. You've got two arms either side. You pull one arm down and you lose. You pull it down again and you lose. You pull the other arm down and you win. You pull the other arm down and you lose, and the other arm you win, and you start seeing that you're winning a lot more on one side. And that's the same sort of concept that we could apply to a model like this.
Is there a concern? I mean, obviously, we've talked about this streaming architecture. It sounds like it's really speedy. Is there a concern in a fast-moving, where you need to return a model quickly, this is all going to take a lot more time?
Not necessarily. So, because we have various different weights on each one of these models, our rendezvous service can be built to just say, well, whichever model gives me the response in the fastest time. You know, there's going to be a slight overhead for the image that's going to be looking at that queue, then reading that information and passing it off to another queue. But if configured correctly, if using decent streaming services, so for the way that we built this for a customer, we used Service Bus, scaled up high enough. It was good for what we wanted.
And Terry, you obviously mentioned you've done this research as part of your dissertation for your masters.
Yep.
You've had a crack at this in production as well.
Yeah, exactly. So my intention was that I would do the research around about the time that we had a very similar problem for a customer.
Genius.
And I could do them whilst I was working, and I could just work on my dissertation. Unfortunately, it never happened, and I finished my dissertation, and then that project started. So it was very good for my customer, but did mean I then had to do all the work up front. But yeah, so we did, and I've got the sort of architecture of how we've translated this.
Oh, cool.
So because this book is it's almost very theoretical. It's heavily based around the MapR toolkit. So all our customers are Microsoft customers. They don't necessarily have MapR. They don't have those same things. So we wanted to port this sort of architecture.
Sure.
One last thing that you can do here is stick metrics everywhere. So every one of your models that's returning a score, capture that score, capture what it's doing.
And the version of the model and all the rest of it. So you've got metadata as well going on.
Exactly. So there's a lot of data to capture, but it can sort of lead to really interesting insights. The same with your rendezvous. So we can start monitoring the total latency from that initial request to that result. And we can see, what decisions were happened and how was that decision got to. And hopefully, it doesn't take a long amount of time. Okay, so we're sort of on to how that would work in...
Looks just like you.
Well, that's how all data scientists look, is in my experience.
I'm going to mention that to Isabel later on, who's a performance survey. I'm sure she hasn't got a beard.
That's it. So what we had is we needed to translate that architecture into Azure. So everything that we're trying to do needs to integrate in with multiple different applications. So one of the simple ways to do that is to expose our models through a REST API. Super simple way to do that in Azure is to use Azure Functions. So functions, come in a whole load of different flavors. For this scenario, we use C#. So we'd expose a C# function which would act as a business objective. So that would be a single function per business objective. So if I'm trying to predict churn, if I'm trying to predict whether or not somebody's committing fraud, they'd be two separate objectives, they'd be two separate, two separate functions. But each one of those might have multiple models that are leading to my outcome. So we have this service bus layer. So every time that message is being called, and the beauty of Azure Functions is it's all load balanced and all lovely. So as our sort of usage scales up, we know that we're still going to be good. It should scale with the demand of our service. So again, sort of this architecture is quite helpful in that if we're just doing sort of a proof of concept and we've got a handful of people looking at it, cool, okay, that works. That's going to work for that. And then when it starts to scale, we don't need to necessarily start worrying about adding more resources to this. It should start scaling with our demand. And so we can do that all through a lot of the stuff that Ben was talking about. So what we're looking at doing here is we're taking Docker. So we're using Docker to package up our code. So as Ben said, that could be Python. But that could also be R. That could be a piece of R running on our Docker container. That could be, that could be a Julia script. That could be anything. That could be some PyTorch. That could be a TensorFlow.
And we've already seen the Kubernetes logo and the Docker logo earlier on today. So hopefully everybody was watching that session. We don't need to go through that again.
No. So Kubernetes is great, and getting Kubernetes set up isn't necessarily the easiest thing to do. It's quite tricky. There's a lot of stuff that happens to get that up and running. But I believe last night, AKS, the Azure Container Instance Service, which is a almost platform as a service version of Kubernetes, went into general availability, which did throw me a little bit when I was trying to have a look at some stuff last night, and all the logos had changed and the setup process had changed. But that's the beauty of the fast-moving nature of Azure. So with Kubernetes and with Docker, we're able to package up our models into a Docker container and deploy that into Kubernetes, so that when our models do increase in demand, we can sort of start seeing, okay, well, as that model is increasing, we can add more compute to our Kubernetes cluster, and we can set it so that it scales with us. And the sort of process of monitoring a service queue to monitoring a service bus, we had to add a little bit of Java in there, just some way that it could interact with it.
Right.
And what that sort of gives you, that Java interface, enables you then to have very generic Docker containers.
Yeah.
So you've almost just got a standard in and standard out. And that standard out is saying, okay, well, I'm going to go away and run a bash file. And that bash file may say, so slightly different to how Ben had his set up. So his Docker image would run the Python itself.
Yes.
This Docker image would run the Java, and that Java would just poke a bash script, which would then say, run me my model.py or something like that.
Yep, gotcha.
Which that could be then actually run my model, my R model, my Julia model, my whatever language you're using.
Yep.
And that could even be something like a Spark model, now that you can run Spark in containers. So once we have all of those results, and all those results are going back, then we have this sort of rendezvous service again. And all of this is contained in its own function. So the start of the function sets all this up, pushes off a message, each one of these right back to another queue, and we can build in our own policies to sort of start aggregating that data.
So this rendezvous service, what bit of Azure is that using, Terry?
So that's using functions again.
Right, okay.
So I've got a better picture in a moment which tries to sort of show the sort of process flow. And yeah, then we've got the decoy up there as well. So as our requests are coming in, whatever format that in, however that works, we can log that off into something like Cosmos DB.
Right.
Benefit of Cosmos DB, if our input is JSON, then we can just log that off in the format that it comes in.
More on Cosmos DB later. Shameless plug there, Alan Mitchell.
So we don't have to worry about, if it's going into, say, a SQL database, you don't need to worry about the schema and those sorts of things. We can just push it off there. So that goes into our rendezvous service and allows us to select which model we may want to actually use. Okay. And then it goes back to our user.
Yep.
And that all happens as one succinct process. But so how that sort of looks in a function way to bring out some probably not massively accurate UML diagrams. It's been a while since I had to write UML. But you can see the sort of process flow of a user making a request and it kicking off a function, going into a message topic queue, having Docker and all of its models just run and kick off in parallel, producing all of their scores, and dependent on our sort of what our function is, what our policy is, then we can go about deciding which model it is that we actually want to use.
I think that's a super simple diagram. I really thank you for doing that for us.
No worries.
It explains it really well.
And the benefit, I think, that you can sort of hopefully see from this diagram is all of those steps there. The total latency that we have is from that user making a request to that response going back. Each of those models, may happen in their own time, but we're just selecting whichever model we want. And so to distill that problem of operations versus the data scientists, they're really going to be interested in latency. What's the effect of this model against my production services? If you have monitoring and you have model management and you have all of this stuff working, then they are hopefully going to be slightly more appeased based on that they have that sort of operational statistics.
Yeah. And it's obviously there's a cost associated with the compute in Azure, and indeed that's fundamentally the unit or how we charge for services. So, so there may be an efficiency element to some of this as well.
Well, yeah, exactly. If you've got a server running 24/7, running your models, then this is on demand. If you've got a peak during the day that you have lots of requests, and then that just completely dies overnight, you're not paying for that service to be scaled up. On the off chance that somebody might use it, this comes up when it needs to, and it goes away when it's not used. So yeah, exactly. Hopefully that will help. So I guess, looking at what Ben's spoken about, talking about Docker, Kubernetes, and a few other tools, do my data science team actually have to go away and learn all of this? That's an awful lot. Do I need to go away and learn Java, Docker, Kubernetes, and all this stuff? I've just spent 7 years doing my PhD, and I've got a good grasp of data science and all these other things, and it's like, well, now do I need to go away and learn and be an engineer as well? And hopefully no, hopefully not. So there are things that Ben was talking about, and there's a sort of core concept of data ops.
Yeah.
trying to, so also the work that I do with customers is trying to strip away the need for them to have almost like a wider engineering team and just focus on their data scientists. So they focus on what they're doing, and the engineering is all handled through things like data ops, through continuous integration, continuous deployment. They focus on their code, they commit their code to source control, and the rest just gets built for them.
Fantastic. Yeah, so Terry, that is great because we can get everybody to still stay in the world that they're currently used to, and it's nice to see this. I was doing something quite similar to this last week. Same meat, different gravy. I was using Visual Studio to do continuous deployment. Git, we should probably mention, that new shiny thing. And we were using Docker, we were using Kubernetes, and we were able to do that in just a couple of, well, like 5 days from a blank piece of paper, and the data science team never having seen any of this before.
Yeah.
They just had their models they wanted to deploy.
Yeah, exactly. I think that's fantastic. The services are all available in VSTS as well. So all the stuff that's happening here, it's not a whole load of custom scripts I've had to write. There's a whole load of stuff happening here from that image going into Git, into source control, going all the way through and then being deployed into that service. So then they just write their code, commit it, it spins up and it becomes part of a service. And that's sort of what we've always tried to get to avoid really having to get people to learn all of this.
Terry, thank you for sharing us. And I clearly are the master of data ops.
No, well, thanks very much. I'm very grateful to be here. My contact details are up there. If anyone does want to get in touch, then just please do give me a shout.
Well, we're going to drag you onto the couch now after the break.
I'm the CVP for customer service and support at Microsoft. Microsoft CSS is actually a very large organization, and we're a major contributor, I believe, to protecting Microsoft's brand, because we play a big part in whether customers feel good or not about their experience with Microsoft products. If we look at something like this artificial intelligence technology, that it isn't just about a virtual agent that interacts with the customer. It's also a tool that will enable our agents to provide a better experience to customers once they do engage with us. And for all the support leaders out there, in the world, all you have to do is consider the cost of an incident, whether that incident is 15 minutes, whether it's 1 hour. We all know what our costs are per incident. This is significant in terms of the millions of dollars that it will take out of our business and enable us to reinvest in either developing further products or higher level services for our customers. So our opportunity to serve our customers is vast, and our opportunity to make a difference in how we serve those customers with the different technology that's becoming available to us is really exciting for us.
Well, that was great. We're now back at speaking with Terry and Andrew, Mr. Data Ops Guru Master. What was the designation you gave him?
Well, I thought Master of Data Ops. Is that
Master of Data Ops? Okay, that's going to be Terry's designation from now on. That was really interesting, and I really liked what you were kind of talking about, how to use the multiple models together. But it made me think about what are kind of the ethical implications with these model choices. Like, can you take the ethics into account into either what model is chosen or how you rate accuracy and success of a model when you're kind of doing these tests?
Yeah, I mean, accuracy and sort of, ethics in what we do in data science in general always needs to be almost at the forefront of what we're doing. So there's been, loads of stuff around looking at. There was a big piece a couple of weeks ago about it's almost similar thing to what I was talking about, which flavor of websites people are shown to sort of optimize the most that they'll spend with you. And there's a very thin line there, especially with ethics. I think as data scientists, we definitely need to be fully aware of it, and we need to make sure that what we're doing is both ethical and that we are making a conscious effort to definitely ensure that what we're doing is the best for everyone, and not necessarily ending up with the sort of scenario that Cambridge Analytica ended up in.
Right.
And yeah, all of the nastiness involved with that.
When it comes to machine learning models in general, what's your biggest worry? Is there anything that kind of keeps you awake at night? Is it ethics? Is it human involvement? You know, is it privacy and security? Again, kind of going back to the Cambridge Analytica thing. Is it, you know, being aware of inclusiveness? Is there anything about this that kind of keeps you awake at night, that kind of gives you pause?
I don't think anything keeps me awake necessarily, but it does definitely drive me to get up in the morning. You know, there's so much change happening, and there's so many new tech, there's so many, you know, new advances around what people are doing with neural nets. You know, it's such a really interesting like arena to be working in. On a daily basis, you know, things are changing, there's new publications, all of that stuff is, you know, is particularly fantastic. So very fast moving, you know, you look at how much talking about things like Kubernetes have really changed almost just in the last 6 months, how the software industry works, and in particular, you know, how we're working as deploying stuff, data science models as well. Yeah, that stuff is fantastic.
You got into this at the end of your conversation. I was really glad that you touched on it. You were kind of trying to say, you know, how much, if you're a data scientist, how much of this DevOps stuff do you really need to know? And you were saying, you know, not that much. But I mean, but really, like, how? But you do feel confident that you do need to have a little bit of a basis there. That's now kind of going to become part of the job description.
Yeah, I think it is. It definitely has to become a part. There's been lots of talk recently around the emergence of a sort of term of a machine learning engineer, somebody who's, you know, who has that software background and has that data science background and can talk to both camps and becomes part of a team. So it's not necessarily that everybody needs to have those skills, but you might need somebody on that team who is that sort of data ops, that master of data ops, who is able to talk to both sides.
To be the translator, so to speak.
Yeah, exactly. Who knows how to deploy models, you know. So Kubernetes and Docker might work for some scenarios, but for large batch operations, that might not be the best way. And they need to know almost a good amount of engineering and a good amount of data science, but maybe not too advanced in either one, just enough. And I think it's an interesting one as well. There's sort of that data scientist, machine learning engineer, and I almost think in the next sort of 12 months we might start seeing the rise of a sort of job around model managers as well. Somebody who's just employed to ensure that the models that we have in production are actually doing what we expect. So that process of handling a single request off to 6 different models, we almost want somebody to be monitoring that, somebody to be understanding, are they going into the right places? If we're doing reinforcement learning and actually deciding which models they should go to, is that the right option? And then also they can help getting models into production as well and thinking about that best way. So it's a sort of merging of multiple things and always adding to the data science unicorn, you know, we always get stuck with.
Right. Well, and that actually, you kind of bring up a good point, kind of trying to figure out what those things are doing and how deeply they're going into things, is how do you retire a model? You know, is it deleted? Is it removed from production? Like, could there ever be an AI that could even kind of go through and figure out all the non-active models?
Well, I'm going to take that one too.
Yeah, of course.
Because I think one of the things you touched on there was ethics. That, for me, is a lot around audit and accountability. So if you want to go back and replay in time, say you're providing a financial service and you're approving a loan application, something like that, the Financial Conduct Authority, or whatever the agency is in the country you operate in, is probably you're going to be able to replay that decision. So you're going to need you showed how the data was being hived off.
Yeah.
Well, you want that old model. Now, it may not be active, but you should be able to replay that model and show how that worked, and somebody can pick it apart. You know, here's the code. This is what it did, and we can either demonstrate the presence or lack of bias accordingly to what we've done. So
that's a really good point. I hadn't even thought of that.
Transparency there is a super useful thing, I think, and this gives us that, which is why I'm really excited about it.
And I guess that problem starts getting even harder when you start looking at neural nets, you know, and they are to some extent almost black boxes when you get to some point, and having that accountability and that ethical, being able to say, okay, well, how did you come to that decision? So especially anything that actually has an impact. So again, if it is something like a loan application, being able to accurately say why somebody was refused a loan application, that might have massive impacts on, you know, on their home life. We need to be able to say with confidence how that happens.
But I also think it's super important the data scientists there are thinking about the bias that goes into those models.
Yes.
So even though you might end up with a situation where a particular thing might predict the outcome really well, you might choose to exclude that feature for ethical reasons. And we can all think about what they are. I don't think we need to name them here. But I did some work where postcode turned up to be a key feature. Now, that's not necessarily ethical or unethical, but it certainly makes something personally identifiable.
Right.
So what we then did is we started to actually look at the statistics around census information in that area. For example, if you're in the insurance industry, you might be interested in rates of crime. You might be interested in demographics, so you'd translate that feature into something else. And then knowing what you're just passing a crime rate into a model, then you aren't aware of where the person is in the model itself. So I think there's a lot we can do with engineering, but it's still going to come down to people.
Yeah.
Great points. And I guess my final question would be, as these models become more intelligent, do you ever see them granted citizen status? That's from Andrew, by the way.
I think there's always this ongoing sort of debate between, like AI is probably an awful term and a term that we should just try and, get away from, because AI has all those negative connotations of Arnold Schwarzenegger and Terminator and all that sort of Skynet problems. And whether or not we'd ever get to that kind of, that singularity, that point where...
Wherever in the Matrix.
Exactly. Probably not. I think we may be that, AI really is, it's an information decision maker. It's a smart decision maker. So yeah, maybe we won't get there.
Okay. Well, now for now, I'm feeling more confident. Thank you so much, Terry. And we're going to take a 10-minute break, and so check out more from Emily around London Tech Week. And at 12:10, we'll be back with Luke from the Ordnance Survey team. So don't go away.
Can you tell me who you are and what are you doing here?
Yes, hi, my name's Hilary Sutcliffe. I run a not-for-profit called Society Inside, and that's sort of riff on Intel Inside, the idea being that people and planet will be at the heart of innovation instead of just money and scientific kudos.
Perfect. And in terms of technology that's influenced you or had an impact on your life in the past 5 years, what would you say that is?
Well, I work across technologies. So in fact, even the last sort of 5 years, I've worked on nanotech stuff. I'm on the synthetic biology governance group, looking at gene editing, gene drives. I looked at responsible robotics, AI, and I was recently on the quantum dialogue for the UK. So actually, the point for me is the lessons from all the technologies that we can learn, which is mainly about the nature of human nature, funnily enough, not the technologies.
Perfect. And finally, in terms of the next 12 months going forward, what piece of technology or area of technology are you really looking forward to coming out or seeing more of?
Well, it's interesting looking at AI because actually it is going to be AI, but AI needs to learn the lessons of everybody else's tech, because if AI is everything from pattern recognition to the singularity, how are we as society going to even know what it is and what to do with it and how to use it and how not to use it? So I think it's going to be AI, but I think AI needs to get its act together to really do what it can do for us and what we're worried about and what we're not worried about. And so I'm hoping you guys will help us out with that.
Pleasure to be here, thank you. Today I'm actually a panelist on the panel about non-fungible tokens. I'm the CEO founder of ZeroXCert. We're actually the first open protocol built to support the non-fungible tokens. We think this is the future of blockchain. And yeah, so really looking forward to it. We have some exciting speakers on the panel. Chris Berniske is there as well. So that's awesome.
Perfect. And in terms of technology, I think I might know the answer, but technology that's changed kind of your life in the past 5 years, what would you say that is?
Yeah, definitely blockchain. You knew that. I think that, the value that blockchain provides in terms of just in the financial sector alone is immense. Now what we're doing with our technology specifically is we're trying to move that to the real life use cases as well. Tokenizing anything that is unique out there, bringing that ownership in that token and allowing people to actually store digital products in their wallets as well. So that's kind of the thing that we're doing and where we see the future is headed. But yeah, we'll see. But blockchain definitely, I think, in all ways.
Perfect. And in the next sort of 12 months or going forward, what would you say a bit of technology that you're really looking forward to seeing might be?
Definitely, I think there's going to be a lot of improvements and a lot of going forward in the AI world. I think that's why it's also great to be here. But in terms of blockchain, which is my space, I think security tokens and non-fungible tokens are going to spearhead the next 12 months for sure.
Perfect. Thank you very much.
Thank you.
Hi, Kim. Please could you tell us a little bit about yourself and what you're doing here today?
Sure. My name is Kim Nilsson. I'm the CEO and founder of Pivigo, the data science hub. And we are here, we are expoing. I am speaking tomorrow at a panel, and also we're running a workshop and trying to support companies getting started with data science projects.
Perfect. In terms of technology that's kind of influenced you in the past 5 years, what would you say the number one area of technology would be?
Oh, that's a good question. I mean, obviously, we're a data science company, and so what we're really excited about is machine learning and how we can predict the future with it, and all the potential impact that will have on our lives, on how we work, how we stay healthy, how we live, how we have fun.
Perfect. And in terms of the next sort of 12 months and going forward, what area of technology are you really looking forward to seeing?
Well, I'm very excited about how AI might impact healthcare and how we can actually maybe predict illnesses beforehand, or actually speed up diagnosis, speed up how we can become healthier individuals, and that's a really important topic.
Hi, Danny. Please can you tell us a bit about what you're doing here today and what you're looking forward to seeing?
Sure. So my name is Danny Giller. I work with Autodesk. I'm the head of global diversity and inclusion. And for me, what I look for are ways where I can apply things orthogonally. So I prefer to go to non-diversity conferences to see how things I can learn might apply to and be relevant in the area of diversity and inclusion.
Awesome. So in terms of technology, what's the biggest piece of technology that's had a largest impact on your life in the past sort of 5 years?
That's a really challenging question. I'd still say, on my life personally, I'd probably still say social media. And I know that's not a dramatic technological change. I think there are other things that I'm not seeing because there are heavy technological tailwinds in terms of artificial intelligence, cloud, and things like that are impacting a lot of these technologies. But in terms of from a direct consumer standpoint, I would still say social media has a much more significant impact on both things in the workplace as well as personally than I think I could have imagined even 5 years ago.
Perfect. And finally, in terms of the next 12 months, what are you most looking forward to seeing?
What I'm most looking forward to seeing in the next 12 months is organizations and people that are doing artificial intelligence and using it, really starting to think proactively about diversity and inclusion, how to make it a part of what they do in terms of the people that are involved, in terms of how they train AI systems, and in terms of how they think about their customer base. I think if they can do that, they can really have a chance to influence inclusion in a very proactive way.
We have so many people who are non-verbal, but still have so much to say.
I want the exact same information that my hearing friends have.
There are barriers to communication everywhere, but I think it's time we look at the barriers as opportunities to reach out to everyone.
Soundscape fills in a lot of the mental map as you move.
Approaching intersection.
You can just put it in your pocket and go.
With ALS, you become locked in. But we see technology as a way to give back what ALS has taken away.
There's no better feeling than to hear a child say something that they've wanted to say and the look on their face after they've been able to say it.
When it's reading, I see spaces between the words, and it's easy to focus on.
Anjay realized that here was something that could change his life.
Now that I have my phone, I can see exactly what was said, and that's been a huge help to me.
The system is learning as it goes, and the accuracy has improved tremendously.
Students can pick any language that they choose to receive the information. It's like we jumped into the future.
Because communication is very important for all of us, and we just want to be together and not feel left out.
Aider les personnes avec autisme à communiquer, il y a des images.
Je parle, je donne une information à Arthur et elle est traduite par l'application El Picto instantanément en pictogramme et après d'une façon orale.
Va t'habiller et te brosser les dents.
On va pouvoir remettre en place une communication qui est plus spontanée. Je crois que ça aide à recréer du lien.
Both my wife and I are totally blind, and we have a 3-year-old son that's in preschool. He can see, but his parents can't. So to be able to know what's going on at his school is everything. The Seeing AI app has the ability to allow me access to the visual world. Artificial intelligence is beginning to have an impact on the lives of people with disabilities, but it's only going to grow. There is still so much out there to be done.
Hey, welcome back to Tech Days Online this afternoon. We've got a team of Ordnance Survey's research scientists joining us. My name's Luke Binton. I've been working with Microsoft with them on their data architecture. So they're doing amazing things with neural networks, and I've been helping them to keep calm and put it on Azure. So before we go into the clever stuff that they've been doing in a bit of detail, let's imagine some scenarios where the work they're doing will help society. So they're working with data that will enable people like the emergency services, if they have an emergency on a campus, to find exact locations, like the exact entrance to a building and things like that, that you'll need to get to deal with the emergency using machine learning techniques. So imagine if some other scenarios as well. So what were we talking about?
Yeah, so another one we've got is about roof type. So we can attribute what kind of roofs people have. We can start looking at whether there's solar panel placement. Perhaps in the future people want to use their roofs to extend upon or to do urban farming. So there's a use case there in sort of future-proofing our society and understanding more about where we live and providing more data.
Yeah. We had an amazing conversation the other week about imagine if the airspace is regulated for the use of drones and you need to understand how the roof landscape over, say, London is working and where you can land those drones for delivery people like Amazon. So amazing use cases from Ordnance Survey's use of data. So before we do a deep dive into that, let's crack into a bit of a background about Ordnance Survey and why are they doing these things. So Izzy, do you want to tell us about that? I thought Ordnance Survey just did maps and they've been around a while.
Just the paper maps. No, actually, we produce quite a lot of digital products. I'm going to refer to a screen over here that shows them. One of the products we use only internally is a digital surface model, but that will reference in a little while. And that shows the height of objects on the ground, vegetation and buildings, as well as the surface of the ground where it's exposed. Other products include imagery data that people can use as a backdrop mapping, topographic data, which we're definitely going to refer to a lot in this talk, as well as producing heights for individual items within the topographic data. Any more? Oh yes, and occasionally on the next one we show some bespoke products. This was for a particular government agency showing where there are hedges. So we do a number of different types of products for different uses, all obviously in the geospatial domain.
Marvellous. So we thought we'd have a little quiz about some... Oh wait, we got this bit as well about how you're getting the information.
That's true, actually. A lot of the data is captured using field survey, but even more now is being captured using aerial imagery. We fly for many months of the year, capturing, I think it's 100,000 kilometres of imagery, which has been described a bit like a fire hose of data. Yeah. We have a lot of surveyors who are able to interpret those data, but there's probably plenty more information in them that we aren't actually getting out. So that's one issue that we have. We have a massive body of data that we're not getting everything out of.
It's simply too much for manual consumption.
Yeah, absolutely, absolutely. I mean, we're doing very well, but there's plenty more. We have a second issue, and that is our customers are very keen to have particular new bespoke products. They want to have those produced much more rapidly, and so we really need to be able to work much faster in order to produce the data that our customers want.
Okay, cool.
Now the quiz.
So yeah, we thought we would have a little quiz called I Spy with My Little AI, which kind of describes the challenges that you have to deal with your data. So do you want to be our host for I Spy with My Little AI?
Well, we've just lost Karis, which is brilliant. She's the person who's most trained in interpreting these images. So I'm going to ask you, Luke.
All right,
what can you see in this
So what can
image?
I see in this picture? So are they sheep on the right? Is that sheep?
No.
No?
Guess again.
Are they bits of sand? Is it a golf course?
It is a golf course, that's right. And what else can you see in that image?
I can see a bit of an urban area and a bit of a forested area or woodland area.
Can you describe the urban area a little bit? Tell us what you think it is.
It's got some terraced houses in it.
Brilliant. Yeah, very good, very good. Do you want to look at another?
Yeah, let's do that. So, oh, blimey. So, what's that at the bottom? Is it like a docklands or is it like a warehouse area?
I'd go with the docklands, yes. Yeah.
And then we've got other stuff going on there. Like we've got a railway, we've got a motorway, is it? Stuff like that?
Technically just a dual carriageway.
Oh, how do you know?
Because if that's the Southampton container port, then that's the Redbridge flyover.
She's got ground knowledge.
Oh, wow.
And therefore it's...
These guys really know their data. If it's just after Watershed, there's some pictures of route bits of the UK we could show as well. But we're not after Watershed.
Naughty place names as well.
Should we do one more?
Yeah, one more.
Yeah.
Okay, so what is that, a sports ground?
Up in the middle at the top, yes. What sort of sports ground?
I don't know, it looks like it's got a tennis court. Is it a school? What is it?
It is a school, it is school, and yes. Can you tell me anything about the housing around? Because you can see different patterns of housing.
Yeah, so I guess we've got a very urban area, so close together terrace houses, and then we've got a bit more sparse houses as well, maybe?
Yeah. So you can interpret those as potentially different areas with different affluence, perhaps, different prices of housing, something like that.
Wow, right.
Should we move on?
Yeah, let's move on. So that's it for I Spy My Little AI. So why are we doing I Spy with My Little AI, Izzy?
A demonstration that we have an idea that the landscape is an encoding of natural processes and human activity. And it's kind of encoded within the patterns of the landscape. And as humans, we can interpret it. Some people are trained in doing that, but even when you're not particularly trained, you can still start seeing those patterns. And this is what we want to really try to start drawing out of this kind of hose pipe of fire hose of data, really. So our research is around trying to use those data, and we have a particular kind of concept that we're working with. Here we go. Thank you. Taking us from the idea of an encoded landscape, which we're then sensing to produce the imagery, although ultimately we might use different sensors than image sensors. And then what our particular aspect is how can we decode those data to create descriptors of the landscape. And finally, once we've got those descriptors, we want to use those we've got two different goals. One is inference and one's discovery, and I think Olivia's going to talk about that in a little while. And it's really, really important that we say that we're working on this in Ordnance Survey, but it really comes off the back of some joint collaboration that we've done at the University of Southampton and at Lancaster University, and we're still working with them on this.
Yeah, you have brilliant minds collaborating with you, don't you?
Yeah, it's fantastic.
Yeah. Okay, cool. So shall we have a little dip into your work with TopoNet, which is your neural network for understanding the world around you?
Mm-hmm.
So we've called it a dip and not a deep dive. We've only got, what is it, an hour or so?
Yeah.
So we could go on for days about this. So shall we start with this little animation slide here that kind of, at high level, explains TopoNet and what you're doing?
Yes, so on the left here we've got our imagery, and what we've been using in terms of machine learning is the deep convolutional neural networks. And basically what you've got on the left here is our input, the imagery going in, and then we're training against our master map topographic layer, which is our data telling you whether it's bare earth or grass, whether it's sea, whether it's buildings. If you go on to the next slide, what we've done so far is using ImageNet weights with our own data, going through and training it again against using the ImageNet weights as an initialization step, yep. And getting results like that. We've used fine-tuned weights, which was starting with ImageNet weights. Oh, yes. Okay, ImageNet weights. Initially, we trained with the ImageNet stuff, and then we put our own data through as the inference step at the end. The fine-tuned, we ended up doing ImageNet weights initialization and then putting our data through. And then finally, what we did is scratch trained a network with our own data, random initialization, and we've been comparing the results.
Yep. It's been a really interesting journey, hasn't it? So we'll go into a bit of detail about a hack we did together earlier, last November. That was using transfer learning and some out-the-box kind of ImageNet data sets and so forth. But I guess it's been really fascinating from my perspective to see how you've started there, but then moved on understanding these deep characteristics of these neural networks that are trained for things like detecting what a dog is classically and stuff like that, and how you found them to be quite different to the sorts of things you need to study, like, hey, is this a high-class urban area, or should I be moving away from here, or something like that? So, cool. So, so do you want to talk a bit about the component parts of that pipeline in terms of training and inference?
So in terms of the data, we have we send through patches of our data. They're 224 pixels square, and we send through all sorts of different classes from our TopoNet. At the moment, we're sending through about 13, which include things like water, vegetation, solar panels, and these go through into our model. If you could go on to the next slide, then we, you can see that see there at the top we've got container ports, we've got parts of the Solent probably, cruise ship in the bottom right,
classified as water.
Classified as water, of course. This then goes into our model. We've been using ResNet 50 at the moment, and we've been putting this into Python using the Keras library, which makes it so easy, just trying to get everything working together. Yep. The ResNet has had very good results on the ImageNet challenge. However, it's a bit of a mixed bag with our data. Yep. Completely different problem space. We've often said in ImageNet, what you're looking at is some sort of classification of you've got a picture of a dog and then you've got background. Yep. What have you got when you've got an aerial image? Everything is background. Yep. So,
so you guys were just on that, like, so from my less experienced deep learning experience, you're talking about how that influences the design of, say, final layers, because you're looking at kind of smaller things with different characteristics, say, to identify a dog, versus if you want to make a more generalized understanding of an environment, maybe, like, is it sea? That's a very different sort of problem to identifying and classifying, like a dog or an octopus or something, isn't it?
And earlier on in the network, you're finding very simple things like lines and very simple shapes, but by the end of the network, you're hoping that the things that it is learning is more like, are you finding tennis courts? Are you finding 1920s housing estates?
Awesome. So I found some of the things that so what's the next bit do you want to talk about here in terms of our slides? Do you want to talk about features?
So this is the data that we've sent through a trained model, and basically what the weights are focusing on. So these are the images with the highest activation out of a trained model. And you can see in the top left, you've kind of got just grass, but you've also got some building types, and these are, I think these are clustered.
These ones, I think, might be from the ImageNet weights, straight up.
Yes.
So this is before we did any fine-tuning and scratch training, and that's why they're a little bit more jumbled than you might see in a minute.
In a minute.
Shall we skip ahead? Yeah, that's great. So this is very interesting as well.
Yes, this is looking at each layer of the model that we did, which was ResNet 50, as I said, and looking at the accuracy of the features that are created at each level. So, given those features, what was the resulting accuracy for a classification purpose? As you can see, it's fairly poor in the first instance, but then it tends to get more stable over time, and you can see that definitely the variation is shrinking by the time you've got to the end of the network, or the epoch that we've chosen to stop at.
So do these sorts of studies into how the neural network's working at various layers of depth influence your architectural designs or directions with your ambitions to understand the world around you with TopoNet and so forth?
That's a good question, because we have a lot of discussion about our architectural choices. We've been working with ResNet 50 with 50 layers most recently, but we're wondering today if actually we need to reduce the number of layers or use a different architecture. So this kind of approach is going to give us information towards that, definitely.
And certainly in the number of epochs that we end up doing, because of how well the accuracy converges.
Yeah. Cool. So, and do you want to talk about this slide as well?
Yes, this is our latest inference, apparently. Inference. So we've created an initial TopoNet using a very large number of patches for training. I think we did the number of ImageNet patches, which was something like 1.2 million. Took a couple of weeks to run, but here we've got the test accuracy on the final output of the model. So as you can see, we're not getting brilliant results at the moment with 0.45. It's probably overfitting on the data, because the training accuracy by this point was 0.94. But it's a good start in that we can see that it's still going up and it's not plateauing yet. Yep. And the training just needs to continue, and we're going to be working further on it.
Okay, cool. Now this one is hello. So we got, I think, on this pipeline, one last really quite interesting slide.
Yes, so rather than doing a supervised learning, we've also done some unsupervised learning on using the TSNE clustering method. And as you can see from the image, we've got and you can see that things are very similar in the different clusters that you can kind of draw lines between. And on the right, so you've got each of the images and where they are in that feature space. And then on the left, you have the groups on the pixels where they were. So basically, whether it was in a class on the right-hand side, and making sure that it's in that sort of, basically it's just showing the classes on the right-hand side, but obviously you can see that it's clustering in certain areas. You can see certain shapes starting to form. Yes, it's very interesting.
I mean, I guess I'm familiar with techniques with neural networks to start with labeled training sets and knowing what sort of questions you want to ask it. So I found this approach really interesting, that actually you're taking the outputs from some layers of a neural network, applying some analysis and clustering techniques then to understand actually what is it finding for itself. Is there any further use you can get out of it? And in that picture there were some really interesting generalizations, like this is an urban area, this is like a watery area. So it's just fascinating that it's figuring this stuff out for itself, and actually it can tell you something, and maybe you can get to a stage where it's answering questions you didn't even know you wanted to ask.
And we don't know what's going to come out at this other end, so you could end up with things like Victorian housing estates being clustered together, and that's have use cases for. But instead of training a model purely to find Victorian housing estates, why don't we see what is actually existent in our landscape already and pull it out organically, almost from the data? What's already there for us to pick off quickly?
Because that's what we haven't mentioned, is that we've been training this TopoNet, which isn't just to do inference, it's also to do the discovery of taking this as a feature map and then using it to train other things. So, so coming back to the you want to find your 1920s housing estate. What do you use? Do you scratch train? No, you run it initially through this TopoNet, train it against a linear SVM, using a small sample data set, and hopefully that would give you better results than trying to knock something else up very, very quickly.
Yeah. So it's fascinating research, really. So Karis was the pun master at Ordnance Survey, and we have a little section here called "Noding Me, Noding You."
Yeah. So this is just a quick introductory slide, just to show you some of the things that are happening within our network. So it's great when you train a deep learning model and out the other side you get the labels that you wanted on your data. That's fantastic, and it's one of the goals that we're after, but it's actually not our main goal. Our main goal is, as you said, doing this discovery of new things. And one method we have of doing that is looking at the representations within the network itself. So here you can see some grids. I've looked at a lot of these grids. I think there's about 2,500 that come out of every trained network. So you start seeing in like fly vision for weeks afterwards after analysing this. So what it's showing you is a single filter within the network. So in ResNet 50, in the very early layers, which you're seeing here, there's 64 filters for one layer. So I've just picked 3 random filters. And on the left, you can see what a certain filter saw at ImageNet weights and which of the 16 images it found most interesting. So that filter in ImageNet is looking for sort of black things with a white line across it. Then you can see in the next one along, that's our, these are later in the network now. So the ImageNet weights on the left, that's when you pass through our imagery, through ImageNet weights, what does that filter find the most exciting? So you've got black cars, and then the bottom one, you can see there's trees and shadows. So then you can see the fine-tune weights in the center, and on the far right, you can see what ImageNet's looking for with ImageNet images. So what you're actually finding is it's not a black car finder, it's a bird eye finder, and that's the closest thing that it could find in our aerial imagery to a bird's eye. But that's okay, because it's still an interesting, useful representation within our network. And what you're not seeing here is the scratch-trained weights, which I'll show you in a second, but the one on the bottom is quite good as well. So that's birds' feathers is what ImageNet is actually looking for. And that's turned out as being shadows and trees in our data. So it's still pulling out these representations. But what we wanted to find out is when we scratch-trained, instead of just getting ImageNet derivatives, can we get something that is, you know, Ordnance Survey, GB Britain, geography as filters? So this is a little bit of a strange one. So we found through the network, after we had fine-tuned it, that actually we ended up getting a lot of blank nodes. Now this goes back to the question of whether we should be using ResNet for our file model, because blank nodes really aren't finding much for us. Now some would argue that on the left there is from the fine-tuned weights and on the right is from ImageNet weights. Some would argue that they're color nodes, they're trying to find colors.
But when you scroll through the folder, there's quite a few of these at the later layers. So we think in discussions that perhaps we've gone too deep, or perhaps when you fine-tune, some filters never get a useful representation for your data. For instance, if there was something that was trying to find Labrador's ears, and there's nothing that looks like that in our data at all, unlike the bird's eyes that we saw before, then it's just going to show you blank pictures, which is the closest thing it could get, which is nothing. Yep. So it's one reason why we moved away from fine-tuning and we started to go into Scratch training. And it's something that we need to check with our Scratch chained weights to make sure this isn't happening. And if it is, it might be an indication to us that it's still too deep for what we're trying to do, and maybe a different approach would be better. So I think in the next slide, we've got why all this matters. So it's interesting, right? I mean, they're fun pictures to look at and they're colourful and everyone likes a colourful picture. But what we're trying to do with these is use these filters and harness them to try and build new feature extractors for us. So we're using TopoNet, which is used to seeing aerial imagery, trained from scratch, all these filters that may have things like grass and tennis courts and road lines, car parks, hipped roofs. And can we then train a linear SVM to then start pulling out these things for us? Because going through them manually, although interesting, is painful. So if you, on the next slide, what I'm trying to describe here is on the left, you can see our topography. And we trained the neural network on a basic version of our topography. So that center polygon that I've zoomed in on there is being sent through the network as made sealed surface, because that's what it is, and that was our basic rendition of it. But when it's actually looking at the image patch, which it's training itself against, it's not just seeing a made sealed surface, it's seeing all these tennis court lines, and it's learning so much more. It's starting to learn a pattern, and perhaps when we look within our Scratch trained weights, we'll find a filter which is just full of tennis courts. And then we've got a tennis court finder. And it's worth saying as a quick aside before I get sacked that we do already record tennis courts in our data, but it was just a quick example. In the next one, you can see some roads. So on the left, we would have trained it on our topography. It would have been a made sealed surface of a road. But on the right, when you look at that, you can see white lines going up and down it. You can see pavements. In some of our imagery, you can see drains. You can see people's driveways, whether they're made sealed, whether they've got cobblestones, whether they've got grass in their front garden. So these are all patterns which the network is learning. And then at the end, it's only because of my fault as a data scientist that I've asked it to just diverge it back to made sealed surface or road again. So what we're doing is using those nodes through the linear SVM. Now, the way this works is we run through a load of images of something we're trying to find. So let's say playgrounds. Now, if we wanted to train a network from scratch to find playgrounds and not playgrounds, you'd need thousands of labeled as examples, probably tens of thousands, most people say, especially if you're training from scratch. And even if you're fine-tuning, it's going to be in the really, really high numbers. So what we can do is we can send through 100 images of a playground, little patches, through TopoNet. And instead of asking for the classification at the bottom, which we don't care about, it'll probably come out as made sealed surface, because that's probably, or maybe that's a bit dangerous for children. Unsealed surface, comfy surface.
Man-made surface.
Yes, man-made surface. Instead of asking for that classification, which is not what we're after, we've got a bit of code that will write out the activations for every filter at every layer. So if filter 10 and 50 and 66 in layer 4 all ended up being playground filters that are looking for playgroundy things, if they have a really high activation when they see our image and some other ones don't, they have low activations, we can feed that into the linear SVM, which is just learning from the numerical data, the activation data, and it can start to detect which ones are playgrounds and not. So I believe we did 100 playground and 100 not playground, stuck them through the TopoNet, got the layer classifications out, and in the next slide you can see some of our results from that. Oh no, next one.
Next one.
Yeah, so we got 90% sticking it through our linear SVM, and this was on one of our, I think it was the fine-tuned weights and also the first attempt at Scratch tuned weights.
So that was a really almost low energy way for us to then start pulling things out. We already have a product which is OS Greenspace, which shows where all the playgrounds are. But for update, it has to be done manually at the moment. We're manually updating all our data, and this is a way for us to automatically start to do that and pull these things out. If you just go back one as well, these are the fun ones that I quickly pulled out from our Scratch Train network, because as I said, it was only last week that it finished. So you can see in the top, I think that's water. We've got some white bands. In the centre, you can see roads, and all of them have pavements and curbs. You've got red things in the bottom with the cars. In the centre bottom, those are all roofs. And in the middle right, I think those are all hipped roofs as well. So you can see that going from scratch, we're already finding filters which are straight up finding these patterns, and all you need is a way to decode that. And manually we can PM is our shortcut into what these activations can show us. So I think the final one I had was just a bit of inland water on the next one, where we just did a quick, very pixelized output of the inland water. So I think we reduced it to 32 by 32 pixels, and the original would have been a hell of a lot bigger than that. But you can see it's already starting to find inland water and give us this pixelized output, and that's just a quick demonstration of how we could possibly update topography and master map in the future and add these new attributions as quickly as possible.
Yep. So master map is an OS product, is it? Just a little bit about that maybe?
Yes. It's a topographic product. It defines, using points, lines and polygons, the positions in the real world of often things that you can trip over or walk into. Yes. So where the edges of roads are, the footprints of buildings, field boundaries, other features like that.
But as of yet, you don't yet offer white van man location services or anything like that, like your features?
No, but it looks like I could.
That might be a bit dangerous. Yeah, so I mean, and I understand as well as an organisation that OS have a mandate to start to offer some of their historically paid-for products for free. Is that right? Or is that something we can talk about?
Currently, the Geospatial Commission is under review with a number of authorities about making MasterMap more open to people, and they're making their decision at the moment.
Mm-hmm. Yep. I guess, I mean, part of something maybe we didn't touch upon is, I guess, your transformation as an organisation. So historically, you've sold these mapping products. You have problems with people. If you go to Ordnance Survey, I guess you can see people outlining stuff, and then you've got all sorts of surveyors out around the country. What is it, 100,000 updates a day, is it, of survey information you're getting through? And this is people drawing stuff out. Yes. And here you have techniques for automatically augmenting that information. Mm-hmm. But also with this paradigm that I guess you yourselves as an organisation need to move away from making your revenue from, I guess, historical mapping products and things like that, more towards what else can we leverage with this data.
Yeah, being responsive as well to our markets. When someone asks for something from us, we want to be able to attack it quickly and provide it, and that's our job as the National Mapping Agency of Great Britain, is to offer what needs to be offered. So part of this research that we're doing is seeing which things that we can automate as quickly as possible and provide them for our customers and for use. Yeah.
You think of the number of apps on your phone that actually use something geospatial in it, and how much more they could be used if we have much richer attribution, not only to the features that we already capture, but information about human activity within different areas, about society, all of those, and it would be such rich attribution to so much other things that we could do.
Yeah, I mean, I went to London Transport Museum the other week, and I must have done 2 or 3 circles of it to actually find the entrance I should go in. So you guys being able to find me the right entrance when I'm mapping, that'd be amazing.
Yeah, that's something, access points, it's on the list.
Yeah. And I heard as well, like recently, where you asked to do some Grenfell Tower analysis or something like that. So a question of like, what other kind of buildings may have similar features to Grenfell? Do we know that information? I guess there's challenges like that. I guess it's more on the ad hoc side, but the more understanding your TopoNet has of the world and the more attribution you have, then the more readily your data scientists can come and say, actually, this is what we know about that domain of problem. It doesn't really have an obvious direct form of analysis, I guess, if you know what I mean. It's not like yes or no, it's like that. It's more of a different form of analysis.
Yeah, absolutely.
Yeah, yeah. So yeah, shall we talk about your pun, our roof of concepts that we did last year? So we worked together last November in a joint hackathon. So Microsoft and the amazing CSE team, led by Mr. Deepfat, that you would have seen earlier in our Tech Days Online Fest today. We rocked up with Ordnance Survey for something that Izzy's been working on and planning for a while to see if we can scale up your ability to do all these inferences, to use this research, and maybe ourselves help you guys along the way with the technology underpinning that. So I guess so just as a bit of background, so though we looked at how we can help you identify and classify roof types, that wasn't the first time you'd been working on this problem. We weren't showing you a fresh approach, was it? It's something you've been researching for a while, isn't it?
Yes. Yeah, we created an approach quite a few years ago, which did a lot of, you can show some cookie cuts, aren't you? So cookie cut out roofs and buildings and did quite a lot of processing, and then used quite a shallow multi-layer perceptron to classify those. And the results were okay, but it was very much standalone. It didn't work within the database, using data directly from the database and potentially feeding back into the data. So that's where you really came in for that one.
Yep. Yeah. And on that note about the data as well, and I guess say for example your line of business systems where people are doing these 100,000 updates a day. Yeah. So I guess historically what you get a sense of when you come to Ordnance Survey is everyone has an amazing just do it attitude, and they, but the challenge of that is you do work on high scale problems, and you've been working on them for a huge number of years. What is it, 272-year-old technology company, is it? You are?
225 plus, is that right?
Yes.
Something like that.
1791.
Yes.
Oh wow,
First,
right.
Yeah.
And
we were there.
Yeah, I was there with my pipe.
Yeah.
And I guess so you built up this technology portfolio over time, and I guess when we started to work with you, what that has meant is you've got this kind of point-to-point architecture of MPP databases and relational databases, stuff like that. And the challenge, I guess, one of the challenges for us from a data engineering perspective in enabling you guys to do these inferences en masse is unlocking all this data from essentially a nest of relational databases where you can't make changes, and even sometimes people use your product information as a database. So people reference MasterMap for another product and so forth. What if we want to make changes to those products to support all this new information you're finding stuff like? So there's been a few kind of architecture transformation challenges that we've been trying to help you with, as well as scaling up all this inference work. So let's talk a bit about the roof of concept hack. So you've been working on this for a while, but I guess it's quite a nice one in terms of use cases that we can understand, right? So
there's a lot of different use cases for this. So it's useful for insurance predictions to know what the roof's like of a building.
Yep.
I think Karis mentioned, did you mention about the potential, well, there's the potential to put solar panels on, potential to actually extend up and build on top of a building.
Roof space real estate.
That's the, yes.
Yep.
So there's loads of use cases. It's also a relatively clearly defined problem with a set of classes that are already defined, although sometimes a little bit vague. But yeah, it's a nice problem to work on.
Yeah. I guess in terms of your transformation as well, it's a new stream of revenue, so insurers can buy this information potentially in a mapping product. Yeah. So it's not something you would have classically thought about versus, say, cartographers and surveyors. You're selling that information, isn't it? So it's cool. Yeah, we worked together in a week-long hack to come up with new puns, as well as some data science and some learnings.
Yeah.
I guess
priorities, Luke.
Yeah, priorities. Yeah. So we had some of our really good from CSE in the UK data scientists join you guys really to fantastic. Work on a few different work streams in the hack, didn't we? So we tried employing transfer learning with custom vision. We tried, so you were doing object detection with fast RCNN, was it?
Yeah. Faster RCNN, and we've also done, we also built a model in CNTK as well to give us a bit more of the parameter tuning that that we couldn't do in custom vision. But I'm going to cover custom vision and CNTK because they both have huge strengths in two different ways. And we actually migrated from one to the other, but we can see where CNTK fits into this story as well. So I'm going to cover that as well.
Cool.
Yep. So I'm going to talk a little bit about the actual data itself. So the reason this roof hack was quite good for us is it was a week-long hack, so it's nice, it's contained, it's something that we can do, whereas our deep learning, image learn project is a big concept piece, which is going to take a lot of work from
Monster
us.
of a project.
It is. So this was a nice thing for us to really dig into and get some solutions, do a whole cloud architecture, store data up there, make a great model, and have this whole flow line. But the other good thing about it is because we've already got buildings in our data. So we fly the whole of the UK and we draw where the buildings are to within 10 centimetres, or I think it's 0.4 centimetres in some urban areas of their actual position. So we know exactly where these buildings are. We just need to add an attribute to them. And that's like a nice problem for us to solve in our first foray into this cloud flow line technology. So what we did was we got all of our topography, which you can see on the left, which is the orange buildings. That's what you can see there. And then on the right is our imagery. So we got all of our wonderful employees to give as much spare time as they could to us and label. I think we ended up with 20,000 in the end. We used some crowdsourcing platforms. Some of it was in ARC, Esri product. And we labeled them as hipped, flat, and gabled. Yes, gabled. We did do a couple more, but we didn't end up with enough of them, such as curved roofs. And as it was just a week-long hack, you know, that's a good enough start.
And can you explain what hipped, flat, and gabled roofs are? I guess I can guess flat.
So gabled is where you get the proper. There we go. The building block does it nicely. So
can't do hipped on these.
And hipped is where you have the sort of three triangles that meet. In a bent pattern, and gabled is the straight flat all the way along. We realised later on that actually some of our use cases don't need that differential. They just want to know flat and not flat. But you know, it's better to attack a harder problem than reduce it afterwards than do it the other way around. So we've actually got lots of data that we can use for this. And because we labelled our spatial data with our hip, flat and gabled labels with our crowdsourcing, it meant we could then use those polygons, which are a perfect match for our imagery and all our data, to then cookie cutter anything we like. So we had DSMs, we've got DTMs.
So, and what are DSMs and DTMs?
Yeah, okay, so digital terrain model is the DTM, so that's the lay of the land without anything on it. DSM is the digital surface model, so that's everything that's on the land, like buildings and trees. And if you take one from the other, you end up with a normalized version of the DSM. We also have our aerial imagery, which is RGB, red, green, blue band, but we also have near infrared. And we also created Frankenband. Olivia, do you want to talk a little bit about Frankenband?
Frankenband was amazing. So we thought that NDSM provides a lot of data, but we didn't want to just send RGB through or NDSM through, so we merged them all together and created, so instead of having an image that was RGB, you had RGB, NDSM, near infrared.
With the slope, so we
with
use
the slope
as
and
one
the slope
band,
as another band.
NDSM, and then we turned the RGB into a grayscale. So we had those three bands. That's right.
Yes, which didn't work as well as we'd hoped, but we think that was because of normalization issues.
Yeah, and we didn't train from scratch on that. So
true.
We need a multimodal training at some point. That's on the list. The list is long.
Hence why it's a monster project.
Yeah. So in the next slide, you can see what some of these patches ended up looking like. So because we, as I said, labelled the topography, we can then cookie cutter out of the NDSM, the slope, the RGB, and you end up with a single building with a little bit of background, because generally CNN's like a little bit of context, a little bit of background to accurately classify. And we could then pick and choose which of these we use, and we can still pick and choose or combine them, as in the Frankenband there, which is the most colourful thing and great to look at.
Yes.
We never see red in our job because red doesn't really appear in aerial imagery, so it's nice to see something with some warm colours. So what we did is we used these for training data. The first thing we tried was custom vision. So you can see in custom vision, what you do is you just drag and drop a load of images and then give them a tag. So I dragged 300 flat, 300 not flat, gave them a tag, took me about 2 seconds, and it's got ResNet 50 behind it, or it might be 34. ResNet 34 behind it, and it does a quick transfer learn and then gives you some results really quickly. Seconds it gives you results, so it's a really fantastic problem. If you've got a problem space which is fairly, I won't say simple, but fairly defined, and you're looking at the same types of data and you need to find segregations between, you know, up to sort of 10 classes, it's a really good tool for you to just quickly test whether it's working. And if it is, you can then hit the API of the model through custom vision. I think you get 1,000 free hits a day at the moment, and then after that you can come up with a paid service if you need one. So you can see our results next. In Hull, it's amazing. We got 80% correct, we got about 5% wrong, and we set a really high
acceptance?
Yeah, acceptance rate. I think it had to be 90% sure for it to give any result for us. So that's why you've got 15 unclassified. But that's much better in our field of work, because we'd rather have some you have to do manually rather than have some wrong. So that was a great tool for us. So we're really happy, fantastic, Hull, sorted, roofs, done. But we realised we did make a slight mistake, in the sense that even though we know generalisation is an issue, everyone in deep learning knows this, we were thinking roofs. How different are roofs? I mean, a flat roof is a flat roof. I mean, why is that any different? And especially when you're looking at NDSMs, when you're not even looking at colour or shadow. A gabled roof is a gabled roof. I mean, how is that going to differ across the country? Well, it kind of did, because in Cornwall, we clearly got a drop in how well that's doing, and the same when I put through a really industrial area in Basingstoke. So sad face on that. But let's have a look at why. So in the next slide, you can see these are flat roofs on the left in Cornwall, on the right in Hull. You can see that the flat roofs in Cornwall are a completely different colour to the ones in Hull, so it's used to seeing these white flat buildings, and perhaps that became an issue. Perhaps it was looking at colour, perhaps it was looking at shape. And in the next slide you can see the non-flat roofs and how they were different. Oh, I can't see my circles very well, sorry. But you can see in Cornwall they were very often hipped, whereas in Hull most of them were gabled, and they also were really orange. The colour orange came out a lot. There was a lot of terraced housing in the Hull area, not so much in Cornwall. So even though it's obvious, generalisation is always going to be an issue. It's something that, even if you think your problem space won't be affected by it, just do it anyway. Just do it anyway. So I did. I then sat down and labelled a hell of a lot more, which was not the best week I've ever had, but it's done. And then we decided to try CNTK. Now, the reason we tried CNTK was so that we could train and fine-tune and change the parameters as much as possible. So custom vision has a limit of 1,000 at the moment that you can put in, images you can put in. And because we found this generalisation issue across the UK, if we could put in as many as possible from as many different areas as possible, maybe we'll start to solve that issue. So we did some fine-tuning, we did some transfer learning, and I think we may have done a scratch train very recently, but we haven't got results from that with me. But on the next slide, you can see our ResNet. Oh no, yes, there you go. Our results from CNTK ResNet 34. So we got 85% accuracy when you have 3 classes, and that was on a more generalised run as well. And then underneath is our binary classification, because binary classifications are always easier, and we got 90% on that. So that is currently probably product worthy. We need to go back to our customers and find out what they want, but once you hit that sort of 80-90%, that's when you start getting real interest. Yeah. And this is something that was developed as part of that Hack Week. Tempest and Jacob were the two working on this, instilling this CNTK architecture, and since then we've then rerun it on that generalised data set, and yeah, the results speak for themselves. They're working really well. On the right, you can just see a quick classification picture with a flat, hipped and gabled, although I'm not sure there's any flat roofs in that, so trust me, they're good.
it's an amazing outcome for a week's work, really, isn't it?
Yeah, absolutely. And we learnt so much in that week about how we should deal with these models, how we should train them, how we should deal with our data. But another part of that hack was about how do we make a proper flow line from this. So great, we've got a model, but it's difficult for us to then harness that and use that on-premise machines. So we really needed a way to keep all of this in a sort of
keep calm and put it in Azure.
Absolutely. So Luke, you were working on that side about the architecture and how we were going to do that. So you say a few words?
So let's talk about the data engineering aspect of it then. So I rocked up with this hack and you came up with your amazing classifiers. So the bit I did was the data plumbing. I was your Mario. So we, at the time, this was November last year, so we were using HT Insight Spark to en masse do some of the operations that you were looking at in minutiae for your training. So these cookie cutter exercises where you're taking like masses of vector data and essentially joining that on raster data. So like these images that have not only many layers of information, red, green, blue, and your Frankenband stuff like that, but also they're geospatially aware, so they have an extent geospatially that then you join with like, hey, here's a polygon representing a university or the schools we saw earlier, stuff like that. So then we do these cookie cutters and then throw them at the work you're doing. So yeah, we built a production architecture to do that, to run over Southampton during our week. We ran that successfully. We then pumped that all into the Esri SaaS platform for GIS, and then we looked at it visually in the conference room, and that was amazing. Yeah. So that was really cool. So then, so following that November exercise, I guess we've all had like a few lessons we've learned from that. So, you know, in the data engineering side of things, we've subsequently released Databricks as an Elastic Spark service. So we've been able to be involved in doing this stuff at scale. And then I guess you guys as well, you've learned that sometimes things like custom vision, they're great. You know, you got to your 90% on some things, and sometimes I guess it's maybe inspired some of your subsequent techniques to then say, actually, we need to fiddle a bit in the inner workings of these networks. Actually, you need to do your own work there. So yeah, we're currently working together on a few work streams here, really, aren't we? So, so one work stream for you guys, I guess, is also you're training up TopoNet, and it takes, like, if you did it on a GPU, what is it, 3 weeks or something? It should take
13 days, 3 hours.
Yeah, and how many GPUs was that? Was it one?
Technically, it was one. We thought it was doing it on more, but it was only doing it on one, and that's with 10,000 megabytes of RAM.
Yeah, wow. So you guys are training on huge data sets, aren't you? So it's like ImageNet sized, if I recall.
Yeah, so I think it's 1.2 million, which is the same size as ImageNet, but we did this is a back of a letter calculation, by the way, so don't quote me on this, but we did a quick calculation that if we looked at all of our imagery in a single epoch up against our master map data, ImageNet is about 3 times the size of the Isle of Wight. So we have masses of data to train on if we want to. And we talked earlier about how we're using 13 classes in the current run. That's our first iteration. But we actually have 2,500 topography classes that we could be training on. And more than that, we have points, we have lines, we have functional sites, we have where schools and universities are and the extents of those things. We have named areas. We have some land use classification, like residential and urban and industrial. So we have so much data to be trained on, and our main issue is doing it quickly. And it's the opposite as what many people have, which is they don't have labeled data. Yeah. We have an abundance of labeled data, but we just need a platform that can scale with us and can move quickly, and that we can then also deploy quickly onto, because if we find a great model and we want to run all the zebra crossings in the UK, but we need to run all of the UK through it. So, sorry, GB, all of GB through it. So it needs to be a scalable thing that we can get results out quickly and iterate quickly upon as well. And that was why our move to Azure Cloud Technologies came in. I think our first Scratch Train Weights was on a single GPU computer, and that took 3 weeks.
That was heating up John Hare's office at the University of Southampton.
Yeah, a mini radiator.
It was absolutely boiling in summer.
Yeah. So moving towards sort of 13 days is our first foray, but if we can get that down to you know, 2 days, 24 hours, an hour.
We can actually start to iterate through.
So I guess, and you guys have historically looked into distributed training frameworks like Horovod for that, and they can be quite tricky to set up the infrastructure for. So one thing we've been looking into recently is Databricks have released this new machine learning beta where you can have GPU clusters which are configured to use Horovod or like distributed Keras on Spark. So we're investigating, you know, can we take a distributed training framework and apply it to the work you guys have been doing on one machine's GPUs and get that those cycles right down.
Absolutely.
So, given the amount of study you need to do on them as well, so that seems pretty paramount in importance. So training is one thing that we've continued to work on since that proof of concept, and a few other things we've been working on as well. So if we just get this slide up here, it kind of gives a picture of where we're moving towards and supporting OS. It might be a bit blurry, but essentially this is just like an ingestion pipeline representing some of the questions you might want to answer. So, you know, you're doing roof type classification and all this stuff using inferences, using your models and unpicking apart models and their intermediate layers, stuff like that. But there's also kind of more classic domain issues at scale we're looking at as well. So like, so you guys have a database of like 740 gigabytes, I think it is, of vector information, and we've been looking at, hey, how can we join that with some other point information you have? So then if we have a building and we know it's roof type, we can also get other information and join it on, such as what class of building it is from some commercially available information, what postcode does it have, stuff like that. So again, we've been kind of exploring what's possible with your data with Databricks. And one thing we've been doing is using like geospatial libraries like Magellan, which is supported by Databricks, and GeoSpark. And I guess we can go into this almost classical SQL world of doing spatial joins with your massive amounts of GeoJSON information and stuff like that, but do it in this modern way within Databricks, you know, following this kind of data lake architecture that's loosely coupled, moving away from all these databases that are point to point. Mm-hmm. And we've been looking at as well, so, you know, you've been doing this cookie cuttering, and some ETL tools for GIS will do this cookie cuttering maybe on a server platform, but it's a hard problem to scale up. Like, you guys have really high precision data, like that's one of your USPs, what is it, sometimes 25 centimeter per pixel accuracy.
Yep.
Like that is crazy accuracy. And so you've got masses of raster data, terabytes of it, and we're looking to join that with all this masses of vector information, put these patches together so that on national scale for your like 500 million features that your surveyors have recorded, we can do all these inferences, all that stuff. And we are then looking to, so here's just a little sheet about how can we do this all in the Databricks world with Keras, so they have a bit of IP that makes this super easy for someone like me dipping their toes into a bit of data science as a data engineer. So, so that about wraps it up from the proof of concept side of things. So is there anything else you guys would like to chat about today in our Tech Days online discussion? Do you want to talk about the future with GeoVision?
Mm-hmm. Yeah, the idea where we want to start taking this, and we want to start iterating through, even with our trained networks that maybe aren't working brilliantly just now, would be to have access internally to the features that the trained network will produce, so that people internally, perhaps some of our staff who are in touch with customers, can actually very rapidly create a new product generator from the trained network, and just to see how well it works with a particular problem that a customer might have. So we're training a network, it roughly represents the British landscape. How well does it actually help to solve a particular problem that a customer comes in? And we want to start creating this internal method of creating these products for customers, and just testing what we're producing, and then keep iterating through. Every time we've produced a new set of weights, does it improve those results for the customers? And that's where we're going to start working towards in the next few months.
Yeah, yeah. So the kind of sales hat we were putting on this earlier in discussion was, so people are used to the idea, say with Power BI of a self-service reporting platform. So you guys, from what I've seen, are looking to build this self-service, fill your boots with your inferences and surveyors' data in your own tool to then go on and, so for others looking to utilise your underlying data, underlying your maps, they can fill their boots and achieve their outcomes with it. Be it a mapping provider who is helping emergency services get to their destination, or be it a BT repairman looking for a junction box, something like that, I guess.
Yeah.
Brilliant.
Absolutely. Yeah.
Awesome. Okay, so I think that about wraps it up for us. So thanks very much, everyone, for watching. We're going to take a little break for 15 minutes until the rest of the agenda in the afternoon. So thanks, guys.
It's day 2 of London Tech Week and we're here at the Excel Arena for Tech Accelerate. Let's go speak to some people about AI and quantum. What does AI mean to you?
Well, AI probably, I'm not a tech guy, but it probably is one of the biggest tech trends. And for me, AI means make a computer equal as smart or even smarter as humans. And so far, when I'm talking to my phone, it's not as smart as a human, but I wish it would be. So I'm hoping on that would be the case.
AI means to me the realm of opportunities to harness computational power or computers, supercomputers, and so on to make decision making faster, more intelligent, and more evidence-based.
I mean, AI is essentially a better way of producing services for the consumer. I mean, ultimately, when you look at it from a telco perspective, there is very little innovation aside from the fact that you can offer data for cheaper or calls better. AI offers a bit of a way for the telcos to actually make money without having to compete with the OTTs by some innovations on the network, for instance.
Is AI a force for good or the end of mankind as we know it? A bit dramatic, but...
I think it's a force for good. I think the world is always changing and technology is part of our change and our daily lives, really. So I think it's going to bring greater things. So we have a Pepper in Vodafone that's kind of like, artificial intelligence. So we kind of teach her to do new things and everything. So yeah, I think it's a force for good.
It's a force for good. It's one of the best things that'll ever happen to us, I think.
There's obviously a lot of naysayers and a lot of people that are sort of terrified of the prospect of AI, but you look at everything around us, whether it's on social media, it already exists. Ultimately, you've got to look at the idea of a sentient being is so far advanced that it is theoretically impossible for compute power or even the technology that we're putting out onto the market at the moment. So, yeah, I mean, it's in theory good. It'll make a lot of people redundant, but ultimately, that's business.
I think it's not a black or white situation. I think it depends a lot on the people that are doing the solutions and developing behind it. So it depends a lot on us. It can go either way. So that's why we need to make sure it goes the right way.
How do you think AI could help improve your job? Is there any areas that could be autonomized or anything that you think it would help add value to?
Well, I hope not to take too much away so I don't lose my job. But to improve it, yeah, I think maybe with our repair operation, if we had more AI, it'd be able to pick up faults quicker than what a human can. So yeah, I think there's benefits there.
So there's a lot of stuff that we currently do that it's just time consuming and we don't add value to it. I think what a person can add in comparison to a machine is a lot, but if we're just stuck with tasks that take the time off and we don't get to explore the creative side, I think we're missing out on it.
Do you trust companies with your data?
Do I what, sorry?
Do you trust companies with your data?
Yeah, I do. I don't feel like I've got anything to hide, and I don't really care if companies want to contact me. It's fine. I don't feel like they're going to do nefarious things with it.
I'm an old-fashioned kind of geek. I put everything out there. I accept all the telematics. Tick, next, I agree, not a problem. All I do, behavioural again, is I choose what I put out there. What they decide to do with that, that's fine. I don't really have an issue with that. I think what's needed is people to understand that what they say is more important, and the platform of the internet and everything else is neutral. The same as the telephone was when Alexander Graham Bell invented it, or any other means of communication. It is a medium. It is not the beginning or nor the end, and that's what people should concentrate on. I think we're just still distracted by the shiny lights of the medium, will be my answer to that.
Do you think AI can be creative?
Not in the human way that we think of. I think there's always going to be a very unique approach of the human mindset and the human spirit. I don't think the AIs will reach this very soon, if at all. I don't think so. For example, a painter or a composer, I think that's very hard to replicate these types of creativity.
I don't think it's creative now, just purely because I don't think that the power is there and the levels of rational data. Whether it actually can be creative, I 100% agree, because I don't believe creativity is something that comes from the soul or something like that. You know, if you look at the basic concept of creativity, it's creating a novel idea or something that's never existed before. So by the basic definition of sort of data science, AI could evaluate absolutely everything, every book that's out there, and figure out one theme that is missing or not being collected altogether. Yeah, it's a very scientific way to be sort of creative, but ultimately it's achieved the same goal in that it's created something which has never existed before. So yeah, why not? Why couldn't it be creative?
Would you trust an AI, say chatbot, or some sort of artificial intelligence to set you up on a date, to match you with someone for a date?
So as I'm married, no. But in general, if I were younger, I mean, I met my wife online already, yeah? So I met her already through algorithms or whatever. So of course, I trust those technologies the way I did before. So why not use technologies that find even more suitable women or whatever, although now I'm already here, I'm married, yeah, so.
That's the point of no return.
I don't think that would make my husband very happy, but I mean, just for the fun of it, I would say yes.
We've had a fantastic day here at London Tech Week, talked about AI and quantum, but back to you in the studio to find out more.
We have so many pupils who are non-verbal, but still have so much to say.
I want the exact same information that my hearing friends have.
There are barriers to communication everywhere, but I think it's time we look at the barriers as opportunities to reach out to everyone.
Soundscape fills in a lot of the mental map as you move.
Approaching intersection.
You can just put it in your pocket and go.
With ALS, you become locked in. But we see technology as a way to give back what ALS has taken away.
There's no better feeling than to hear a child say something that they've wanted to say, and the look on their face after they've been able to say it.
When it's reading, I see spaces between the words, and it's easy to focus on.
Anjay realized that here was something that could change his life.
Now that I have my phone, I can see exactly what was said, and that's been a huge help to me.
The system is learning as it goes, and the accuracy has improved tremendously.
Students can pick any language that they choose to receive the information. It's like we jumped into the future.
Because communication is very important for all of us, and we just want to be together and not feel left out.
Aider les personnes avec autisme à communiquer, il y a des images.
Je parle, je donne une information à Arthur et elle est traduite par l'application El Picto instantanément en pictogramme et après d'une façon orale.
Va t'habiller et te brosser les dents.
On va pouvoir remettre en place une communication qui est plus spontanée. Je crois que ça aide à recréer du lien.
Both my wife and I are totally blind, and we have a 3-year-old son that's in preschool. He can see, but his parents can't. So to be able to know what's going on at his school is everything. The Seeing AI app has the ability to allow me access to the visual world. Artificial intelligence is beginning to have an impact on the lives of people with disabilities, but it's only going to grow. There is still so much out there to be done.
Hi, could you introduce yourself and tell us a bit about what you're doing here today?
Hi Emily, I'm Karen Knowles and I'm originally from Australia but moved to London or returned to London not that long ago. I work mostly in clean energy as my background, but more recently with scale-ups. So not startups but scale-ups once the ideas are proven out, how to roll them out across the business or in industry.
I'm Adam Chimwell. I am a channel marketing manager for the UK and Nordics for DJI.
And what's the most exciting scale-up you've been part of?
Nothing to do with clean energy. It's actually a company called Redbubble out of Australia. It's the world's largest digital marketplace for creative artists. And we took them through an IPO listed on the Australian Stock Exchange 2 years ago now. And the exciting part about that was watching them keep their customer very much at the center of all of this. It's for artists who retain their copyright and able to put their art out into the world without bypassing art galleries and all the traditional ways of artists being owned by intermediaries. The artists retain their own control.
Can you tell me a little bit about a piece of technology that has really kind of changed your life in the past 5 years?
I think I'm going to have to say the DJI drone technology. It's been a real change for my life personally. I come from a background of FMCG, so prior to this I've been working in the food business. I joined DJI in January and I've just been blown away by the technology that the company are producing.
So what is it about drones specifically that really excite you?
I think it's how far the technology's come. Our latest flagship product, the Mavic Air, it has a raft of autonomous flight modes that mean that even the most novice pilot can get really professional looking results with just the push of a button. It's really incredible stuff.
And this is some of the footage that we see behind us.
Yeah, some of this footage has been created with, the full range of our drones. You'll be seeing stuff here from the Phantom 4 Pro, the Mavic Air, the Mavic, and even the Inspire 2, which is our kind of enterprise level stuff. So, yeah.
In the past 5 years, a map app. I'm directionally challenged. I cannot go to any city in the world without having my map app telling me where I am and where to go. The only thing I would change is that I never walk towards myself. I walk away from myself. So if you could get the guys to just turn that thing around so we're not walking towards ourselves, that would be awesome.
And in terms of technology you're looking forward to coming out in the future, is that anything that's particularly exciting to you?
Oh, absolutely. 5G. Cannot wait to get connected wherever I need to be with whatever I need. Can't wait. Bring it on.
I'd have to say some of the enterprise stuff that the guys at DJI are working on right now. I know there's been some business cases in Holland recently where we've been demonstrating our new thermal imaging cameras to locate people within burning buildings, and just the fact that we can save lives with this technology is just really incredible.
we're here in the heart of London, kicking off London Tech Week at CogX. Let's go have a look inside. So we've got our first interviewee here today. Can you tell me a little bit about yourself? Virtual or augmented reality?
Augmented reality.
Augmented or mixed reality?
Augmented.
And why is that?
Well, I work at Cognitive Scale, and we do augmented intelligence. So for me, augmented equals everything.
Have you used an augmented reality app on your phone?
Not an app, no.
What have you used?
I've used some sort of surgical augmented reality, so you practice doing surgery where you get haptic feedback. Yeah, and that's pretty cool because I wasn't the surgeon, and they're much safer practicing on dummies than they are on real people.
Do you remember your first hologram?
No, unless you mean the ones that you made a funny scratchy noise and you could wobble them around from a cereal packet.
The first hologram I remember was used in Star Wars, and it was Princess Leia saying, "Help me, Obi-Wan Kenobi."
Probably when Tupac Shakur showed up in that one concert years ago.
Have you ever used a virtual reality headset?
I have indeed. I created a soundtrack for an organisation called Gorilla Science. It was for a space travel app where you get to travel around planets. So I provided a soundtrack for the Moon and for Mars and for Pluto, I believe, yeah.
Do you think the future involves wearing some kind of glasses or eyewear?
I know that there's quite a lot more hardware coming out like that at the moment. I think it would depend on how easy people will find to integrate it into their daily lives and their daily looks. So I think design is key to something like that.
Have you ever done a conference call with mixed reality?
I haven't. I'm looking forward to it.
Yes, I have in my current stroke previous employers. Yes, I have. And it's quite an interesting experience, but it saves a huge amount of time. And I think it also provides that opportunity to sort of feel as if you're involved in more than usually a Skype or anything like that. So yes.
Are keyboards going to be redundant anytime soon?
You know what? I think the keyboards might change, but I don't think they'll be completely redundant. So maybe they'll be on-screen keyboards rather than physical keyboards, but I can't see it going away, although famous last words.
Perfect. Thank you very much.
I still think that we're going to need some form of way of cueing what we want to say and how we want to say it. Ideally, I think we'll just talk to machines and they'll just type or send the message that we need. I think they'll still be needed, but I'm not sure they'll be as such a heavy reliance as they are today.
Do you think virtual reality is just hype?
No, because I had my first fully immersive experience with a Microsoft partner the other week, and it was mind-blowing.
No, I think that there is a lot of hype, but it's not just hype. It's going to become very important in the very near future, which is why I'm here.
When do you think mixed reality might become mainstream?
Hasn't it already?
What does AI mean to you?
Well, artificial intelligence is really talking to robots, but is it what just humans put into robots, or is it what robots think for themselves? Who knows? And who knows what will happen in the future?
and welcome back to Tech Days Online. I'm Christina Warren, Senior Cloud Developer Advocate, and I hope that everyone had a very nice lunch. I had a great lunch because I was chatting with two amazing women that we're going to talk to right now a little bit about communities, inclusiveness, and why these things are important. So first we're going to talk with Simi, who is a technical evangelist at Microsoft, and Jen, who is an MVP and regional director. How are you guys doing today?
Good, thanks. Good, thank you.
And Simi, you actually, in addition to working at Microsoft, you actually have your own nonprofit, right? Yes. It's called Witty Careers?
Yes, it's called Witty Careers.
What is Witty Careers? Tell us a little bit about that.
Witty Careers is an organization and it's a platform to help Black women and minority ethnic women get jobs in tech. So we do this through equipping them with the skills they need to get these jobs. So this is through events, mentoring. We also have free resources on our website like career guides and CV cover letters, just to help women actually get the skills they need, because not only is the women in tech problem a problem, also equipping people to make sure people know that tech is not a black box and there is a space in tech for them. It's very important to us. We also have an event at the Reactor here at the end of June, on the 30th of June, which would be very good. We have 100+ women joining us, so it's really awesome.
Amazing. So June 30th here at the Microsoft Reactor in London, you're having another event. That's great. And we actually have a video for Witty Careers that Simi's made that you can kind of check out to see what they've been doing. So we're going to cut to that. This. That's so good. And you've been doing this for 2 years now?
Yes, this is the second year running.
That's amazing. Jenny, you do a lot of community work as well. Tell us about some of the communities you work with.
So what we've been trying to do is develop a diversity charter so that any user group, meetup or events can adopt it, so that we can try and not just recruit diverse groups into technology, but retain them once they're there. And personally, I find that being part of a community has made such a brilliant, positive impact in my own personal life. And I think it's so important to have diverse groups. I love what you're doing with Witty Careers. I really think it's so important for everyone to have an equal voice. And it's not just about community and being nice, actually, although that's always a good thing. It's also the science tells us that businesses that are more diverse do better. They respond better to their customer voice, which is very important. We can't just talk technology and features, we have to talk about business value and benefits. And I think the way the industry is going, it's all about having that very organic mix of skills, not just technical, also business as well. And I think what we see here is diverse groups bring these things to the table. They also bring a lack of ego, which we sometimes see as well. And I think that one reason for success is if you have successfully carved out a career and you are on the back foot, you've been through a lot. So you bring empathy, compassion, wisdom to the table. And I think these things will make things more successful for the team, but also for your customers as well.
So you're basically, I mean, we've been talking about data and AI all day, and you're basically saying like that the data shows that being more inclusive, being more diverse is making your businesses better, making your products better.
Yes.
What challenges do you kind of see, Simi, that, were there any challenges that you noticed kind of in the women tech problems as you're trying to address that with Witty Careers that you weren't anticipating when you started the organization?
So I think in the beginning, so I came from a STEM background. So I did electrical engineering at university. I converted and was a software engineer before I joined Microsoft. And I came from a STEM background, so I knew, okay, there's a level of upskilling I need to do, but it is possible. But I meet so many women who feel like tech isn't a space for them and that in no way could they ever be qualified or ever code or work in project management. And I think there's a lot of unlearning to be done in terms of the fact that
it's about problem solving, and the skills you have existing are transferable. So one way we do that in our sessions is we make sure we have practical hands-on workshops where you don't just come and it's a show and tell of women that are working in tech. You actually leave with practical skills you can demonstrate at interview or during an assessment center to actually help you get your job in tech. So we don't always do traditional coding workshops. Sometimes we have like product design sessions. So at our last event, we had explaining the software development lifecycle from requirements gathering to actually doing the commit, to testing and the different testing frameworks, speaking about agile versus waterfall. It's very important to teach these concepts because if you don't have a traditional computer science background, you wouldn't know this exists. And having those concepts kind of gives you insight into what the career would be like and what kind of projects you'll be working on. So it's very, very important, and just working on the fact that tech isn't a black box and you can do it too. It's not impossible. It is very possible, and there's so much impact you can create by being in an industry like this.
And Ginny, when we were talking earlier, you were telling me about a group that you're working with who's doing some amazing things with the data.
Yes.
And you want to tell us a little bit about that project, but also what you were able to teach the people on that group who have very diverse backgrounds.
Yes, I'm working with some amazing people at the moment who don't have a traditional computer science background. So one's a historian, one has a degree in English literature, and they've all sorts of backgrounds, but not science, and certainly not computing science. So what we're doing is we are trying to analyse data which might predict homelessness. We're really trying to help London's homelessness by understanding data. So it's a real data science for good project. And that's really important because I think, particularly for diverse groups, or women in technology, they don't always see that actually you can really use data and IT, data science, to really have a positive impact and help people. And the interesting thing with their backgrounds is you can apply different skills to have great outcomes. In history, you're doing lots of research. In English literature, you're learning to communicate really well. Difficult concepts. So when I first started to work with them, they didn't know SQL, certainly never seen R, very good in Excel. So I took those Excel skills, and we are building such great things. And it's great to try and have an impact, not just for London's homelessness, but about the processes in place to support people. The data really surprises us because people switch off when they think about homelessness. They think of the tramps who they see in the street, and that's a really awful way to think about it. What we actually see when we look at the data, the largest group of people that are homeless are women and children who are victims of domestic violence, who have had to leave their homes in very difficult and sudden circumstances. So if we can do something that even improves the opportunities for that family or anyone in those circumstances, that's got to be a good thing. And that's where the diversity comes in, because we are starting to look at these problems in a very different, non-traditional computing science kind of way.
Oh, I love that, and I love what you're doing with that group and trying to look at that data to try to solve this very important problem. So thank you for working to do that. But I also love that you were able to upskill the people to recognize that they have Excel skills. I can teach them SQL. I can start teaching them R, and getting them into creating these models and using this themselves. That's really amazing.
Yes.
What have you found with kind of your workshops and with your mentoring? Has that been something you've been able to kind of see as well, that people might have their own experiences that they might not necessarily assume would make them a good fit for tech, but actually do make them a good fit?
Yes. I think one certain element I see this in is with people that are creative, so people that are artists or have like an online website where they do photography. I think people don't realize that there are roles like UX designer and UI and user experience. It's really, really good to make sure people from the creative space also feel included in tech as well. So I've met so many women who feel like, oh, I have all these great skills, but I don't know where to apply them. And actually showing that user experience is something that's taken very, very seriously. Some products are actually, it's literally do or die if the user experience isn't like 100% in terms of like how many clicks a user has to actually get a product or buy a product or onboard a product. Or it's really, really important to make sure these groups are included. So that's one element. I also think diversity of thought is very important. We were discussing earlier, and to make sure that there are different kind of voices on the table. So they're different. So in creating a product, there are different workflows. So there's the actual product team, there's the evangelism team, and there's the marketing team. And all these different teams need to interact. And working in tech is working in any of those different teams. And we need to kind of advocate the fact that you're trying to make the product as successful as possible. It's not always you actually doing. The person that's writing the code is equally as important as the person that's advocating for the project in the field or going to the conferences. So making sure that all those careers are kind of spotlighted and people feel like they're accessible to them is very important.
Both of you, what is, have you noticed kind of a shift in, I think that we've all kind of noticed, because there's been this broader conversation about women in tech and about more inclusivity and more diversity in tech, and we've definitely, there's been a lot of attention on that, and I know that there's more interest, but we're not quite seeing the results yet. Do either of you kind of have any ideas about what it's going to take for us to start seeing results when it comes to hiring, when it comes to retention, which is what you were talking about before, which is so important, because it's not just that we don't have as many diverse people working in tech as that when they do work in the field, they leave. You know, they stay to a certain point in their career and then they leave and they don't come back. What can we do to, or what do you think needs to be done for us to start seeing substantive change?
I think there's certainly a place for role models and for people to feel valued. There's that quote by Mary Angelou where she says, people don't remember what you said and what you did, but they remember how you made them feel. And I think people don't leave companies, they leave bosses. And what I think we need to do is understand how we can make people's working environments more inclusive. So I had someone working for me who was Muslim. I was very happy for him to take time out of his day to go and pray. I actually bought a cupboard for the office so that he could put his prayer mat in it, because I understood for him that was a very precious item. I also worked with someone in my team who was Jewish, and he was respectful of the Sabbath. So we just organised his working hours so that he could take Friday off, really, so that he could go home and be back in time for the Sabbath. So I think there are ways that you can make it successful. It just requires perhaps more thought, but I think it really is a team more compassionate and understanding. I don't expect people to be working for me, knocking themselves out 70 hours a week. I'm not getting the best out of that person. It's not a good environment. And I think it's about, there's a lot to be said to being a leader in your workspace and your workplace. It really is showing the way for other people how to retain and recruit people and make a happy workplace, because the reality is happy employees do better. Yeah. So there is a business angle as well.
Just to piggyback off your point about communities, I think it's very, very important for companies, or tech companies especially, to make sure they are kind of fostering a community element. So I know Microsoft is really good at that. So the different groups, so the BAME group, the Women at Microsoft group, and the different interest groups as well, because diversity is not always in what you look like, it's what you're interested in as well. So making sure you're facilitating that conversation, people to meet up and gather, and also just have peer role models as well as role models you can look up to up the career ladder, because peer role models are equally as important, and that's part of the reason why Witty Careers existed. Witty Careers is run by myself and 7 other women, Black and minority ethnic women that work in technology as well, and having that peer mentorship is really, really important. And when we're not running events, we're actually bonding with ourselves as well and learning, okay, what should I upskill in? Oh, what are you going through at work? Kind of having that peer relationship is really important, and companies should make sure they foster that. Yeah, I'll say that's my take, as well as all the other things like training, and obviously the women's STEM problem, as I mentioned earlier, it's a huge pipeline. It starts from when a girl is a toddler, and she's given toys to play with that don't develop her spatial awareness or problem-solving skills. So girls should be able to play with dolls and Lego. So
yes. I certainly played with both and enjoyed both. No, and I think that's a great point you bring up about making sure that we have people visible in leadership who are not, the typical background. That I think being able to see that, having peer is so important too, because it's important to say I have someone I can commiserate with and talk with, but to know that there's someone in a leadership position that exists and sadly it's too rare. We're seeing more and more women in leadership positions, but not as many minority women and or people who might be non-binary or trans or LGBT, and so that's important, I think, for all of I think moving forward. That's something I think a lot about. When it comes to communities, is there what success or I guess what lessons have you kind of found that's made being successful within your communities? Because you started one, 2 years, you've now been doing this for a long time. What makes a community successful, and what can people kind of avoid if they're trying to kind of start communities to make sure that they're doing things the right way?
I'll say one thing that makes a community successful is making sure you're actually listening to what people want. It's one thing for you to say, I think this is the problem. You actually have to be receptive to feedback and find out this community that I'm trying to target. Have I spoken to them? It doesn't have to be as formal as conducting an interview, but you actually need to speak to them. So one thing I did before, and my group did before we started, is we actually went to universities and we were talking to people, and people that came to us to kind of ask for mentorship. We made sure we were finding out what their problems were, and we were addressing those at our events. So it's not just an abstract imagining what the idea was, because I went to university a couple of years ago. What's relevant to someone a couple of years ago is not relevant now. So making sure it's relevant and then iterating on the idea. So there are things we learned from our first event that we're not doing again now. There's some things that we were told to continue doing that we're doing now. So just kind of reiterating and spreading the word is very important, making sure it's not just Twitter, but verbal testimonials as well are equally important. So I'll say those are the two things that are quite important.
I agree, and following on from that, I think the voice of allies is really important as well. It's a very key item. So I don't expect someone to speak for me as a woman in IT, but I expect them to speak with me. So one of my male friends will, if I tweet something that's fairly feminist, he will retweet it and he will comment, and he'll say, and he's quite right, I think, for some people, the answer to me is no before I've opened my mouth. They don't want to hear it. But he says, but they will listen to me. And he's right, it's a sad fact, and it's quite difficult to understand that. Because I've got 20 years experience in IT, and to be dismissed before you've opened your mouth is quite difficult, because I've worked really hard to get where I am. And there's still a long way to go. As I was saying earlier, it's still my ambition to have imposter syndrome. I don't always feel that I'm good enough to have it. So I think having those allies is important.
Well, if I can just stand in and just say, I've spent the last couple of hours talking with you and having such a lovely conversation, and you should not have imposter syndrome for anything, but let alone aspiration for that, because you're amazing and awesome. I mean, this is why we were laughing. It was just like the idea of that. But I think it's also, thank you for being so humble about it, but you bring up a great point about allies. Do you have any perspective as being a woman of color of how people can be allies and how we can best people who are not minorities or people of color can help amplify those voices?
I'll say one thing is when someone is like an expert in a particular space, putting them up for opportunities, because most times some people might just not actually know that, oh, this person is spent 2 years of work in Java, for example. I was a Java developer before I started. So one thing that happens regularly is at team meetings, people just say, oh, Simi has worked on Java. Can you ask her or check with her on it? So just kind of advocating and just encouragement, really. I don't think, it's not as if anyone wants to be singled out, but making sure you're encouraging people, and just the same way you encourage all your other colleagues. Just make sure everyone feels included. And I think diversity is not just in how you look like, it's also in how you think. So me going into an evangelism team when I was a developer previously and making sure my skills from that team are also embraced in my new team is something that shouldn't be ignored. I can kind of bring something new to this new role. So yeah, I think it's just all about kind of advocating for people, and we should all be advocating for each other and cheering each other on.
And I love that. And Ginny, tell us more about your diversity code.
Yeah, I had a long think about this, and although I think code of conducts are important, it's important to know what happens when someone's in the door, but how do you get them in the door? So my thought was we should have a diversity and a decency charter, and basically the decency charter is almost like you say in Star Trek, be good to one another. That's really what we shouldn't have to codify that. But sometimes we do. We see behaviour which is maybe difficult, or there's been misunderstandings, or something's gone really badly wrong somewhere. And I think having a decency charter really is attracting people to the user group or to the meetup or to the event to say, look, we value decency and we value being good to one another regardless of our background, our faith, our religion, our age, and our ability or disability, however that shapes up. Some disabilities you can't see. Yeah. So autism is a difficult and very challenging condition to have. And how we can make our spaces and our events as friendly to people as possible. Give people a prayer space if they need some downtime in a room because they've got autism. Can you give them a place, a chill zone? And so you don't necessarily have to make it about autism. You can make it about anyone. Mm-hmm. So I think it's decency first, and then once something has gone wrong, you can then invoke the code of conduct if you need to.
I love that. I love that. We are unfortunately out of time, but I want to thank both of you so much for joining me. I could spend another hour or so talking with you both. Wittycareers.com, is that where people...
Wittycareers.org.
Wittycareers.org is where Simi's site is. Do you have a website you want to point anyone towards?
I'm just Jen Stirrup, but I will tweet up my diversity charter. I'm sorry,
Yes.
I've forgotten the URL.
Oh, no, that's okay. That's okay. Check it out on Twitter. And you've got an event here, the London Reactor, on June 30th.
Yes.
All right. Well, next up, we are on to Andrew Fryer to introduce the next session.
Hi, and welcome back to the sort of technical bits and pieces. You can see the title says it all, but what you don't really know is how amazing Alan Mitchell is from looking at this slide, who's coming on to speak to us in a minute. He, when I first started working with him, he was all over this thing called SQL Server, and it's so old school now that we kind of forget about it. But in the 12 or so years we've known each other, it's completely reinvented himself as a NoSQL guy, and probably the most deep expert we have on this thing called Cosmos DB, which is not only SQL. And as we're about to find out, it can do a variety of different things at planet scale. Ordnance Survey are using it, as you heard earlier, and pretty well every engineering project I work on also make use of this amazing database engine, because it just stores whatever it is you want, and you can kind of make decisions about what it does afterwards. So, excuse me. So without further ado, let me see if we can get hold of, Alan.
Hi, Andrew.
Alan, hello.
Sorry about that.
No, it's okay.
Luke Skywalker having just come in to talk to you about Cosmos.
Indeed, you're looking well.
Thank you very much. Thank you.
Lovely to see you again. So this Cosmos DB thing, what about it?
So Cosmos DB is an amazing planet-scale, multi-model database from Microsoft. It's evolved from, I'm sure you remember, you and I used to do presentations a couple of years ago on something called Document DB, where it's Document DB, and they've advanced it with new APIs, new functionality over the past 2 to 3 years, and it is now something that is really, really exciting. We've got a number of customers on it. They have very, very genuine use cases that Cosmos DB is sourcing for them. But today, I could talk to you all day about Cosmos, but there's two main parts that I want to talk to you today about, and that's obviously the multi-model type of stuff. Yeah.
We're using the word model a lot today, but perhaps we want to be clear about what we're using it for in this context.
Yeah, so this is what I mean by multi-model. So typically when you have a database, it's you code against it using an API. Yeah. It's usually a single API. Like you'll talk to SQL Server a certain way. But the thing about Cosmos is, as you can see from this slide, is there's a number of different ways of talking to it, and Microsoft have effectively made it more appealing for people who maybe aren't from the traditional Microsoft world. And they've given them APIs so that they can use this planet-scale distributed database without necessarily having to change their front-end code that they're already using.
Right.
So you'll see from here, we've got your typical document DB, right? So you've got your document DB on the left-hand side there, which is SQL. You've got your JavaScript. You can talk to it using JavaScript.
Yeah.
Right, but the next one is Gremlin, a graph database.
Yeah.
Right?
So like a bit like Neo4j or something
Correct.
like that? Yeah.
Correct. Really, really exciting. Table API, classic. And then you've got Mongo. The one thing that's actually missing from here is Cassandra.
Yeah, what is that?
So again, that's a column family database that you can use, and when you provision your Cosmos DB, you get a choice. You have a drop down, and it says, okay, how do you want to talk to this guy? Right, and you can choose from the different APIs. But today, the two main things that I want to go through are Mongo and Gremlin.
Right.
So one of our customers was we can say was now, was a big MongoDB company. They had 3 terabytes worth of MongoDB, right? But it was all managed on a cluster, a physical cluster. And if you've ever tried to manage a big cluster like that, it's not all easy. So using Cosmos, we've been able to migrate them off, take their existing document stores, migrate it to Cosmos, scaled, partitioned. They didn't have to change a line of their Mongo.
Wow.
And in fact, their application has no idea who it's talking to.
Yeah,
Right?
okay.
Has no idea, doesn't care.
Yeah.
Right? Data is data to the front end. Works beautifully. So, but I do want to cover off a couple of the things about Cosmos first.
Yeah.
So what are the use cases for it that we've seen? So your classic is a Lambda architecture. So you'll see that we've got devices which will be transmitted up to Azure functions, which go onto IoT Hub. Stream Analytics will then stream into Cosmos DB. Cosmos DB is a fantastic way of landing data at super high speeds.
Right.
Then what you'll see is we've got a web job reading the change feed. Now this is a really exciting piece of technology from Cosmos, is that it exposes a change feed. So when you update, you insert a new document, it says, bing, there you go, something's happened. You can subscribe to that effectively and do something with it. So you can be sitting there asynchronously saying, okay, something's happened, boom, something's happened, boom. Yeah, and react to it.
Yeah, you could hook a model up to it or something like that.
Correct.
Yeah.
There's loads of things that you could do. You could just land it into Azure Data Lake Store. You could go process it. You could have it run other functions. Fantastic. Retail product catalogs. So this was in the early days of DocumentDB. This is what I used to use at customers. I used to use that for, which was essentially session state and a product catalog. Get into a DocumentDB, boom, really, really quick to retrieve. Yeah, fantastic way of using Cosmos. Order processing, and this is again where we use a change feed, and then we have functions reading off to do different things: tax, payments, fulfillments. Fantastic.
Yeah. So very much designed for the modern web world. And I think the other thing, back to your product thing here, is of course you're not predicated on having a structured schema. So Terry earlier was talking about selling paper clips and submarines. Clearly the attributes of those two different products are going to be completely different. You don't have to worry about changing your schema when you use this thing.
And that's one of the beauties of products like Cosmos, is that in the traditional world, you define a schema, and it can be costly in terms of money and in terms of man hours to change that schema. Whereas when you've got something like Cosmos, you can have that fluid schema and you don't care.
Yeah.
Yeah.
But you wouldn't call it schema, would you?
No. Okay, so, and this is back to yours, which is where you read with the Azure Machine Learning. So there's loads and loads of ways that we can use Cosmos DB out there, and we're seeing more and more people interested in Cosmos. So what does it look like? Well, if you've ever looked at DocumentDB, it has the same kind of structures, right? But it's underneath, the containers are exposed slightly differently. So you've got collections, you've got graphs, you've got tables.
Yeah, and we need to be clear that we've been talking about containers earlier on today. This is nothing to do with Docker,
It's got absolutely nothing to do with Docker. Yeah, absolutely nothing.
Good.
Right? And then you've got items within those containers. So a container really is a container.
Can be likened to a table?
It's a folder. I'd go with a folder that contains items of different types.
Yeah,
right?
okay.
And you maintain a collection if you're talking about a document store.
Yeah.
Yeah. And I think on the next slide, so here you go. So the next slide, so if we're using DocumentDB, then the container will be projected as a collection, right? And inside that, each item within that will be a document. Right? And likewise with your Gremlin, your container will be a graph, and inside that will be nodes and edges.
Yep.
Yeah?
Okay.
Partitioning.
Mm-hmm.
So you can see that we can partition, and we get incredible scale from partitioning within Cosmos. So here we're partitioning on airports, and you can see that it's going to a different partition based on the airport's code. So that's Sydney, for example.
Yeah.
Different consistency model.
Ah, yeah.
Right. So you've got your traditional on the left, which is everything's strong, everything's got to acknowledge, yep, I got that before we return, and we say, yeah, we're good. On the side, which is the eventual, which is the fire and forget method, which is the, I'm going to shoot this off, and you know what, if you hit another node in my cluster over this side, you might not see that for a while. You will eventually, but you might not see that. And we've got different variations in the middle. So a session, for example, would be, you're guaranteed that if you've written something, you're guaranteed to be able to read it.
Yeah.
Yeah. So it's got these 5 different ways of you being able to handle consistency within your database.
Yeah, and I kind of, my brain kind of gets the session thing. So a user sees a consistent state when they log in. So if I'm buying a theatre ticket or something like that, I'm going to see a view of the world. But the other two, I don't quite get.
Which ones?
The bound staleness and the...
Okay, so what this is saying is, that, so bounded staleness is where you will allow a certain amount of latency between the writes and the reads.
Right.
Yeah. And the consistent prefix is that it will process the document in order. So you will see it in order. So it won't be that you will see this and then you'll see this, but this came before this, so you'll see this. Yeah. So this guarantees that you will see it all in order.
Right.
Yeah.
And I guess if I was going to draw an arrow the other way, there's a cost element. To do strong is going to be more expensive.
So strong is more about latency.
Yeah.
Yeah. So if you really just want to go
yeah,
right, then maybe you'll choose eventual, knowing that it will get round there. It might take a second, might take 2 seconds. Yeah. Whereas it'll be super snappy. Over on the left-hand side, it might be like that. But you know, everybody's got it. Everybody's happy.
Yeah.
Right?
Clear. Okay. Thank you.
So this is what I was talking about earlier. This is where you go to the Azure portal and you say, I'd like Cosmos DB. Right? Cosmos DB isn't a thing by itself. It's got a whole bunch of APIs, like we said earlier. And one of the things, besides entering the ID, i.e. the whatever it is that you want to call it, is it's then going to ask you, how are you going to talk to me?
Right.
Yeah. And you get this choice. So you can go for MongoDB, you can go for Cassandra, you can go for Azure Turbo, Gremlin, and SQL. SQL is a traditional document store. Right. So you get all of these different versions. And you'll see later when I do a couple of examples that I've got, that I've created one using Mongo, and I've also created one using Gremlin.
Right.
Yeah. So they're 2 separate instances of Cosmos DB, and you can address them in 2 separate ways.
Notice as well it says UK South, so liking that?
Correct.
A bit like the latest Hollywood film has now arrived in the UK.
Yeah. So the advent of the UK data centres was massive. So at Elasticloud, I'm not telling a word of a lie, the day that they got released, the day after, everybody seemed to breathe a sigh of relief, and more people wanted to talk to us about Azure. It was that good.
Wow.
Right? So fantastic. Fantastic. And now people have got a choice, right? They can land their data in UK South. Yeah? Brilliant.
Okay.
So what does it do? So you've got MongoDB support, but what kind of support have you got? You'll see here that I put up a URL, so people watching later on can freeze this frame here and go and have a look. Microsoft have done a really good job on their documentations around these multi-model support. So they've got examples of how to use it, how to set it up, what it does, what it's capable of. And so go to that page, find something. But I've just listed a couple of things on here that you can do. So you can do your classic CRUD operation, right? So your finds, your inserts, your updates, your deletes. Big one, aggregation. So being able to take a collection of documents and saying, give me a sum of all of this field within this document collection. Fantastic. Project is obviously what do you want to see. Limit, that's top.
Yep.
Yeah. And or not. And there's a whole heap of others, right? I could have a number of slides, but go to that page, have a look. Brilliant documentation.
So this is the Mongo query language equivalent to SQL, but
correct.
Specifically for them, yeah.
Correct.
Yep.
So I think in the early days of this, there wasn't. So aggregate, to get aggregate working, I'll show you a little thing that you have to do, right? Otherwise, it will say you've not enabled aggregation for this account.
All right.
Yeah, so it's a preview feature right now. Yeah, but it works, right? You just have to enable it, and 15 to 20 minutes later, you can do what you want.
Yep.
So for my examples, what I've used is I've used a Mongo UI called RoboMongo.
Right.
Yeah. So it's just something that would traditionally talk to Mongo. But as you can see from here, I've created a connection to Cosmos.
Yeah, TDO, Mongo, documents. Oh, TDO,
Yeah.
you've created one specially for us.
Yeah,
Thank you.
Tech Days Online. I thought I'd just create that. And you can see, again, on that URL that I just posted, tells you exactly how to do it. Depends on which client you've got, tells you exactly what to do. And you can get RoboMongo talking to Cosmos DB, and it has no idea that it isn't Mongo. So let's have a look at that then.
Yeah.
Right, so. So you'll see that this is RoboMongo, and you'll see this is my Cosmos DB connection. And you'll see, just let me expand this a little. Here's my database. Here's my collection. And there we go. And that is going against Cosmos.
Yeah.
So here's your find, one of the things that I was talking about earlier. Now, if I pull up the Azure portal, you'll see here that I've got two instances of Cosmos running.
Yep.
So this is the, just like that. So you'll see that's the TDO collection that we were just talking about. And if we have a look at Data Explorer, you should see the exact same documents that we saw earlier. So if I just click there, you'll see that it's exactly the same. Now remember I was telling you about aggregation? If you look down here at preview features, all you've got to do is just click that box there. It'll tell you you've got to wait 15 to 20 minutes. Everything's good.
Yeah, that's fairly consistent across Azure, isn't it? We often have things you have to turn stuff on, like in SQL or what have you.
Very rarely do things just go click, boom, you're in. Yeah. So they have to turn stuff on. They'll be doing stuff in the background. 15 to 20 minutes. I actually had a phone call last night, so it was exactly this time, so I didn't notice the 15 to 20 minutes. And I came back, boom, it's all done. So what I've got is I've got in here so I can go and I can issue a query which simply says, give me all the documents where the quantity is greater than 6.
Yeah.
Right, so in here,
wow.
There you go.
That's incredibly quick.
Practically instantaneous, right?
Yeah.
Practically, and in fact, if you look there,
and that's the round trip time. Never mind.
And that's And remember, this guy, Robo3T Mongo thing that I've downloaded for free, has no idea this isn't Mongo.
Yeah.
But this is genuinely Cosmos. So one of the sexier things that have been added, like I was saying, is this aggregation. So let's have a look at that working. Let's make sure I get rid of all of that.
Yeah. You've been watching me down, haven't you?
Just want to make sure. I usually leave some kind of bracket on somewhere and it doesn't work. But you'll see there we've got by day of the year, by year, total sum, and we'll multiply price times quantity, and we'll also get a count of the documents as well. Look at that. I mean, that was, granted I don't have an awful lot of documents in there, but...
So just basically is a function of retrieval time here. It's instantaneous on the back end, isn't it?
Correct. So you'll see there, look, total amount, count, document 2, 3,
Yeah.
Absolutely fantastic. And we can even, so you'll see in Cosmos, you'll see if we look at Data Explorer, that we have 5 documents. So let's see if we can insert another document through.
Oh yeah.
Through the Mongo layer. Insert a document. Let's just.
Oh, so it just opens up a dynamic window for you to write the code in.
Yeah. So let's see if it's inserted that document. Yep. There you go. There's mine, and with a bit of luck, it should be over.
Probably... Yeah.
Go.
Yeah, so we just give you a lightweight query interface in the portal. Yeah.
So this gives you a this is what you would have seen with DocumentDB, right? Is you see an editor very similar to this, but this just proves that what was written in that Mongo tool is really querying.
Yeah, the back end here.
DocumentDB, Mongo Cosmos.
The thing that's on Azure.
The thing that I'm querying here is what we're actually querying.
Yeah. Okay.
So absolutely fantastic. So let me get back to my slide deck. So the other thing that, like you were saying, like Neo4j, is this idea of graphs.
Yeah.
How do things relate to each other? I want to see Andrew knows Alan, knows Richard, knows John, knows Peter. I want to say that he drives this car and describe the relationships between things, people, places, etc.
Right.
Yeah, and that's the job of a graph. And you can query Cosmos DB as though it was a graph database
using
Gremlin.
And this is part of Apache, is it?
Apache Tinkerpop. It's a nice name.
Yeah.
Yeah.
Yeah. I do love open source. Sometimes the names confuse me a little.
Exactly. They could have called it Toasty Maker, right? But they called it Tinkerpop.
Yeah.
Yeah.
Okay. So this is an example of one of these graphs.
This is an example of a graph that you could have, right? So I've taken this straight from the Microsoft document page. as this being an example of a graph. So whatever you see, you'll see this on the documentation pages that I was linking to earlier.
And how do we characterise the different things on here? Like, there's obviously objects, and then there are these lines.
Yes, so there's edges and vertices.
Ah, right, okay.
Right? So remember those things that I was saying? These are the items within the collection. So the collection is the graph. So the container is the graph, and the items are the vertices and the edges. The edges describing, I know you.
So they're each individual documents, but they're in a different structure to each other. Yeah.
So I'll show you what they look like.
Cool.
So I'll show you the Gremlin console, and we'll also go again into the portal and see what that looks like there.
Cool.
So requirements for running, if you intend to run what I'm about to run, you're going to have 3 things. One is Java. Make sure you've got Java. I thought I had Java, and I did have Java, but I had to update Java to the latest version, right? So if it comes back and it says, when you run the Gremlin console, if it comes back and says, I can't find Gremlin, I can't find Java, just update your Java. Because I did have a Java home, etc., but it didn't seem to recognize it. So you want the Gremlin console, which you can go download easily from the Apache project. You need Java, and obviously you need the
Cosmos DB.
Cosmos DB account.
Yes, because obviously it's not in MongoDB mode. We're talking about
Correct.
Cosmos DB in Gremlin mode.
Yes. So,
right, okay.
So well spotted.
That's okay, that's okay. I make mistakes like this all the time.
Cosmos DB account with the Gremlin API.
Yeah, okay. You've got your pen in.
Yeah, so I should have got, my pen's in the bottom of my bag. Not that pen probably will just break my laptop. Okay, so let's have a look then.
Yeah.
So again, you'll see that if we go to the portal, you'll see that if I go back, I've created TDO Gremlin.
Yeah.
And I've created a person's graph. Again, this graph, I wasn't imaginative enough to create my own graph. Microsoft supplied this. It's like
sample sort of thing.
It's like a sample. It's like a Northwind database.
Yeah.
So Microsoft will supply this person's graph for you to be able to get a flavour of what it is that it looks like without it being too big that it blows your mind, right? So you can go to Data Explorer again.
And that query you've got there, g.v, open bracket, close bracket.
Yeah, so that's select star from my graph.
Right, okay.
Yep.
So g dot is the object and v, and we haven't put anything in there. So that's
correct. That's all vertices. It would have a little star in here if it was SQL Server.
Yeah.
So it's a give me everything.
Gotcha.
Right. So you'll see that if we bump that over there a bit, you'll see that we've got these documents, these items, these vertices.
Yep.
Yeah. With an ID, a label of person, first name of Thomas, last name of Anderson, age of 45. And if we just scroll down a little, you'll see where they lead off to. And you can go find that person, telephone, car, whatever it is.
So you can just crawl through the graph that way.
Correct.
What's this? Oh, yeah, there's a thing in the middle as well, isn't there?
Yeah, so that's the little... Yeah, so these are the objects, and you can see that you can highlight that, and then you get to drill into it. But
right,
let me open up another tool. So this is the Gremlin console. So I have it here. Got some commands that I need to run. So again, you see this URL here?
Yeah.
This is the document DB, this is the Gremlin DB version of what I was showing you earlier for Mongo, right? Really good documentation will get you started, will explain the concepts. Okay, so what I want to do is I want to connect to the Tinkerpop server, and the configuration is in here.
Oh, yeah, YAML file. Yeah, we've seen these already today.
Yep.
Yeah.
So mine looks like that. Yeah?
Yep.
Again, all in that URL, it tells you exactly what to put, where, how, and why.
Yep.
Right? So long as you've got this, you fill it in, obviously, with your information. Yeah. So what I need to do is I need to go connect using the config from the YAML file. Cool. And then what I need to do is I need to execute this. What this does is it says everything Alan now types will be going against the remote server.
Yep.
Yeah. And it says there, it even tells you all scripts will now be sent to the Gremlin server. So what we can do is we can start to issue some queries. If you look at the documentation and you see this colon greater than sign, do not ignore it. Nothing will work unless you have that in the line. It's saying push this. Yeah, you must include this. Initially, when I was getting up to speed with this in the Gremlin console, I thought that was some kind of syntax from whoever did the web page.
Yeah.
It's not. This is super, super, super important.
So that says go and execute remotely?
Yeah.
So if you didn't have that, you'd have to have the thing on the
Correct.
local machine?
Correct.
Right.
Okay, so all this query is going to do is it's going to say, okay, go against all the vertices where it has a label of person, which we saw earlier, and it whatever you find there has an age greater than 40. So let's go and let's execute that. So it'll go away and it'll come back. It takes a couple of seconds, but you'll see what you get isn't necessarily wonderfully readable.
No.
Yeah, because we've retrieved an object, we've retrieved the whole object here. We've not done any projection, which we'll do in an example's time, right? But you can see that we're now looking for, his first name is Thomas, his last name is Anderson, his age is 45, and that's his user ID.
Yep.
Right. Yep. So what we can do is we can do projection.
Right.
So we want to retrieve.
I see. Just putting a tag out of the document.
Correct.
Yeah.
Instead of that big dump.
Because obviously, oftentimes when we're retrieving off data, we want to put it into some other tool. It might be a BI tool. It might be an application. And generally going to want flattened data for some of that.
Correct.
Yeah. Okay.
So as you'll see here, we just got Thomas, which is probably more readable than this. If all you needed to know was who is it, and there wasn't in this room today.
And obviously, if there are multiple people who met that search criteria, we ended up with a list. Yeah.
Correct. So so long as they met that search criteria, you would have had A and B and C and D and whatever.
Yeah. Okay. Clear.
But so what's this then? This SQL, right? So you and I, back in the day, did lots of SQL, TSQL. We still love it. Still love it. But there's other tools, right?
Yeah.
Right. So what is this? Right. So what you do is if you come over to console here, you'll see here new SQL call. What's that about? So you think, okay, I'm gonna have a little go with that then. Select star from C. Looks very much document DB type. Let's see what that does.
Yeah.
It retrieves your documents, your vertices, yeah? And you can see labels, persons, ages, user IDs. Yes, so I've got just a few people in here, so I've not got a whole load of people in here.
There's obviously a whole load of extra bits and bobs at the bottom here, aren't there?
Yeah, because look, label knows. That's your edge, right? I know you.
Right, so the edge gets stored as part of the... No,
as a document, as an object.
Of course, it's a completely separate document, isn't it, with the curly braces there,
Yeah, it's an object, that gets done, and your graph gets made up from all of these things.
Yeah, so that's saying, that second thing is saying person in the sink is connected to this other person.
Correct.
Yeah.
Correct. But that there is a genuine select star from.
Yeah,
right?
Fantastic.
So let's just do one more query then, because it wouldn't be very good SQL. So what about if I just wanted this? So this is the exact same query that we did before for Thomas. Yeah?
Mm-hmm.
We said, give me back his first name where the age value is greater than 40. So before, in the Gremlin console, we retrieved back Thomas.
Mm-hmm.
I'm hoping when we do that here, it does.
Yeah.
There you go.
Okay.
So hopefully this has been a good introduction for everybody to the flexibility and different ways that you can address what is the same platform product in Azure in a different way. And like I said, we've got customers on Mongo who were previously on Mongo who haven't had to change a line of code, ported all of their documents into Cosmos, and they get turnkey, global-wide distribution, proper SLAs. Microsoft give you money back if they don't hit those SLAs.
Wow.
Right? If Microsoft don't hit the SLAs, they give you money back. Right? And they take care of all your hardware for you.
So what's not to like? Yeah, so much better than running it on premises as well.
So it's a lot easier.
I would actually argue, I'm going to be contentious here, and go to them and say it's more secure because you're persisting everything in there. You aren't downloading it, you aren't mucking about with it. If you're totally in that world, data's not going to leak out so quickly.
Yeah, so this has been an eye-opener for some of our customers using the MongoDB.
So I get the planet scale moving the Mongo thing because I kind of understand what a Mongo database is, a set of JSON documents on. What sort of, have you picked up any recent use cases you can talk about generally about how Gremlin, the graph thing is being used?
So we're seeing graph being used by law enforcement.
Yes, well, yeah.
Right?
Yeah.
So law enforcement, we're seeing being able to describe the relationships between different types of entities at different moments in time is insanely useful. Previously, these companies were using a technology which did it, but it wasn't a graph database. So all they had was a hammer and everything looked like a nail.
Yeah.
Right? So they didn't have the right tools, but with this now, they can see A knows B, B drives X. Yeah.
And then there's the, I think the UN on law enforcement, for drugs enforcement, they've got a 6x6 intelligence classification system. And you would actually tag those lines because sometimes they're not known facts, sometimes there's suspicion, sometimes there's also an indication of how relevant they are to a case.
Yep.
So that's really important, that's not so important. So you can quickly tease out the relevant thing, and also you could then tag it with which operational teams can see which connections, because it's the connections that give you the information.
Correct, it's the edges.
Yeah.
The edges between the entities.
And finally, you know, and everybody's compliant with GDPR, you can start to tag who can see what and the lineage and anything else about all the documents and evidence that you have. So I'm seeing all sorts of unusual cases with that now. But yeah, I have a little bit of a background in that world as well. Was a while ago. I've been with Microsoft for a while now. And what's so with Cosmos? Is it just sort of sitting behind the big e-commerce sites? So where else are you seeing it being used?
So I'm seeing it we're seeing it being used where people want boom, 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 really quick ingestion, right? So you've got ADLS. The next step that we see, if people want to be able to react to something going in, they consume the change feed.
Yep.
But they get crazy, insane ingestion rates.
Fantastic.
Yeah.
Okay,
So that is a real use case that we see. Plus, it's global scale, massive storage options, the flexible schema. Yeah, flexible schema. Let's not go schemaless.
No.
Right. Flexible schemas. People are really switching on to it. We're seeing a lot of people opening their eyes to the possibility of using this, whereas possibly previously, without the things like the change feed and the different APIs, it didn't hold as much for them.
Yeah. And if you hadn't, I mean, say you've got our people we go and talk to sometimes the community, I can see you've got SQL Server down there. So that transition from that world to this world, how would you recommend people get started? Because you've been on this journey, right?
Yeah, so I've been on this journey, right? So I would like to think that my peers are open to other. So I was an MVP in SQL Server for a while. I was an MVP in SQL Server, but now I'm a data platform MVP, and I think and I've embraced that. I like I said, go to the Microsoft site, go look at the examples, go to your conferences, your SQL bits, your SQL Saturdays, watch things like Tech Days Online, yeah? For all of these people who are using the technologies that you've got a little bit of interest in, and start to learn, start to build it up. And I think Microsoft, with a lot of this stuff, like streaming analytics, like DocumentDB, Stroke, Cosmos, is they expose a SQL-like language as well to make it so that it doesn't scare you, right? Because even though this is a bit funky, it's not quite what we're used to in TSQL, you'll get your head around it in 10 minutes, right?
Okay. And I'm going to stop you there because we're going to roll a short video and we're going to drag you onto the couch because you're getting roasted alive by Christina. Sorry, interviewed.
Okay.
By Christina.
Okay, I'll leave my laptop.
Hi, Kim. Please could you tell us a little bit about yourself and what you're doing here today?
Sure. My name is Kim Nilsson. I'm the CEO and founder of Pivigo, the data science hub. And we are here, we are expoing. I am speaking tomorrow at a panel, and also we're running a workshop and trying to support companies getting started with data science projects.
Perfect. In terms of technology that's kind of influenced you in the past 5 years, what would you say the #1 area of technology would be?
Oh, that's a good question. I mean, obviously, we're a data science company, and so what we're really excited about is machine learning and how we can predict the future with it, and all the potential impact that will have on our lives, on how we work, how we stay healthy, how we live, how we have fun.
Perfect. And in terms of the next sort of 12 months and going forward, what area of technology are you really looking forward to seeing?
Well, I'm very excited about how AI might impact healthcare and how we can actually maybe predict illnesses beforehand or actually speed up diagnosis, speed up how we can become healthier individuals, and that's a really important topic.
All right, well, I hope you got a lot of information about Cosmos DB. I know I learned a lot from that presentation. Thank you very much, Alan. Welcome back, Andrew. So, you talk a lot about the Cosmos DBs for managing things that are planet scale. What's the largest Cosmos DB instance that you've worked on?
So it's 3 terabytes. Yeah, so 3 terabytes, and that was the MongoDB customer who had, and their architecture was that they had 2 3 terabyte clusters of MongoDB that they, as far as I could tell, shoveled data between one and the other backwards and forwards, right? So we took that and we ported all the documents into Cosmos DB, and like I said on the video just there, they didn't change a line of code.
So you were still using the MongoDB API?
Correct. So their front end had no idea, not a clue, and that's what that RoboMongo there did. It has no idea it's talking to DocDB, and And you saw the speeds at which it was coming back. It was electric.
To follow up on that a little bit, is there a reason, if you were doing like a new project, to use Mongo over DocumentDB if you're going to be using Cosmos?
If I was starting a brand spanking new project, would I use straight away? I guess it would be, what we always like to do is we always like to play to your strengths. So if you have a if you were previously a MongoDB shop, or all of your developers are really well versed in MongoDB, then use the MongoDB API, but put your data layer into a secure, massive, distributed, money back if SLA is not met data store. Yeah, so play to your strengths on the front end, but don't put it in MongoDB at the back.
Have Cosmos behind it.
Have Cosmos behind.
Yeah, because you haven't got the VMs. Presumably, Alan, in that case, that case you talked about having, like the failover, the other node. But obviously, when you port that to Azure, you just have the 3 terabyte environment, right?
Correct, because Microsoft create the replicas for you.
Yeah.
Okay, so that's what. Okay, yeah. Thank you for asking that. That's good. Okay.
Yeah. So behind the scenes, Microsoft had taken care of all that. What if this goes out the window? Boom, we got it. We've got it. We've got it. And you can replicate your data across the planet to better serve wherever it is that you happen to be. And yeah.
So obviously 3 terabytes, which is, I'm trying to wrap my mind around a database that size. That's huge. But we're talking about planet scale. Well, what if I'm just like country scale? Is there something that maybe I should be using Cosmos, or should I be using something else?
So if you've been watching the outpourings from Microsoft about Cosmos DB, it's very much about planet scale.
Yes.
Right? Because people nowadays want to store an awful lot more data, but it doesn't have to be like that. Right?
Okay.
If you genuinely are the Americans might call it a mom and pop shop, right? So you don't have 50 terabytes worth of data. You've maybe got a couple hundred gigs, 50, 20. MongoDB, Cosmos, I'm doing it again.
Love it, it's very
Cosmos is terrible. I'm going to go, when we finish, I'm going to go slap myself.
You have to rinse your mouth out with
exactly.
with soap.
Mm-hmm. Right, so you can scale up and down and you pay for what you use. So you're not paying for a planet-wide architecture just to have this little bit here. You're paying for this little bit here, but you're having the whole functionality like the replicas, like Microsoft managing this for you, right? But hopefully your business goes crazy nuts.
And
right?
It'll be able to scale.
And you can go, whoop,
and you can grow that way.
I think the other thing, Alan, you also mentioned with the law enforcement example, I imagine they want to keep it inside an Azure region, in other words, just inside the UK.
Yep.
So it doesn't have to scale across the planet if you don't want it to.
Correct.
Yeah.
Correct. So you're right. But you can have. But for them, it's more important to keep it in the UK or with partners.
Yeah.
Right. And B, it's to be able to have that expansion, to be able to expand, because as we know, more and more data all of the time. I can't remember what the figures were like. Half the world's data has been collected within the last 11 minutes or something, whatever that figure is, right? And it's only going to get, as more and more devices, we've all got 2 phones or 3 phones or 4 phones, right?
Fitness devices.
And fitness devices.
The number of IPs we have for our person is crazy.
Yeah.
Correct.
One last question for you. You talked about this very briefly kind of at the start and kind of again at the end, but I wanted to dig further. Cosmos DB is schemaless, but is it really?
So now you're into a question that will take all day.
Okay.
Right? So people call it schemaless, right? But that's only. So with SQL Server, you create a schema up front, yeah.
Mm-hmm.
But and you restrict what people can put into it because you've created this restriction. Things like Cosmos DB are schema-less on write, but you still have to be able to read it back. So you then impose a schema when you read, because you can't just say, give me everything.
Yeah,
right?
well, I was going to say, because this is why I was confused. Okay, so it's schemaless on write.
Correct.
Okay.
But on read, you have to be able to shape it into a person object, right? Yeah. Otherwise, it's just give me back everything, and and I want to show people, and I get information about the Xbox One. That is no use to me.
And it's also important, even on write, to say, well, if you're going to create a tag for person, that if you want to find somebody's name again and retrieve on that, you've obviously got to be consistent with that. So it's on the application developer to do that.
So you couldn't start labeling attributes of a person as A, B, C, D, E, F, and then just go through the alphabet and then start as A1. You're right. If you're writing things like a person object, then it's up to the application developer to write a first name, a last name, an age, a gender, whatever. So schemaless is often bandied around, but it's not really as wild and crazy nuts as all that.
Okay. Thank you for clarifying that. I very much appreciate it. And thank you for both of you for that great presentation. We were going to take a 10-minute break and more from Emily. Check that out. And we'll be back at 2:50 with Dan talking about bots.
It's day 2 of London Tech Week, and we're here at the Excel Arena for Tech Accelerate. Let's go speak to some people about AI and quantum. What does AI mean to you?
Well, AI probably, I'm not a tech guy, but it probably is one of the biggest tech trends. And for me, AI means make a computer equal as smart or even smarter as humans. And so far, when I'm talking to my phone, it's not as smart as a human, but I wish it would be. So I'm hoping on that would be the case.
AI means to me the realm of opportunities to harness computational power or the supercomputers and so on to make decision making faster, more intelligent and more evidence-based.
I mean, AI is essentially a better way of producing services for the consumer. I mean, ultimately, when you look at it from a telco perspective, there is very little innovation aside from the fact that you can offer data for cheaper or calls better. AI offers a bit of a way for the telcos to actually make money without having to compete with the OTTs by some innovations on the network, for instance.
Is AI a force for good or the end of mankind as we know it? A bit dramatic, but...
I think it's a force for good. I think the world is always changing and technology is part of our change and our daily lives, really. So I think it's going to bring greater things. So we have a Pepper in Vodafone that's kind of like, artificial intelligence. So we kind of teach her to do new things and everything. So yeah, I think it's a force for good.
It's a force for good. It's one of the best things that'll ever happen to us, I think.
There's obviously a lot of naysayers and a lot of people that are sort of terrified of the prospect of AI, but you look at everything around us, whether it's on social media, it already exists. Ultimately, you've got to look at the idea of a sentient being is so far advanced that it is theoretically impossible for compute power or even the technology that we're putting out onto the market at the moment. So, yeah, I mean, it's in theory good. It'll make a lot of people redundant, but ultimately that's business.
I think it's not a black or white situation. I think it depends a lot on the people that are doing the solutions and developing behind it. So it depends a lot on us. It can go either way. So that's why we need to make sure it goes the right way.
How do you think AI could help improve your job? Is there any areas that could be autonomized or anything that you think it would help add value to?
Well, I hope not to take too much away so I don't lose my job. But to improve it, yeah, I think maybe with our repair operation, if we had more AI, it'd be able to pick up faults quicker than what a human can. So yeah, I think there's benefits there.
So there's a lot of stuff that we currently do that it's just time consuming and we don't add value to it. I think what a person can add in comparison to a machine is a lot, but if we're just stuck with tasks that take the time off and we don't get to explore the creative side, I think we're missing out on it.
Do you trust companies with your data?
Do I what, sorry?
Do you trust companies with your data?
Yeah, I do. I don't feel like I've got anything to hide, and I don't really care if companies want to contact me. It's fine. I don't feel like they're going to do nefarious things with it.
I'm an old-fashioned kind of geek. I put everything out there. I accept all the telematics. Tick, next, I agree, not a problem. All I do, behavioural again, is I choose what I put out there. What they decide to do with that, that's fine. I don't really have an issue with that. I think what's needed is people to understand that what they say is more important, and the platform of the internet and everything else is neutral. The same as the telephone was when Alexander Graham Bell invented it, or any other means of communication. It is a medium. It is not the beginning nor the end, and that's what people should concentrate on. I think we're just still distracted by the shiny lights of the medium, will be my answer to that.
Do you think AI can be creative?
Not in the human way that we think of. I think there's always going to be a very unique approach of the human mindset and the human spirit. I don't think the AIs will reach this very soon, if at all. I don't think so. For example, a painter or a composer, I think that's very hard to replicate these types of creativity.
I don't think it's creative now, just purely because I don't think that the power is there and the levels of rational data. Whether it actually can be creative, I 100% agree, because I don't believe creativity is something that comes from the soul or something like that. You know, if you look at the basic concept of creativity, it's creating a novel idea or something that's never existed before. So by the basic definition of sort of data science, AI could evaluate absolutely everything, every book that's out there, and figure out one theme that is missing or not being collected altogether. Yeah, it's a very scientific way to be sort of creative, but ultimately it's achieved the same goal in that it's created something which has never existed before. So yeah, why not? Why couldn't it be creative?
Would you trust an AI, say chatbot, or some sort of artificial intelligence to set you up on a date, to match you with someone for a date?
So as I'm married, no. But in general, if I were younger, I mean, I met my wife online already, yeah? So I met her already through algorithms or whatever. So of course, I trust those technologies the way I did before. So why not use technologies that find even more suitable women or whatever, although now I'm already here, I'm married, yeah, so.
That's the point of no return.
I don't think that would make my husband very happy, but I mean, just for the fun of it, I would say yes.
We've had a fantastic day here at London Tech Week, talked about AI and quantum, but back to you in the studio to find out more.
We have so many people who are non-verbal, but still have so much to say.
I want the exact same information that my hearing friends have.
There are barriers to communication everywhere, but I think it's time we look at the barriers as opportunities to reach out to everyone.
Soundscape fills in a lot of the mental map as you move.
Approaching intersection.
You can just put it in your pocket and go.
With ALS, you become locked in. But we see technology as a way to give back what ALS has taken away.
There's no better feeling than to hear a child say something that they've wanted to say and the look on their face after they've been able to say it.
When it's reading, I see spaces between the words, and it's easy to focus on.
Anjay realized that here was something that could change his life.
Now that I have my phone, I can see exactly what was said, and that's been a huge help to me.
The system is learning as it goes, and the accuracy has improved tremendously.
Students can pick any language that they choose to receive the information. It's like we jumped into the future.
Because communication is very important for all of us, and we just want to be together and not feel left out.
Aider les personnes avec autisme à communiquer, il y a des images
Je parle, je donne une information à Arthur et elle est traduite par l'application El Picto instantanément en pictogramme et après d'une façon orale.
Va t'habiller et te brosser les dents.
On va pouvoir remettre en place une communication qui est plus spontanée. Je crois que ça aide à recréer du lien.
Both my wife and I are totally blind, and we have a 3-year-old son that's in preschool. He can see, but his parents can't. So to be able to know what's going on at his school is everything. The Seeing AI app has the ability to allow me access to the visual world. Artificial intelligence is beginning to have an impact on the lives of people with disabilities, but it's only going to grow. There is still so much out there to be done.
And we are back, and I'm now joined by Dan, and we're going to talk about CherryBot and kind of hear your story about building, using bot framework and building a chatbot for a football league.
Yes, thank you. So I'm going to talk about CherryBot. I'll explain why it's called that soon. So CherryBot is a bot built on the bot framework using the AI cognitive services in Azure, and its purpose is to increase fan engagement for the club. I'm Dan, I'm CTO of Greenwood Campbell. I started life as a back-end developer, and I still get a chance to roll my sleeves up every now and then and get my hands dirty in code, as I was doing a lot on this project, in fact. There's another caveat, which is basically I'm not a front-end developer or a designer, so you'll notice from the state of some of my slides that I'm definitely back in back-end land. And I grew up almost completely uninterested in football. So
okay, so you're uninterested in football, you're not a front-end developer, but yet created a chatbot for a football team.
Yeah,
cool.
That's right. I mean, I've had a lot of help from guys in the studio as well, but
sure.
I know a little bit more about football now, not much. So I'm going to tell a story about how we created it, the struggles we had, and what the future of it is. Basically.
Awesome.
Okay. Greenwood Campbell, the company I work for, our strapline is we transform and accelerate brands using technology. Sounds exciting.
That's very buzzworthy.
Yeah, I know it is.
Buzzwordy, yeah.
But like I said, we're in Bournemouth, which we refer to as like the Silicon South of the UK. So
okay.
It's like the fastest growing area outside London for digital.
Nice.
So we're amongst lots of friends here. And we started...
So you're kind of like the Seattle of kind of like the tech scene, because we consider
like the
ourselves...
cool side of things.
Well, that's what I'm saying, because we consider ourselves like the everyone's in San Francisco. The cool people, all the real stuff is happening in Seattle.
Yeah, those in the know.
Yes, exactly.
We started life as like a traditional .NET house. So we used to build like ASP.NET websites in web forms, and we gradually moved over to MVC and so on. But about 12 months ago, we pivoted and started looking at emerging technology, probably because of lots of cool stuff happening, and also it's just fun to work with, right? So I'm going to talk to you about the project with AFC Bournemouth. They are a Premier League football team. They're known by their fans as the Cherries, and they're the smallest football team in the Premier League. It's a proper like rags to riches story. They started in like Division 3, and with a manager, Eddie Howe, they gradually got brought up to the Premier League. So it's a proper underdog story, really.
And so by smallest, does that mean like least amount of financial backing? I apologize, I'm not from
small
here.
In terms of what their stadium's only 11,000. So
gotcha. Okay.
You coming from the States, Christina? There's college teams like that
there are
have
high school teams
70,000 capacity and so on.
There are high school stadiums with more than 11,000 capacity.
Yeah, exactly. So AFC Bournemouth 11,000. And they're on international television with that in that stadium. So they're a small team. Okay?
But I love the story. That's great.
And you've probably got one guy who's also like on the ticket office, who's then later on like putting the cones on the pitch and so on. That's the size we're talking about here. But we've been with them since the early days as an agency, so we had a lot of trust with them. So the great thing was we were able to work with them on an emerging tech project and allow them to be daring and do something brave, basically, which not... I mean, there's other football teams in the Premier League that have done chatbots, but nothing that's done anything to do with AI or cognitive services or the sort of fan engagement sort of flavour that we've used in this one. The story of this began actually with the help of Microsoft, a lot of help from Microsoft, in fact. So basically it started in November last year. There was a hackathon, and then before the hackathon started, we knew that we had to plan this for the right client, right? We knew AFC Bournemouth would be the perfect for a fan engagement piece. But they said, oh, okay, that's a great idea. We'd like to launch this at a Liverpool match in December. So we had like 6 weeks from the hackathon. In fact, it's probably less than that because the hackathon was probably like beginning of the month in November. To take this from hackathon state of code to ready for the entire world to look at and use potentially when it's broadcast on international TV.
And having to then deal, have the results and get feedback and whatnot. And before this, we were talking beforehand. You said that you had built your agency. You built a chatbot project before, but it was unofficial. So this was not even. This wasn't like this is your bread and butter where you're building bots all day.
No. So we started looking at emerging tech, and so we were quite brave as well, I guess. But then generally that's the sort of thing agencies do, right? We do just sort of like fly by the seat of our pants. And so yes, we worked on this bot project. The guys at Microsoft that helped us, one of which is Jamie Dalton, I remember seeing him before the hackathon, and he was like, you are going to come to the hackathon with some code already written, right? Like that, 'cause he already knew that like it needed to be launched on the 16th against Liverpool as well, so they're a major Premier League football club. So basically the eyes of the world were going to be on this product, and he was just hoping that wasn't going to turn up with file new project and just go, okay, come on, help me guys.
He's like, I don't have enough time.
Yeah, exactly. So as well as the actual hackathon and the inception of that project, there was a few late nights involving me coding away before, during and after as well. But we actually got really involved. So the club, like I said, they were small, and so we helped them not only with actually building this product, but promoting it as well. So we got the players involved. We had them using like the early prototypes of the bot, so that we could film them using it to get excitement from fans and build it up. And then we actually had we worked out all their comms and all their imagery, and we did all of that for the club basically.
And this was running on Facebook, correct?
Yeah. So actually, I think to a layman, you wouldn't even know that any of this is using Microsoft tech. It's just built in Facebook Messenger, as you'll see soon. Well, I say built in Facebook Messenger. The front end of it, appears in Facebook Messenger, right? But
it's a Facebook bot, I guess, is what I'm saying. But behind the scenes, it's using the bot framework.
It's going through to a bot hosted in Azure. It's calling through to cognitive services, storing data in like Blob and table storage and all this sort of stuff. So actually, there's a whole heap of Microsoft tech used, exclusively Microsoft tech used, but actually it's all hidden behind the scenes via a Facebook Messenger bot. Another exciting thing to say is that like even Microsoft guys were actually dressed up in AFC Bournemouth hoodies, branded up with CherryBot, handing out flyers, telling people how to use it, and basically trying to just get boots on the ground, people using it and getting excited about it on the match day as well.
That's good. That's good.
So, get lost where I am on my slides here. Oh, there we are. Okay, fine. If I can click play. Can you see that? Is that animated?
Yes.
Yes. Okay, so there's like a little example of what it looked like, basically. So why did we do this? So, like I said earlier, lots of football clubs have done bots, or they've dabbled with it. Like they've done it with like free services and stuff, like sort of like template bot creation services. But it's never been anything really much more than like how do I find parking, or how do I get a ticket, that sort of thing. Like a simple Q&A. We want to do something much more exciting. As an agency, we're quite small, but using like the tech in Azure, we can use amazing stuff, right? So we can do cognitive services like Face API, Emotion API, all that sort of stuff to bring a bot to life, basically. And the reason we created a bot is because the whole sort of user demographic, you think of like, young people nowadays, they're fluent in using like WhatsApp, Facebook Messenger.
Yeah.
No one really cares about downloading apps anymore. Some people do, but they don't really last, or they're not used that much anymore, but they're fluent in using like chat apps, right? So if the brand or AFC Bournemouth can chat and engage with their fans using that medium that they're already using anyway, then they're going to get better engagement. And also like the monthly active users on chat is astronomical.
Yeah.
You've got more people combined using WhatsApp and Facebook Messenger than use Facebook itself per month. It's something like 2.5 billion monthly active users. And the open rates, if you send a push notification on something like on Facebook Messenger, the open rate at the moment is something like 80%. Whereas on email, it's like less than 20.
Right. No, I was going to say, if you get an 80% open rate on email, then you're doing, like as marketers, oh my gosh, they would be dying.
Yes.
But the fact that you're getting that on chat, I mean, that's very impressive.
Yeah, and that might not last.
Right.
Because, Facebook Messenger is quite new. People get excited. They think it's stuff from their friends. Right. The more people that start creating bots,
and they might be
people
like,
might tire of that. But right now, at least
for now,
it's an opportunity. You can use this tech, create stuff for brands, and get great results.
Very cool.
So I'm going to show you a video, hopefully if it works, which basically just demonstrates exactly, or sets the scene really. So hopefully if I can just press the play button, he says.
Yes, as we try to see if we can get this video to work.
Look at that, I'm pressing the button. There you go. Is that working?
It's not playing.
You've got to love tech on the day, haven't you?
No, I know. I mean, honestly, it's yeah.
I'm gonna try
there we
more.
go.
That looks better, but it's not playing, is it? Tell you what, I'm just going to task switch to Chrome and load it up in YouTube, my favourite.
Okay.
This is where you see all my kids' videos appearing. So. Yeah.
So you started working on this in November, and then it was launched in early December?
Yeah, 16th. Yeah, so we had like 6 weeks. So my entire sleep pattern completely changed basically as a result of doing this. Right, hopefully you guys will be able to see this now. Right, let me just rewind.
Oh no, you need to exit.
Oh, I see. Sorry, my bad. Drag it across. There we go. Stick it on full screen. I'm assuming you guys can hear the audio.
Emerging technology is at the heart of everything we do. We wanted to create an innovative solution for fan engagement which embraces artificial intelligence and offers a brand new communications channel. Using Microsoft AI technology, we created a chatbot within Facebook Messenger that will take fan engagement to the next level. Knowing that AFC Bournemouth are always looking to capture their fans' imaginations, we took our concept to the club's digital team and presented a chatbot solution, CherryBot. The club loved the idea, and we began a 3-month collaborative process of refinement and development, which culminated in testing the bot with the football players.
We love to try and be at the forefront of new technology. Anything that's new and out there, we like to explore and see if we can use it to help better engage with our supporters. And hopefully CherryBot is the first step towards that.
The main features included were Man of the Match, a selfie competition, and FAQ, which automates personalised answers to commonly asked questions. We created a comprehensive comms plan, which included promotional videos, direct and digital marketing campaigns, PR strategy and branded uniforms, all of which include a successful launch at the Liverpool home games on the 17th of December 2017 with exceptional fan engagement.
The project so far has been a great success for the football club. So the future of CherryBot hopefully is going to be a full-time recruit for AFC Bournemouth moving forward. We're looking at getting a commercial partner to be associated with CherryBot and integrating a number of features within it to benefit our supporters and hopefully benefit a commercial partner as well.
Awesome.
Okay, nice.
Great.
I'm just going to crook my neck back around
Yes.
to stop autoplay in the next review of a Domino's bot.
No, yeah, we definitely don't want that. Were all the users of the bot actually in the stadium?
No. So this is the point, right? So the bot was designed for fans in the stadium, but also fans outside the stadium. The whole reason for AFC Bournemouth being really interested in this was they wanted the fans to feel closer to the action on the pitch.
Okay.
They never really have a problem filling the stadium. That's always a capacity, especially with the size
of it.
But either way, they want people to feel that they're closer to the action, because often, like, especially with football in the UK, the fans feel worlds apart from actually the players. They're on so much money and all this sort of stuff, that they wanted to feel like a much more sort of grassroots level kind of connection to the action going on. And so this is the whole purpose of that, basically, to allow that to happen.
Very cool.
So I'm going to flip back to my slides. You can probably see them, but I'm going to... There you go. So in that video, the highlights of that was that there was 11,000 fans using it, about 20,000 messages. The number changes depending on when I cut the figures. And we had a massive social media marketing campaign that meant there was like 3 million social impressions. So
that's awesome.
There's a lot of excitement about it, basically.
And over what time period?
That was just about 3 days, something like that. But the thing is, right, so it happened in terms of a product launch. It was the worst possible conditions you can have. Bournemouth, the year before, they beat Liverpool 4-1 or something like that. They got thumped 4-0 at this game, and they were 3-0 down at half-time.
Oh, no.
And so the fans... the impression, like, we were able to see from like the emotion, the results from people's faces when they're taking selfies, it did dip slightly, or their engagement sort of like went off a cliff after half time, basically, when I guess sort of like the desperation kicks in and the emotions of people leaving the stadium early.
Just going, I can't do it. I can't watch.
Yeah, absolutely. So, any clues for who designed this slide?
I like it. I like it. I mean, it's clean.
Yeah.
Clean.
Absolutely. Thanks, Microsoft PowerPoint. So the tech approach. So it's written in C#. I know you can write bots in Node.js. I'm a C# guy, so we wrote it in C#.
You were a C# shop exclusively, and
yes.
now, okay.
Yeah, exactly that. It was built on the version 3 SDK of Bot Framework, and that's because we started dabbling it early in the summer, and then I think it went into general release actually midway through the project, which was exciting. But it uses the standard dialogues, and there's about 20 of them. I'll talk through some of the features later.
Okay.
But there's not 20 features, but there's a lot of dialogues. And we use something called scorables as well. And the thing about scorables is that's a way of basically allowing a user, wherever they are in the bot, like when I say in the bot, in a conversation.
In a conversation with the bot,
it allows them to say, fan selfie. And then suddenly they'll go straight to fan selfie conversation, rather than it saying, oh, I don't understand what you mean by fan selfie, you're trying to vote for man of the match or something like that, you see. So it allows people to immediately say what they want and get what they want, because one of the learnings when writing a bot, you're not writing an app. You're not writing something which has buttons that users can click or not click. These are people that, first of all, they're not even software users. They're people at a football match.
Right.
They will write funny things, and they will try and break your bot.
Yes, because it's fun to try to break the bots.
Yeah, and they will be incredibly unpredictable with how they use it. And there's a lot of learning that you gather from launching something like that.
So let me ask you about that. I'm sure you're probably going to get more into it, but how much of a challenge was that for kind of getting into the UX, especially with letting users know, for instance, that they could say, you know, a fan selfie anytime. How were you able to how did you approach, I guess, teaching them the features?
My first approach was as a natural sort of like software developers, well, it shouldn't work like that. You know, they shouldn't do it like that. But guess what? They're going to, and you can't stop them. So scorables didn't exist before, and that's what we introduced to allow people to say, I want to use vote for man of the match now, or fan selfie, or whatever. One of the other things that is interesting from a UX approach is if you midway through your project change buttons or text commands that your bot accepts, if someone's already previously conversed with your bot in Facebook Messenger, they'll still have the old history.
Okay.
And they're still able to press those buttons, and so you need to understand that as a developer.
That's a really good thing to know, because if you change things in a different way or got rid of maybe a button type, then them pressing it would make something not happen.
Probably not happen, or it'll go, I didn't understand that, or something like that. So that's really important. So it's things like that, and I'll get onto that later. But like I said, it's hosted all in Azure. It was written in a few weeks by 2 to 3 people, and there were a lot of late nights involved, like I said. and had the hard deadline. I think it was 16th of December. They changed it to 17th, not for us, but for Premier League football scheduling reasons. So the features, I won't dwell on that side too long. So selfie competitions. So the idea of this was that fans, either at the match in the stadium or before the match started around the stadium, they could take a picture of using their phone. I'll grab my phone here, just thinking about it, and take a picture during the bot, using the bot, and it would basically
do the selfie.
Yeah, exactly. Take the selfie, and then that would appear in the chat, and the bot would actually say, "Oh, why do you look so sad?" Or "You look happy. You look happy. Happiness looks great on you," or something like that. We had like a random selection of different cheeky quips based on the emotion that comes back from the photos.
I guess you're using the cognitive toolkit for that. So you're basically sending the image, to your back end, and then have it, because it's being hosted in Azure, and then that's doing all the processing.
Yeah, so we were using quite a few of those, and I'll show a lovely architecture diagram in a second. But we were using the Emotion API for that. And that's, I guess, the headline cognitive service in terms of this bot. It's the most obvious. Interesting thing is, it also happened because it recognizes emotions, it also recognizes faces in one shot. And so you'd have people taking selfies where there's multiple people in the picture, for example, like a mum and her 2 kids or something like that. And so we had to handle that and then come back, and the bot would then say, right, first person, you look happy. Second person, why are you so miserable? Third person, why so shocked? So that was the selfie competition. And the idea with this was that once you submitted, you could share your selfie after you'd read what the bot's response was. And then that selfie would then appear on a wall of selfies on the stadium screens.
Oh, cool.
Right? So therefore, we used a moderation API to prevent people from submitting anything dodgy, or away fans or whatever getting hold of this.
Yes, but also, as you said before, people love to break bots, and people knowing this would definitely love to take.
Well, also, if you know that there's some sort of social product results in images that you can submit appearing publicly on screen somewhere, everyone has a go at that, don't they? Especially football fans, who are hoping the other team lose. So that was the selfie competition. I'll explain more about the nuts and bolts of that later on. Then we had MOTM, or Man of the Match. So this was another reason, or allowing fans to get more involved. So we had a back-end CMS, or content management system, that we wrote that allowed the club to select the players that they wanted to be available as man of the match, because you think, oh, I'd want to vote for any of the 11 players, right? But I think it's 11 players. This is my football knowledge. 11 players?
I don't know. I'm not going to pretend to be able to correct you.
Okay, fine. Any of the available players, right? But no, the club want to have like 5 or 6 people or players that they say, we think these are the contenders for man of the match. And then, so they would then select those through a tick box list. And then as a result, you'd then see a carousel of those selected players within the bot. When you said, I want to vote for my man of the match, you could select the one you wanted, click vote. And so
to connect with that CMS, you were just, I guess, just writing some stuff in C# to pull in that data, and then I guess using the polling functions of the bot, or?
So the CMS was simply just an ASP.NET like web app, storing data in table storage, and then we would just, every time someone votes man of the match, it would just request the latest version of that content. I think there was caching involved, but I can't quite remember.
Okay.
There were, like I said, the late nights and coffee and everything. And the results also were stored in table storage. So when you voted, you could vote again, but your vote would be cancelled from the previous one.
Oh, that's smart. That's smart, because yes, because that's because football fans are going to do that.
Yeah,
but, they're going to try to game the system. Absolutely.
And then videos. So this is not really a sort of like a Microsoft particularly involved thing, but we had videos that you could upload via the website.
Nice.
And they would appear natively within the bot. The annoying thing with that is with Facebook is you have to actually upload them to Facebook.
Yes.
You get back an ID, which you then put as a chat identifier in the chat.
Right, and so which makes it then harder to share that. Like with the photo, you can share that out other places, but with the video, they kind of like to keep their own.
Yeah, and it's a bit of a nightmare because actually, as far as us writing a content management system in ASP.NET, when you uploaded a video in the back end, it then had to do a push to Facebook, get back, and so on. So. Yeah, and this is the thing with writing a product like this, you have to contend with lots of different things and the quirks of how all these things work. So you're basically a master of connecting things together, basically. So further features, so there was some quite cool stuff on this. So we did use Q&A Maker. I think that's just gone to general announcement or general release.
I think so.
Yeah, but when we first started using it, Jamie at Microsoft and the CSE team, he was like, oh yeah, use Q&A Maker, it's quite new. And so we used that as a really easy way for the club to upload simple questions, like, you know, how much is a pint of beer? Where can I find, how can I get a pie? Where's the parking? All the stuff that I was saying was boring earlier.
Yeah.
We still got it in there.
Oh yeah, because I mean, it's
part of the
useful.
bot,
Because
right?
I mean, most people are going to probably use it for the selfies in this
Yeah.
instance, because you're going fan focused. But that doesn't mean that it can't still have those other useful features. If you're in the stadium, you want to figure out, where's parking, where's the bathroom, you know, how much is beer.
It was an opportunity to also bring in like the character and the sort of like the tone of voice of the club. They were able to bring in their personality in the sorts of questions. You could ask funny Easter egg style questions as well, like what's your favourite colour? The bot would reply with the colour of the strip and all this sort of stuff, you know. So it was quite a cool opportunity just to get some fun stuff in as well. We used Lewis, so the bot could actually understand the intent and understand actually what someone's saying. From the numerous ways people can ask a question, we'd understand. Like I said earlier, we use native Facebook dialogues. So Bot Framework comes with some standard card style dialogues like carousel, menus and various things, but we wanted to actually make use of the specific Facebook dialogues to get the best experience. The Facebook documentation for that is quite difficult. Lots of it's undocumented, so if you're looking into that, it's going to be a fun ride. But we got there. Maybe I should stick it on some sort of like NuGet package or something like that.
No, I mean, honestly, I think you should.
Yeah.
Put it on there or put it in GitHub, do something with it so that people know.
Cool.
I think a lot of people will be interested in that.
Yeah, nice. Oh, and also Graph API lookup. So what we didn't want to do is for the bot to go, oh, hi, what's your name? Or something like that.
So it was able to immediately greet the
with their
user.
name.
That's awesome.
Because as soon as they connected, we did a Graph API lookup against their Facebook profile to get back their name. An interesting thing is you only get back a very limited profile data from Facebook if you're doing a bot, because you just get back the messenger profile, not their full Facebook
Not the full thing.
Yeah, which you'd expect, right, for privacy.
Well, I mean, Cambridge Analytica would say
that's
different
a bullet
things.
point later on. That's a bullet point later on, because that's one of the struggles we had. And there are some other Easter eggs and help menus and so on. So I was going to show a demo, but I can't because.
Well, we saw the preview beforehand, but I mean, is this bot still active?
It is still active, so that's what I was going to say. So instead of showing a demo, just look it up, right? So basically, go to Facebook Messenger. In the search box that appears, you can basically, in fact, maybe I won't show a demo, but basically, I'll go like this. There is the bot working. Basically, in Facebook Messenger, you just have to search for the word CherryBot. You can find
CherryBot.
And then basically, you can start saying whether you agree with all the things I've said about it, about how great it is and how fast it is and scalable and so on. So, but yes, I'd recommend you have a look at that.
Okay.
Yeah, you can have a look later. That was the video that I don't need to play.
Okay.
You can just look it up yourself and just be braver and let you guys have a look.
And then this is the architecture.
Here is an architecture diagram, which I'm very proud of. I can't show a mouse, can I? I might have to just go like this in that case. So we're using loads of cognitive APIs. So we're using Vision API, not for much actually, just generating thumbnails. So when someone took a selfie, you didn't know whether they were going to take the picture sideways or upright. And so we'd use the Vision API to create a thumbnail because it automatically works out the focal point that's interesting in an image. So we used that was really cool. We used Emotion API to detect faces and emotions. The 7 emotions, I think it is. We used Lewis to work out natural language. And then we used Content Moderator to flag content. That was quite fun testing that, because honestly, if the developers in the studio were like, what are you looking at? Oh no, I'm testing the bot. Oh, okay.
Yeah, you were like, please don't, like, you know, fortunately you own, you own the firm, so you don't have to tell IT, I promise.
I don't own the firm.
Oh, you don't own the
Not
firm?
yet.
Okay.
Not yet.
Okay,
Not
well,
yet.
we partner with the firm, we work anyway, they know that this is for work, so the IT guys are not gonna flag you. Okay.
And the other thing was we had App Insights running, not on here actually, but Jamie set up behind the scenes a Power BI dashboard for some of the analytics. But one of the cool things we had is we were storing all the results and selfies and so on in storage here, but we had a function running. and that function would scrape Facebook to see when someone submitted a selfie, it would appear on AFC Bournemouth's Facebook wall, but it was moderated manually by AFC Bournemouth. So even though it went through content moderator, they wanted to actually...
they wanted to ensure that it was...
Yeah, because something might not be adult content, but there might be other reasons why they don't want it to appear, like historical, stuff that's like controversial.
Of course, and there might, they might not just want things auto posting to their page.
Yeah, sure,
if you've got, thousands of people, you've got 11,000 fans using this, you don't necessarily want your
absolutely.
page to now be taken over with this. Yeah.
So that was one of the jobs we had on the match day, was actually going through, just clicking approve on everything, basically, because everything actually turned out to be okay, but we were worried. So we had this Azure function that would run, scrape their Facebook page to look for IDs that matched against IDs in the database. If it found one, it would mark it as approved in the database, which then meant it was safe to appear on the Stadium screen on the web page. So that was the reason for that, basically, to make sure that nothing appeared on the Stadium screen.
It was not already approved by the club.
Yeah. So it meant that it had been manual. It meant there was one single approval that then meant that you'd also see it on Stadium screen.
That's clever.
Yeah,
that's clever.
Cool. Thanks, Jamie, for that idea. So, architecture-wise, like I just said and described in the diagram, it's a chatbot. We used just pre-trained cognitive APIs. We didn't build anything clever ourselves. We were just using the off-the-shelf stuff. There's plans in the future for us doing something with player lookalikes, which will involve training like Vision API with certain models and so on. Like, who do you look the most like?
That's a fun feature.
It would be cool. It would be cool. Yeah. There was also an Umbraco CMS website, the Azure web app website, the function, data layer, and we had loads and loads of load tests, which I'll talk about later as well. Challenges, these are interesting challenges, because some of them aren't technical, some of them are sort of like things you wouldn't really even think about when you're building a project like this. One of the ones was, and we were talking about this earlier actually before we started, was the tech itself, right? Bots. Some people know about bots. The general public, especially sort of like without wanting to, people that aren't technical aren't likely to know about.
Yeah,
bots
no,
yet.
I mean,
it's not in the public masses.
If it's not something that if you're not somebody who's keeping up with this stuff all the time, it hasn't become, at least in the UK and the United States, it's a little more in other parts of the world, but it hasn't become a natural thing that everyone does.
So me earlier saying, load up Facebook Messenger, search for Cherrybot, that might come as a surprise to someone that they can actually search for a bot and talk to a bot on something they normally just use to talk to their friends. So bots itself, there's a bit of a learning curve that we need to get over with the general public using it. So that was one of the challenges we had. The second challenge, it's just new tech, right? We need to get our heads around bot framework, integrate with lots of different areas within Azure. The technologies themselves, some of them actually hit GA during the development cycle, and they changed as a result. And so we had to quickly go back and change code that was working. That's fine. That's just the life cycle of code, right? There were black holes in the dialog path. So this is really interesting. Like I was talking about earlier, it's not an app, it's a conversation. You can't predict what people are going to say, but you have to handle that.
You have to have some sort of response.
In the early days, when we first started doing this, users would find themselves, or when I was first testing it, would find myself with not any way to get out of the conversation. I'd got into a corner and I couldn't back out, basically. And so we had to really carefully think about how the conversation flowed in the dialogue, handle people just wanting to quit out from where they'd started a certain menu, gone through a certain menu. Even the word menu, I sort of like, it is technically correct, but you need to get your head out of that way of thinking when you're writing a bot.
Right, because there's no interface.
Yeah, the interface is just words. I mean, you can have buttons and stuff like that which help the user, but ultimately they're just sort of like the training wheels on what it should be a conversation. They help the user understand what's possible, but that doesn't mean the user's going to use those buttons. They could type anything they like. Then comes Facebook. So my 2 points on Facebook. If you're releasing a bot and it's on Facebook Messenger, there is an approval process.
Okay.
So you need to understand this, a bit like the sort of like the Apple App Store process, where people would like pray a week later.
Please let me get this through, because it used to take so long.
My deadline's in a week's time. It takes a week. Surely, let's hope it gets approved. So there's that to contend with. But then also, luckily, this didn't actually affect affect us during this project, but it did for other projects, was during the specific Cambridge Analytica scandal, Facebook themselves stopped all new bot and app registrations. So it's just a reminder that when you're using Facebook Messenger because it's an incredibly popular chat platform, but it's someone else's platform, and so you're at the mercy. Yeah, absolutely. So that was a major challenge we had. Next thing comes to the testing. So this is, we were worried, right, that moderation and performance would be a problem. Moderation because football fans can do what they like, right? Especially away fans. So we needed to make sure it wasn't abused by those fans. There's a really good example. I won't name the brand, but it's a very popular crisp manufacturer in the UK. And they had a campaign where you could submit a picture of yourself, and Gary Lineker, probably a good clue there, would be holding his arm around, and then that would appear on screens live, and there were people uploading pictures of like serial killers and stuff like that, and it was just appearing with no moderation whatsoever. Oh
God, so I don't mean to laugh because it's terrible, but it's, yeah.
You need to think about it.
Absolutely.
You need to think about it. So
you need to anticipate how the public is going to use what you're building.
Yes, and that's where I think the sort of like the moderation API, it handles adult content, it handles racy content, but there's loads of things where some content in one scenario is perfectly fine, but in another scenario it's completely unacceptable. So that's one of the things we had to contend with. And the other thing was load testing, right? This had the potential, it could go viral. It had very sort of like peak demand. It could have hit during 90 minutes of a football match. And so we load tested it on VSTS. We created a test rig. We did full load tests uploading images because we thought that would be the most performance hungry aspect. And we just needed to get confidence that it would be ready for the match day, basically, which it was. So I'll show you some cool graphs here. So this is our load test that gave us the confidence, basically.
Okay.
That little dip there, I still struggle to work out what that dip was. But the problem was it wasn't too much of an issue because it suddenly resolved itself and was absolutely fine going forward. So I was quite happy. And then here is the Power BI dashboard that Jamie created. So
nice, that shows all the
stats. Stats. So the little pie graph at the end there is basically the gamut of emotions of all the photos.
Oh, that's amazing. Basically. So the Power BI was able to even pull in the emotion graph. That's
so you
great.
see most of them are happy because it's basically families posing with their kids wanting to win an Xbox, right? So they're going to try and look happy. So the future. This is quite exciting. So in February, I got to go to Seattle and I looked at the V4 framework, which is not released yet, but it's available for you on NuGet. You can have a look, you can download, you can create a bot using it. Not ready yet for sort of production quality, but you can do it.
But you can get a sense of what it's going to have.
Yeah, and one thing I would say is it's entirely different to V3.
Okay.
It's the equivalent of, if you've done web development, it's the equivalent of going from web forms to MVC.
Okay.
It's like, instead of driving down the motorway on a car, it's like driving on a motorbike, basically, in terms of it's thinner, it's lighter. You sort of have to do more, but you can write less boilerplate code as a result.
Can you reuse any of your V3 code?
Not really. When it comes to dialogues, no. If you've got helpers and you've architected it nicely, you can reuse all that. But when it comes to the actual dialogues and stuff, the concept of dialogues itself doesn't even exist in V4 yet, at the time when I was looking at it anyway. There are other, they call them topics you can use. There was a framework someone had released, one of the engineers had released to add on top of this called topics. A little bit similar, but not quite. So you can't upgrade, you have to make a decision, and V4, as at the moment, is being considered not suitable yet for production quality stuff. But that will be. We started writing the next version of CherryBot in V4 as a separate side project, basically. I've not upgraded or anything. I've got it as a separate branch.
Right.
But one of the really cool things about this whole thing was we actually managed to create a white labeled product from this.
Nice.
So CherryBot was for AFC Bournemouth, the Cherries. Then we realized, well, hang on, this is a fan engagement bot that we could reuse for any sports club. In fact, not just football.
It doesn't have to be football.
You know, it can
other
be
sports,
other sports, especially in the States. You know, you've got like football, baseball, hockey. Really exciting. Really, fans that really emotive. Who want to get
basketball.
involved.
Basketball, just because the championship happened last week.
Oh, cool. Okay, there you go.
LeBron lost.
As you can see, I'm not. No,
I just know that
my knowledge of football is probably the maximum in terms of sport.
I just know people were very upset about LeBron losing. And the Warriors won
maybe
again.
they could have.
It would have been great.
Suggested that through a bot then about how happy they were.
It would have been good
too.
He could have used his Samsung phone in some sort of way. There would have been some sort of tie in there. Yeah, I'm just thinking about all the brand synergies.
Yeah.
Yes.
So Matchday Bot is the platform. So that is what we refer to as like the fan engagement platform. Yeah. So it's a box product that we now offer to our clients basically. We've had quite a lot of interest from other football clubs as well, not just in the UK, but in Europe as well, so it's pretty exciting.
And is that also going to be running off of version 4 once that's ready to kind of go? Do you think you'll refactor that?
It depends. If we get like a major club come in, it depends on their timeline, basically. I wouldn't want to upgrade to V4 just yet if they say we want to go on this straight away. So right now, our current code base.
That's what you're using what's stable, but I mean, once V4, I guess, once that's rolled out, do you anticipate that you'll then update
I think so.
the Matchday Bot?
But once we get a sports team actually drive that change, basically, then we'll do that basically. So there it is there. Upcoming features, I'll gloss over those because this isn't really about the features, it's about the tech. But basically, like I said, V4 bot framework, and there's cool stuff we're going to do, like push notifications. Integrating with APIs to give you like results, live updates, and all that sort of stuff. Basically.
That's really fun.
Yeah.
That's really fun.
So that was it. That was me.
Amazing.
Dan Meinert, CTO at Greenwood Cavill, talking about CherryBot.
Dan, thank you so much for talking to us about that. And I think this has been a great use case to see how you can start from a hackathon and within a month basically have not just an MVP, but something that's actually in the market and is getting real engagement. Yes. And it has been evolved into a real white label product that you're going to be sharing. So we have a very short video, and then we'll be back with Andrew and Luke. See you in a bit.
We are selling a product, we are selling also the excellence in supported services.
Customer support and customer service is a huge priority to the company. We have over 600 million contacts per year. Microsoft's advanced AI gave us an opportunity to look at better ways that we could scale the virtual agent that's guiding them and answering their questions, trying to get the proper context around what the issue is. If the virtual assistant can't solve their problem, that information is automatically passed to a live agent so they can continue the conversation.
Artificial intelligence may be able to boost significantly the productivity of our agent.
It's going to cut down on call handle times. It's going to cut down on the actual overall wait for the customer.
The dashboard is critical. We're able to understand direct customer feedback, see key metrics around how the system is performing and whether or not it's resolving customer problems.
We were addressing maybe 15 to 20% of issues. We're now expanding that to close to 70 or 80% with artificial intelligence.
Microsoft's advanced AI capabilities is a win for any organization. And the platform that they are delivering allows you to get the scale and capabilities that are needed in order to implement AI in your business. We're looking at what other areas that we can apply this technology throughout our ecosystem as part of our digital transformation.
Give me a tool that allows me to say yes definitively and effectively, this is going to fix your problem. Bring it on, let's do this right now.
Hello and welcome back to Tech Days Online. I've just stolen a few minutes of time because I was so interested in what Luke was doing with the Ordnance Survey. I thought I'd drag him back on stage and talk about one of the things you casually mentioned. And as this is the Data and AI Day, let's talk about Databricks.
Yep, so we're going to have a 7-minute dip into Databricks. So here's a little high-level view of the platform. So really, the great thing about it is people like myself, like a data engineer or a data scientist or so forth, can come into this PaaS service. It's very easy to use. When we need to do some crunching, we can elastically spin up some commoditized Spark as a service. So the unique thing about Databricks and Azure is that it's a PaaS service. So there's very little management of infrastructure that you need to do to use it. So shall we crack on and get involved?
Yeah, so it's basically Spark and you just turn it on.
Yeah, that's it. So shall we go do that?
let's do that.
So here's my Azure portal. So here's my Databricks instance.
Yep.
If you want to turn one of these on, just create a Databricks and you'll be flying in a few minutes. Oh, we're on the wrong screen.
Just
there we go.
Yeah, we don't see Luke on the motorbike.
Right,
fun though that is.
So here's my Databricks service in my Azure portal, which I spun up earlier. You can have one for yourself in about 10 minutes, and here's my landing page once I spun one up. So we've got here's one I made earlier notebook on deep learning that we're going to talk through. So this is a this notebook is all about transfer learning using TensorFlow. So I've got an image set of flowers, which I'm also bringing up on the wrong screen. So let's show you a few bits about those. So we've got all sorts of dandelions, we've got tulips and stuff like that. And what we want to do is use a transfer learning technique to classify this data set. And so what I'm going to do is run this notebook now and then step through all the Databricks features that make this awesome and easy to do over a cluster. So we start, let me duplicate the screen. So we start on our first cell here by downloading from tensorflow.org the example data set I was just showing you. We wait for it to run firstly, and then secondly we'll run through it and then we'll show you stuff. There we go, so that's downloaded, really pretty quick. Then what we're going to do is show you that we've downloaded that stuff. So this is living currently locally to this node on our Databricks instance. Here's a little magic command for accessing the Databricks file system. If you ever want to use that, you can do the same stuff with that.
I'm going to stop you there because that's really important. You just put that % thing in whatever language you want to run. Yep. Your Python, R, Scala, or access the file system.
Yes,
we just can run them
that's
all
it, Spark
inside.
SQL, stuff like that as well.
Yeah.
And some of this stuff is like a bit of Databricks IP in there as well that makes it seamless. So this WASPC thing here, that's actually an address in a blob store. So say I wanted to not download that TensorFlow example and connect this to my blob store like an HDFS, I can do that as well. Moving on. So what we're doing in this tutorial is then we're going to take a little sample data set. We're going to copy this for tulips and daisies into a little sample area, which is running here. So I think we're going to beat it, but then let's go back and see the examples of it.
Yeah, sure.
Sure. So we're copying those data sets into a sample here. So we can see here we're grabbing a load of daisies, we're grabbing a load of tulips. Then what we're going to do is load these into a Spark data frame. So a Spark data frame, for those of you familiar with the likes of pandas and so forth from the Python community, this is the same sort of structure as that, but whenever you run anything on it, it runs over a cluster. So I can just choose to spin up, say, 10 nodes in my cluster here, use one of those data frames and compute stuff at scale, and that's the beauty of this ecosystem. So going back to my notebook. So we have these images loaded up, and this image schema thing, which we can use to load up images into a data frame, that's a bit of Databricks IP that we can use to make this stuff easier for deep learning activities. So to do transfer learning with this data, Databricks also has some other awesome stuff. Firstly, we're going to repartition this data, split it up in like typical data science fashion to start with a little training set there. Then following that, what we can do, and this is the really cool stuff, is there's this thing called a deep image featurizer. So this is part of Databricks ML beta that has just been released that allows us to do deep learning with GPU-enabled clusters. What this does is you take a neural network such as Inception v3, it removes those final layers that you'd use for classification and gives you the featurized output of the neural network. So say I want to then build a pipeline where I'm doing transfer learning, I can follow that with a logistic regression. That is just a standard Spark ML lib method there. And we can build a standard Spark pipeline using this feature. So essentially, we're taking the image data frame, running it over a cluster. We're then getting the features out of that using Inception v3, and then applying some logistic regression. And then this p.fit line will execute this pipeline that we've defined with those stages to featurize them and do the logistic regression. So following that then, we can run an evaluator. And again, this is more towards standard Spark ML methodology now. So that's a bit of a quick round tour of deep learning. So I see we've got 1 minute and 44 seconds left, so let's do something else. So we've got another problem that I've recently working on here. So I want to, I've got this interesting data. I've got 740 gigabytes of vector information. The problem is that all the quotes in these polygon arrays, they were all in the wrong place. So I need to pass all that data over that 740 gigabytes. And then also I'm using another technology that blows up if I use the 3D element of this data. So I want the option to turn it into 2D. So being
height in here as well as X, Y. Then.
That's it, X, Y, and height. Yeah, yeah. Some of these polygons are huge as well. Like, so the JSON document containing them might be over 2 megabytes. Some of them have like tens or hundreds of thousands of points.
Wow.
So
you're going to show me this in a minute.
Yeah, so we'll show you. So here's one I made earlier. So here's a little bit of horrible code that I've used to, in the Python world, evaluate the JSON that we've pulled into a Spark data frame here. So here's our magic where we pull in the 740 gig of data. That took a while. I think I can get that to be quicker, and I think there's some nuances for data.
2 hours, yeah.
Yeah, that took a while. But that code you just saw up there, to run it and then to pass the data and to produce a 3D and 2C set, it took 10 minutes over 740 gigabytes of data. So that's the power, and that was using a 10-node DS64 V3 cluster, so 640 CPUs that were spun up on demand.
Wow. And so it just takes a couple of minutes to spin up as well, Luke?
Yeah, it did. Yeah, just a couple of minutes. Final statistic, there were about 118 million records in that data set, and that's what we processed.
I'm impressed, Luke. So Databricks, super cool. We're going to take a 10-minute break. I need coffee now. We're back at 15:50 with some hidden figures. If you know what that means, come back and see us.
Can you tell me who you are and what are you doing here?
Yes, hi, my name's Hilary Sutcliffe. I run a not-for-profit called Society Inside, and that's sort of riff on Intel Inside, the idea being that people and planet will be at the heart of innovation instead of just money and scientific kudos.
Perfect. And in terms of technology that's influenced you or had an impact on your life in the past 5 years, what would you say that is?
Well, I work across technologies. So in fact, even the last sort of 5 years, I've worked on nanotech stuff. I'm on the synthetic biology governance group, looking at gene editing, gene drives. I looked at responsible robotics, AI, and I was recently on the quantum dialogue for the UK. So actually, the point for me is the lessons from all the technologies that we can learn, which is mainly about the nature of human nature, funnily enough, not the technologies.
Perfect. And finally, in terms of the next 12 months going forward, what piece of technology or area of technology are you really looking forward to coming out or seeing more of?
Well, it's interesting looking at AI because actually it is going to be AI, but AI needs to learn the lessons of everybody else's tech, because if AI is everything from pattern recognition to the singularity, how are we as society going to even know what it is and what to do with it and how to use it and how not to use it? So I think it's going to be AI, but I think AI needs to get its act together to really do what it can do for us and what we're worried about and what we're not worried about. And so I'm hoping you guys will help us out with that.
Pleasure to be here, thank you. Today I'm actually a panelist on the panel about non-fungible tokens. I'm the CEO founder of ZeroXCert. We're actually the first open protocol built to support the non-fungible tokens. We think this is the future of blockchain. And yeah, so really looking forward to it. We have some exciting speakers on the panel. Chris Berniske is there as well. So that's awesome.
Perfect. And in terms of technology, I think I might know the answer, but technology that's changed kind of your life in the past 5 years, what would you say that is?
Yeah, definitely blockchain. You knew that. I think that, you know, the value that blockchain provides in terms of just in the financial sector alone is immense. Now what we're doing with our technology specifically is we're trying to move that to the real life use cases as well. Tokenizing anything that is unique out there, you know, bringing that ownership in that token and allowing people to actually store digital products in their wallets as well. So that's kind of the thing that we're doing and where we see the future is headed. But yeah, we'll see. But blockchain definitely, I think, in all ways.
Perfect. And in the next sort of 12 months or going forward, what would you say a bit of technology that you're really looking forward to seeing might be?
Definitely, I think there's going to be a lot of improvements and a lot of going forward in the AI world. I think that's why it's also great to be here. But in terms of blockchain, which is my space, I think security tokens and non-fungible tokens are going to spearhead the next 12 months for sure.
Perfect. Thank you very much.
Thank you.
Hi, Kim. Please could you tell us a little bit about yourself and what you're doing here today?
Sure. My name is Kim Nilsson. I'm the CEO and founder of Pivigo, the Data Science Hub. And we are here, we are expoing. I am speaking tomorrow at a panel, and also we're running a workshop and trying to support companies getting started with data science projects.
Perfect. In terms of technology that's kind of influenced you in the past 5 years, what would you say the #1 area of technology would be?
Oh, that's a good question. I mean, obviously, we're a data science company, and so what we're really excited about is machine learning and how we can predict the future with it, and all the potential impact that will have on our lives, on how we work, how we stay healthy, how we live, how we have fun.
Perfect. And in terms of the next sort of 12 months and going forward, what area of technology are you really looking forward to seeing?
Well, I'm very excited about how AI might impact healthcare and how we can actually maybe predict illnesses beforehand, or actually speed up diagnosis, speed up how we can become healthier individuals, and that's a really important topic.
Hi, Danny. Please can you tell us a bit about what you're doing here today and what you're looking forward to seeing?
Sure. So my name is Danny Giller. I work with Autodesk. I'm the head of global diversity and inclusion. And for me, what I look for are ways where I can apply things orthogonally. So I prefer to go to non-diversity conferences to see how things I can learn might apply to and be relevant in the area of diversity and inclusion.
Awesome. Yeah. So in terms of technology, what's the biggest piece of technology that's had a largest impact on your life in the past sort of 5 years?
That's a really challenging question. I'd still say, on my life personally, I'd probably still say social media. You know, and I know that's not a dramatic technological change. I think there are other things that I'm not seeing because there are heavy technological tailwinds in terms of artificial intelligence, cloud, and things like that that are impacting a lot of these technologies. But in terms of from a direct consumer standpoint, I would still say social media has a much more significant impact on both things in the workplace as well as personally than I think I could have imagined even 5 years ago.
Perfect. And finally, in terms of the next 12 months, what are you most looking forward to seeing?
What I'm most looking forward to seeing in the next 12 months is organizations and people that are doing artificial intelligence and using it, really starting to think proactively about diversity and inclusion, how to make it a part of what they do in terms of the people that are involved, in terms of how they train AI systems, and in terms of how they think about their customer base. I think if they can do that, they can really have a chance to influence inclusion in a very proactive way.
We have so many people who are non-verbal, but still have so much to say.
I want the exact same information that my hearing friends have.
There are barriers to communication everywhere, but I think it's time we look at the barriers as opportunities to reach out to everyone.
Soundscape fills in a lot of the mental map as you move.
Approaching intersection.
You can just put it in your pocket and go.
With ALS, you become locked in. But we see technology as a way to give back what ALS has taken away.
There's no better feeling than to hear a child say something that they've wanted to say and the look on their face after they've been able to say it.
When it's reading, I see spaces between the words, and it's easy to focus on.
Ajay realized that here was something that could change his life.
Now that I have my phone, I can see exactly what was said, and that's been a huge help to me.
The system is learning as it goes, and the accuracy has improved tremendously.
Students can pick any language that they choose to receive the information. It's like we jumped into the future.
Because communication is very important for all of us, and we just want to be together and not feel left out.
Aider les personnes avec autisme à communiquer, il y a des images.
Je parle, je donne une information à Arthur et elle est traduite par l'application El Picto instantanément en pictogramme et après d'une façon orale.
Va t'habiller et te brosser les dents.
On va pouvoir remettre en place une communication qui est plus spontanée. Je crois que ça aide à recréer du lien.
Both my wife and I are totally blind, and we have a 3-year-old son that's in preschool. He can see, but his parents can't. So to be able to know what's going on at his school is everything. The Seeing AI app has the ability to allow me access to the visual world. Artificial intelligence is beginning to have an impact on the lives of people with disabilities, but it's only going to grow. There is still so much out there to be done.
Hello and welcome back to Tech Days Online. And now for something completely different. There's no formal definition of data science, not one I've been able to find. It's generally a job title. But I know that there are a lot of women working in this field, in the broad field of playing around with data. Some of them are playing with science, some of them are passionate about the data they're working with, and they're all doing very different things. So I've gathered an eclectic collection of very talented ladies to join me this afternoon to just talk about that world and their experience of it, so we can all learn a little bit more about how to do our jobs a bit better, a bit more inclusively, and maybe be a bit nicer to each other. Claudia, tell us a little bit about yourself.
I'm a scientist. I work for the European Centre for Medium Range Weather Forecast, which is an intergovernmental organization whose mission is to advance weather science to make better prediction for its member and cooperating states. And within the organization, I work in the environmental application team. The team is very wide, and we look at different applications. And personally, I work on wildfire forecasting.
Wow, that's pretty hardcore science. Jen, what do you do when you're not sitting in front of a camera?
So I work for myself, mainly because I'm a terrible employee, but I think I'm not very good at following instructions, but that's what I love about freestyling and data science, because you find things out. It's that wonderful, creative, exploratory process. So I do lots of work for different organisations. I do work for the NHS. I also do work for some of the London councils as well, analysing their data. And I just love it because it's so much fun, so much variety. I do work for private organisations as well, so enough to keep me out of mischief.
And Claudia, we work together, don't we, occasionally?
Yes, we do. So I'm a data solution architect at Microsoft. So I work with enterprise customers who are exploring the world of Microsoft Azure Cloud, and specifically around projects in data, big data, in advanced analytics, in machine learning. So helping them to get to know the cloud and helping them to bring those projects successfully on the platform.
And Kate, you've probably got the toughest job here.
I don't know. So I manage a team of data solution architects at Microsoft. My team covers financial services and insurance. So very similar to what Galio was saying, we help our customers in enabling them on their journey to cloud, specifically in the data space.
And you were telling me before we came on that you did some science before you...
I am a scientist who deals with data. So yeah, my background is in biotechnology, I would call it. So genomics and then neurobiology. But then I went to the dark side and got an MBA, so.
Great fun.
I turned.
You turned, and I think that's perhaps my first question. What you've all chose at some point to go into science. Claudia, what was the inspiration for you doing that? Yeah?
I was just a curious kid when I was really young. So when I grew up, it was natural for me to go into research, and I always liked to do research that is applied and has got a very important impact on the society. And this is the reason why now I work in this field.
I'm going to keep working this round. I'm not scoring you on the best answer, but we're doing that rendezvous architecture. We come up maybe with a set of good answers. Jen, what got you into this world of working with grumpy guys like me and fiddling around with computers and stuff?
It probably was a grumpy guy. Not that you're one, but so during the Second World War, my grandfather and my great uncle were both spies, believe it or not. So then when I was growing up, I was 8, they said, you have to learn to code, you have to learn to program. They had been to Bletchley Park, and my great uncle has been codes breaking Japanese codes. So they really inspired me, and they never, ever made out that I couldn't do it because I was a girl. There was never any of that. They had obviously worked with other women at Bletchley Park. They could see what they could do and said, you absolutely have to learn this skill. So they bought me a ZX81. I'm showing my age now. It's a very old computer. And we learned BASIC, and I just loved it ever since.
I think, I'm going to carry on from there. Because I actually had a conversation with my dad literally yesterday, because he bought a computer for me and my brother when I was 7. I was trying to establish the age I was in, because I couldn't quite remember. I remember the summer, but I couldn't remember how old I was. So that was my ZX Spectrum machine. First time I was doing something, learning BASIC, and that's kind of inspired me to try more things and actually go and do a computer science degree. And then during the course of work, when I was working as a software developer, I moved into the world of business intelligence, learning about data, of actual value the data can bring to the organizations. And this is how I progressed into the world of data science and actually bring it more and more into the decision process.
And Kate, you've alluded you got into it. So what got you into it? And can I ask you what got you out of it? Was it just egomania?
Well, so I come from a family of biologists, and I think what's interesting is how that evolved over time. So the possibility of what you can do today with very little was just like unheard of even 15 years ago when I was getting my degrees. So that sort of is what pushed me into science, and again, the excitement of uncovering, big questions. But then what got me out of it is sort of that limitation on how much you could, grow if you don't see yourself as an academic for life. And I think in the past there were less options, but what's really exciting about today is that more and more businesses are using data like research institutions used to in the past. Like, it's a lot more accessible, a lot more democratized just because of what we have today in terms of technology. So I think you see more and more businesses incorporating research methodologies and things like that into their practices.
Yes, and becoming more evidence-based, and they need those empirical skills to make stuff work. And I also get a sense here that you're all trying to do good with this stuff, and we hear so much about the dreaded AI, which no one's really sure what that is either. They're using some very evocative terms here, but have you ever seen a film where AI ends well? Here you seem to be quite all committed in different ways to trying to use this tech for good. Would that be fair? You can qualify some of that. So what's the, so Gali, you said you work with lots of customers. What's the most interesting sort of project you've come across in that you would say that embodies some of that tech for good stuff?
The most interesting. Whoa. I think in my world, a lot of companies, they explore what machine learning can bring to them. So it's still a novelty for them. We talk about, we as Microsoft talk about democratization of AI and machine learning and those skills. I think realistically, the businesses are still quite see it as a very new, novel ways of doing things beyond the reporting and business dashboards, which everybody is accustomed to. So I think it's, for me, the most exciting part is actually working together with the customers and sharing with them that these are skills they can actually use to explore what they have already within the organization, the data they could use, whether it's internal project or whether it's external projects for some predictive scenarios.
And Jen, you've been at the NHS, so I kind of, that goes without saying. Can I ask you, have you ever walked away from a project because you didn't think it was kind of ethical or a bit weird?
I've walked away from projects because I think they haven't really understood the business value of what they're doing. Yeah. And what I mean by that is if you don't have a really good business question then or something you're looking at, it's very hard to show success. So one of my customers said to me, Jennifer, I'm really disappointed in you. I said, why is that? And she said, you haven't given me a neural net. And I said, well, why do you need one? And he said, Jennifer, that is a beautiful question. I don't really know, but I've heard about this data science thing and this AI and it's all neural nets and you haven't given me one. And I said, but I need to understand what you need it for, because I'm really trying to make sure that you get a real tangible business benefit from it. I don't want to bill you for something and sit and work in a project which has no value. So it's coming back to your point earlier, Andrea, about doing something that's really useful. Yeah. So I'm doing some really interesting work around analysing data for prediction of homelessness. So what we do find is in councils, for example, in government bodies, the data sets are not joined together, always they're very siloed. And if your data is siloed, your analytics is siloed, and also your AI is siloed. You don't have that horizontal view of the business. So what I'm trying to do there, I'm leading a small team and we're having a great time. They involve, it sounds like the Breakfast Club actually, we are a historian, English lit graduate, and then someone else who deals with geography, and me. And they don't know any SQL skills at all, and they don't regard themselves as programmers, but they have learned SQL. We're using SQL Server. We're using R in Microsoft SQL Server as well, and they're picking these things up. And I think the reason for that is it's all about research. They see coding as a tool to help them to have a great impact, especially for homelessness. You find that when we think of homelessness, people think of the people on the street. But actually the largest group of people are women and children who've run away from domestic violence. And you don't see them because they end up in emergency housing. So what we're doing is using Microsoft technology, Microsoft R and Power BI to help us understand how these people get there, how we can stop it, and how we can embed our findings and the processes to help people when it happens. So it's all about the business value for, as you say, a data science for good project.
Yeah, obviously you don't need to be a genius to see that wildfires are a huge problem, and even areas of the UK get burnt out, as we sort of seem to have all our rainfall in one night and then go for 3 months without anything. It must be very difficult though in your world, because if you call a wildfire, you issue an alert.
Well, we don't issue directly, it's our member states, the forestry agency in our member states.
So you're building, so I just perhaps take one step backwards and so I understand how the model works. But so you develop the model.
Yeah, well, I personally work on a EU-funded project. It is called Anywhere, and the goal of this project is to build a multi-hazard early warning system that will help first responders to act more quickly and more efficiently in case a natural hazard occurs. So this is basically.
So you're putting those emergency teams on standby that there could be a problem, rather than actually maybe alerting the public. So
they know how to allocate resources, they know which areas are more prone to disaster.
Yeah, okay. And how do you just somebody just phone them up? Is there an app people log into?
We are going to have a platform with a series of services where we serve forecasts for the day and overlap this information with the local data, like urban areas and this sort of thing.
So you sort of plot it, and then you perhaps give some sort of confidence value of how likely, like red alert, orange,
we have indices of danger, and based on that, people on the ground will make decisions.
And is that live now?
Not yet. We are still working on it.
Okay. So do you sort of test it against incidents as they happen to see how your model performs?
As events occur, we test the model and we check whether we made the right decision or not.
And so how's that going?
It's going well so far.
Yeah,
yes, we have a big pilot study starting right now in June, and it's gonna go. It's gonna last until next year. So we have probably we are gonna have lots of events to test our platform. So.
Right. Okay. That sounds fascinating. I want to change gears slightly. Obviously, this isn't one that you can easily answer, Claudia, but I imagine that you three, and I'll perhaps start with Jen again, are having to deal with the fact that on the 25th of May there was this little piece of legislation that slipped in under the radar unannounced called the General Data Protection Regulation, if I've got that right. I mean, you know, even if you're doing your charity work, Jen, that must be incredibly difficult now. You've got to be very aware of what you're doing with the data and so on. So has it made a huge difference?
I would say that it has. I do think the organisations I was dealing with, that I'm dealing with now, were always very careful. I've been dealing with them for some time.
Yeah.
So it wasn't a massive change. It was more just about going through the processes that were applied. And for one of my private customers, they found that when we started to look at their data, some of the columns were questionable. We were not sure if we could do certain things with them. So all I've done there is say, when we're running the project, it's not a no, it's a not yet. We will take those out of the data warehouse or the data lake, we'll leave them, and we will add them in a later sprint. When they've been through the process of information governance. It's about prudence, really, and I love the regulation because I think it teaches companies to be adults with data, which you don't always see.
Yeah, we have a very similar experience with my customers. I think it's that awareness, and obviously the 25th of May just happened now, but obviously the whole processes were started to put in place months before that. But it's the awareness of how do you deal with the data, what's the data, where it should reside, who can access it. It's a general, I guess, sort of laws of how the privacy of the data.
So generally everybody has been ready.
It's been a process. I guess it depends on some of the departments of the companies, but it's people are aware.
Because obviously, if you're, and I guess the area you work in as well, Kate, the financial services area, is fraught with all sorts of problems there. So perhaps some of our most personal data is financial transactions. You know, what the hell is on that credit card statement that shouldn't be, or whatever it happens to be. But generally, you've seen that people are ready.
Yes, I think it's been a big topic, obviously, for all organizations, but I think especially financial institutions historically have been, you know, maybe painted as the bad guys, but most of the organizations, or all of the organizations that my team works with, have been very prepared and have taken it very seriously as well. So it's great to see, but I do agree it's all about, you know, how you handle the data and just to have that governance in place. So it does require some sort of organizational transformation, and the organization, like the 25th of May didn't, you know, just happen out of nowhere. There was a lot of preparation leading up to it. So a lot of organizations have had to transform in order to prepare.
And you as a manager are going to have to make some changes in your day job, as well as obviously your staff are subject to those regulations, and the processing data you work with different as well. So what would you characterize that as, perhaps, then?
I mean, I think at Microsoft they did a pretty good job at preparing us and sort of training us to be able to understand what this all means. So yeah, I think we were pretty prepared. They did a good job, so it didn't impact anything immensely just because we had been doing it for a while. So,
and I think we've rolled it globally as well, haven't we? So we just haven't sort of stopped at the edge of Europe. We've just said, we'll just turn everything on. So all our data centres are prepared for all of this work. Okay, that's because I still occasionally come across people who are going, who now what? But then if you're down your local model, you know, My Village are running the Fate this weekend, and even they are going through that process. And I think sometimes we forget that it touches our personal space. Okay, it's very, very interesting. Obviously, again, perhaps with UK, you manage a whole ton of people. And they all speak, I can tell you, they all speak very highly of you. But part of that, of course, is that you're managing a team of architects. You're not Gallia's manager. I'm trying to get my names confused here. But a lot of your people are out on the road all the time.
Yes.
How's that working for you?
How is that? So I think with my team specifically, we're more London-based, obviously, because we're finance and insurance, but they do travel. in general, as a company, I think we do try to allow people to have that work-life balance. So I do, and I think in general, we do allow people to sort of work around their own schedules, and there is that flexibility. And I think it's all about working with the customers and working with your teammates as well to make sure that you don't sort of burn out with all the travels, and you don't like overcommit, and then you're not really effective if you're, you know,
herring around.
Yeah, burning the candle at both ends. So I'm very supportive of that.
And Jen, you're your own boss, and that must be difficult sometimes. Private engagements you talked about, what have you, that you may have other stuff to do.
Yeah, for me, I ended up working for myself because I found it made it easier as a single mum to operate. I used to be a consultant for some of the very large firms, and I found it quite difficult because they were organising my travel and my time for me. But I wanted the time with my son, but also wanted to work in a career that I loved, and I'd worked so hard. I learned to program when I was 8. I didn't want to give all of that up. So, but what I love about data science and IT actually in general is it means I can work wherever, whenever. We're all about mobility. You can really see this story happening at Microsoft as well. So I can control my hours as long as I deliver, and I can work later in the evening once I've done the bath, bed, time story type of routine. So actually it works really well for me. I think sometimes I get the nice, really, really nice customers because they look past the fact I'm not, say, a programmer or something like that. They know that I have other commitments as well, and I think sometimes they come to me with that understanding that I'm not going to travel all over the world and do the things that they maybe need. If they do that, there's plenty of other people that can help them. So I do have to thank my customers. I think they're all amazing, actually.
Yeah, cool stuff. Yeah, so because there are lots of programs in place now, and I know you run Our Ladies, don't you? So there's a lot of work going on there to encourage people into the world of data. I'm going to use the word data science, but just please don't shoot me. I can't think of another word. Into the world of analytics, into the world of software development, whatever you want to choose with the various languages. What do you think about the sort of returning to work kind of thing? Do you think there's more that could be done there? And if so, what? Anyone want to take that and put their paw in?
There's always more we can do about it.
But what would it be? What would you change?
Well, I would first of all educate more people, because there are a lot of unconscious biases towards women that, and I think that's the first thing we need to fight against.
Yeah. So, So, how does that manifest itself? Help me out here. I'm a guy, all right? So just treat me like the idiot that I am. And what sort of things am I doing wrong that you've come across? And we don't need to name names.
So if it helps, I can talk about my experience returning to work as a single mum.
Yeah.
And I went back to work 6 months after having my son, who's now 12. And what I found was people were more sympathetic than I thought they'd be. I suddenly realised I was in a world where other people were parents, it wasn't just me. And they sort of understood that in the human level I had to go to hospital appointments with my son and do all sorts of things. But I think I was always worried that maybe it was perceived that I wasn't keeping up. So maybe I went and overstated the case. You know, I went and kept getting Microsoft qualifications. I went back to study at night. And I think I still work incredibly hard, and I'm still trying to teach my son Python, which has been quite challenging to get my future. Well, I think he just chose that one because it sounded cool, you know. But don't worry, we'll get him into it. I will do my best. So I think for me, it's about having some flexibility. But I think if an organisation is willing to invest the time, they get so much more returns. Because it means that by bringing a diverse opinion, I feel I become the voice of the customer. I think sometimes it can make you more empathetic. People that have maybe come from a minority background they've sometimes been through a lot, so there's an incredible amount of empathy, wisdom and compassion. And those values are always useful and valuable in any workplace. And it's about harnessing that and trying to really build teams that are successful in helping everyone.
I think for
me, from my personal experience, it was also that flexibility that the employer can give me. Because, and it's not as a woman, I think it's as parents, you know, it's the same, applies the same to men. When you have a new family, you know, you need to make sure you can balance it out and let people be successful when they can be, not when they're, you know, when it's 9 to 5 job. And I think another point is in the world of technology that things are moving fast, the new technologies coming up, the new tools coming up. It's really hard to keep up when you actually just, you know, full working mode. If you step away for a year or two or a few more, it's having that opportunity to have training, onboarding, working with your colleagues to do shadowing sessions, you know, to actually get that gentle kind of
back to work, rather than just a big bang kind of thing. You could maybe come back
thrown into,
a little bit more part-time or something like that, and have some calls
having the part, exactly.
Have you managed that situation?
So I think
your reports, I mean, you know.
I mean, to Galia's point, it's all about equality, right? So treating men and women equally, equal responsibilities as a society. And what I see across our team is that people are just very excited about what they do. So it's almost a vocation, and we do allow time for learning and training, and that's a big part of it. So I think that sort of encourages people to keep going because they just really do enjoy what they're doing. But then they're also enabled to control their own agendas, to be able to take time off if they need, you know, to pick up their kids, whether you're a man or a woman. I think it's, you know, that's sort of a shared responsibility. And as society, if we only look at it as, you know, a woman problem, we're only addressing half of the problem because I think it doesn't end with that.
Sure. Okay, good stuff. We have mentioned R and Python.
Cannot avoid that.
So I wondered, Terry this morning made quite a good point. He's came up with this rendezvous architecture where he was able to leverage the power of both without precluding one against the other. Do you think that's a way to go? On the other hand, so should you just specialise in one language? And that's the first question, I guess. Anybody want to take that?
I can tell you something I've done at one customer.
Yeah, sure.
Because I'm not just focusing on the language choice, but I'm looking at the overall architecture. And that can include things like taking them to the cloud. Can use, and that's usually a big jump in itself conceptually. So what I tended to do is, what I still tend to do is if they've never used cloud, is I try to encourage them to start with a virtual machine. And then using SQL Server on that, which has got R in it. So for one customer, we've gone with 2016. They haven't upgraded to 2017 because they haven't got the support signed off in training. So it's all people issues, it's not technology. So I think to try and streamline things, I went towards SQL Server and R on a virtual machine because I want the overall architecture to be successful. I'm not against Python, it's just about delivering success.
Right. And because I tend to, my simple brain says R has come from academia, and Python has kind of basically nicked all of the algorithms and stuff from R and MATLAB and whatever. You know, you've got Matplotlib and ggplot, and kind of fused that onto an already mature development language. And that makes it sometimes easier to operationalize models. But there are occasions when if you had a particular problem to crack. Let me say that we wanted to detect unconscious bias against women in job adverts. Let's posit that as something we might want to code against, right? That's our hack this weekend. What language would you use for that?
So I think sometimes, and everyone feel free to disagree with me, I think actually when we focus on R and Python, we sometimes forget about the other languages. So I want to use SQL as well. And actually what I found is when I'm training people to do data science, and sometimes they've never used SQL, I start off in Excel and I say, look, let's just prototype. What do you want it to look like? And let's focus on the results. And then I can start to teach them, because it's easier to springboard, I think, from Excel to R or Excel to SQL than it is to Python, because Python's so much more procedural. And that's just my experience. I don't know what everyone else thinks.
It's where the people come from a software development background. Python is a natural, you just read it, you understand it, you don't need to learn it. And I think from my personal experience, it was the same. When I was learning R, it was that learning curve where you have to just come over, because I don't come from an academia statistics background. Whereas with Python is much more natural, just because of the skill set. And I can see it with my customers as well. There's often that preference of the tools, just because this is where people want to be successful and solve the business problem quicker, rather than start going to the details of the language. Because both of them offer various libraries to solve the problem.
And Claudia, you're developing your models presumably in R, and you're doing. I think you've got 3 Crays in the basement. 3? Cray computers in the basement. Yes. Just like you have them lying around there. Do you use those, or is that?
I personally don't use them, but obviously in our team there are people that use them. But in general, to connect to what you were saying before, I would say that you use the language you need for a particular job. For example, I started working with Fortran a long time ago, and then I moved to Visual Basic, and then I moved to MATLAB, and then again, I would say I evolved my programming skills, and now I landed and used R for my daily job. So I think people just need to use the language that is most appropriate for a particular job. For my job, we do a lot of geospatial statistics, so R is really the best fit. But I wouldn't know for other.
Sure.
It might be completely different.
And do you see a lot of, obviously, I think, I'm not sure you do, Kate, but I know these 3 are constantly at community events, either presenting, attending, and what have you. Do you see the next generation coming in? Are they evenly balanced, or is there a bias towards one of those languages or another? Do you have a lot of new graduates coming to Our Ladies?
Yes, a lot.
Good.
Majority, yes, they are graduates. All our,
fantastic.
All our attendees.
And you've also mentioned MATLAB there. Now, obviously, MATLAB had a language in it. Was it S? I'm just trying to remember the history. Give me a quick history of R, because it came from S, didn't it? And S was a language in SPSS. SPSS, right? So it wasn't MATLAB yet. So is it easy to transition from MATLAB to R?
It was very easy, but I guess it's easy to transition from MATLAB to R and to Python, because there are similarities to both.
Well, you have Matplotlib, obviously, you're plotting in Python, I know that. But so ggplot's kind of a different. I kind of get that, because I like it. It's like I used to use those overhead projectors with acetate on them.
So you can actually stack
layers. You just put another layer on. And say, and then you push the button, like turning the bulb on, I guess is. So I found the plotting. I think that sometimes I see these languages just being used to tell the story with data, which I think is perhaps an important part of the problem before we actually start modelling, obviously doing the modelling. So you're seeing lots of new people coming into it. Are you seeing a lot of new libraries? And we had the Hadleyverse and what have you back in the day. Tidyverse, that's the word I want to use, isn't it? Hadley Wickham's Tidyverse. Coming into the thing. Is there more new stuff coming out? For example,
there are more now, about 10,000 packages on CAN only, and if you count all the packages that are released just in beta version on GitHub, for example, there are even more.
Sorry, just the GitHub joke. Sorry. So, and are there libraries too for deep learning? Because obviously everyone knows TensorFlow, the Google framework, and we have Microsoft's CNTK, which is also super cool, and then you have the Keras thing that manages layers on top. Are there equivalent tools in there for R? Yeah. So you're not precluded on just doing deep learning in Python, you can do deep learning in R. So I'm just asking for a shameless R plug here, right? So,
because the rise of Python, I think, in machine learning happened because of those frameworks, right? Because at some point it was R versus Python. It was about equal, you know, wherever you're coming from. But with deep learning framework, TensorFlow, CNTK, others, Python has suddenly got a massive rise.
Yeah, and the other area I work quite a lot in, I just alluded in my previous question, was the area of analysing text. You know, so a lot of times now we have to pick up a report. It could be a CV. You know, the classic problem of matching a candidate CV to a job advert.
Yeah.
You know, if we could crack that problem, you know, we'd have all those recruitment agents out of work. But we probably should care about that. But you know, but it would be great if you could get a match, wouldn't it, straight away? Or if you knew what kind of house you were actually looking for, and you could reason against the description of the property. So can you do a lot of that in R?
Yes. Yeah. It's a tidy text package.
Tidy text? Yes. So everything's tidy now inside Microsoft. Okay, excellent. Okay.
Well, but going back to the job advertisement, I think the real problem is not much the language. It's more the fact that job advertisements are way too ambitious. You know, this doesn't encourage women to apply, because it's a very well-known thing that women only apply to a job if they have at least 80% of what is required.
Right.
While men can apply even if they have less than 50%. so
okay.
You know, this discourages women.
So
the fact that job advertisements are way too ambitious.
Yes, so what we should be perhaps clear about is what we absolutely must have for this job.
Yes.
And then we can have, these are nice to have, but don't worry if you haven't got all of them. So actually just state that explicitly would be super cool. And is that what because you obviously presumably get involved in the recruitment process, Kate?
Somewhat, yeah. But I think we do a pretty good job at that, at Microsoft at least, in the technical space.
Yeah, in our team, when we did recruitment, we kind of feedback on some of the job descriptions saying like, well, it sounds a little bit too focused on specific areas, so let's make it a bit more
So actually,
natural.
this might be a good point to pivot on that and go through the process of applying. So first of all, you're put off by the advert because you think, I can't do all that stuff, I'm not going to bother applying. Then you've got to the 80% mark now, and you're saying, okay, right, I've rocked into the interview. Where does it go wrong there as we dig into this unconscious bias? So what puts you off? You know, like, because obviously you are all supremely employable, right? We can accept that for a moment. And if you had the passion for it, you could probably go and do anything in data science. So you're now in this hypothetical job interview, and you're going to walk away because of something that is making you feel uncomfortable. What would that be?
Yeah, if it's an interviewer, tell me, because I turned up in trousers, although I'm in a skirt today, and the interviewer said, it's all right if you wear a skirt when you come to work here, and that was it. I was done. Because I thought, you've just completely singled me out against everyone else, and my clothing shouldn't matter.
Was it a Scottish company?
No, it wasn't.
Because you could turn up in a...
If it was a kilt. That's fine. But I think the point I'm trying to make is sometimes people can be either very overtly insensitive, because at that point the lady in the interview, she turned around, she elbowed him and glared at him for the rest of the interview, and obviously I didn't go back. So that immediately told me it wasn't just insensitivity, there was problems in that workplace, and it was not right for me.
Sure.
So I think if a company, joking aside, if a company makes such too big a thing of the fact that you're female or you tick a box somewhere, you suddenly think, or certainly I think actually, they just want me because I tick a KPI, not because of something, not because of my skill set and what I can contribute. And I don't want to be hired because I tick a KPI. It's not fair to me, and it's not fair to the team I work with, or would be working with. They would always feel to me a bit of a smell. So I think there has to be a very, very fine balance between saying, yes, we offer family friendly, but also here's what you contribute. Here's teamwork, here's how we collaborate. And I think these, to come back to your earlier point about job descriptions, having those keywords in a job description makes such a big difference.
Right.
I've seen a big difference in certain tools as well. So one of my customers, I've managed to encourage them to use Microsoft Teams, which I love. I think it's great technology. And just the collaboration aspect of it means we're not drowning in email, but it means I can be messaging people and it's open and collaborative. There's no secrecy between myself and another colleague.
Yeah, yeah.
So that helps.
Yeah, well, I mean, obviously, the people watching, we often use a tool when we're working with customers called Slack as well, and that's going to offer the same kind of. I don't want to press the Microsoft button too much. It's great, but thank you for that shameless plug there, Joe. This isn't scripted. So do you then then we've gone through the interview process. There's a few weird things going on there, and you finally arrive at work, and you're having a review. What matters to you then? You know, you're doing the day job. What's getting it right look like? Claudia.
For me, it's very important when people listen to you, first of all, and take on your suggestions. And sometimes, you know, it's really hard to make your voice heard.
Yeah.
I think for me, it's having that diversity in place, having those role models, you know, in the leadership position as well, because we, in our technology, we work, it's a male-dominated field, there's no way out of it, but I want to see where other women got to, what I could be in a few years' time, so it kind of gives me that, you know, indication.
So you'll be the next Kate, and Kate, you'll be the next Cindy.
I don't know. So I think all of this goes back to the culture of a company, and I think a lot of companies are going through that transformation and want to be inclusive and diverse because the benefits to the business, you know, strictly from a business perspective, are huge. I don't know of many companies that actually do it right. I think at Microsoft we're extremely lucky, and I'm relatively new to Microsoft, so I can tell you what happens on the outside. Not great, but I think it's down to the culture and that sort of inclusivity, and really when you go into a place and when you talk to the people, and I would encourage anyone in an interview process to talk to other people on the team and see how, you know, what they're saying and get a feel for it. I think that is going to make it or break it, whether you're going to love your job or, you know, hate your company and want to leave within a year. So
having a peer on the interview panel perhaps is a good thing to have, and preferably if it is, if you have got your role model, if that person was part of the interview process, that would perhaps help. Would it? Yeah?
Yeah.
So I'm just trying to come up with some sort of things for people to try out after the show. Would that be something?
I mean, it's a two-way interview, right?
Yeah.
So whenever I interview someone, they're also interviewing me equally, and it has to work both ways. And I think that's something that people need to remember. If you're not comfortable or if something doesn't seem right, I think if you're talented, you probably have a lot of other options. So, you know, not to limit yourself.
Yeah, I mean, obviously, as I said, you're all supremely employable. Excellent communication skills, and you obviously do the data or the science thing or the data science thing or whatever we're calling it this week. But not everybody's in that position. So, but we're chasing down a talent pool here. And you know, when I called this session "Hidden Figures," and I'm minded that NASA originally got into hiring black women because they ran out of white women. They ran out of white women and they ran out of guys. They kind of went through that because they had to, because the necessities of well, it was NACA before it was NASA in World War II. But now we're in a situation where we're saying, actually, what's the business value? And you've kind of posited it about having a wider view of the business by having women on your team. Would that be right?
Yeah,
I think so, and I think it maybe sounds a bit abstract, but actually that's something everyone in any organisation can help with every day. So something that I find really hard is being interrupted. I get interrupted a lot and quite softly spoken, and I think when people interrupt you and don't listen to your ideas, they're actually depriving themselves of some data. And if they're doing that, that means that their ultimate model, if you want to look at it like that, is not going to be as good because they're skewing the data towards one thing and not something else. So in one organisation, I partners with a project manager, program manager, and I said, I'm having a real problem being heard, and I'm also having a problem getting them to understand that I am technical. I don't really want to have someone else explain to me what Power BI is, for example, then I'm there to implement it. And I think sometimes people's perception can be quite hard. But the only way to overcome that is to maybe partner with someone and say, look, if someone keeps interrupting me, can you just say something like, oh, sorry, could you repeat that? And I think it's about finding your own voice to say things like, I'm sorry, but would you mind, I didn't finish my sentence, could I please finish illustrating? And it's not that I'm talking forever, although I'm doing it right now, but it's just there's sometimes that person that will just dismiss you before you've opened your mouth, and when you do open your mouth, they will just try and cut you down. And it's not very good. So that's something everyone can do, is just listen and let people have their voice.
Okay, thanks, Jen. This is also a bit contentious, but fortunately or unfortunately, when we look at it, we've got a few different nationalities. How's that working in the workplace in the UK for you? Is there sometimes a perception about the accent that you have? No, honestly, seriously. I mean, I worked with a girl from Venezuela years ago, and we had problems going to see customers sometimes because they felt that they couldn't understand her. And then there was an unconscious bias that because English isn't your first language, that you couldn't understand what I'm saying because I can't understand what you're saying. That sort of thing. Any experience? No?
I'm lucky, I can say, because I work in intergovernmental organizations,
sure.
so we are all, the majority of the employees are from different, not British, so...
Excellent, yeah.
So
yeah, cool.
It's an happy island.
Yeah. I think sometimes it's about being diverse. Diversity sometimes gets translated into gender, and I don't think that's right. Diversity is what it says in the tin. So as someone working for me who was Muslim, and I let him have time off to pray during the day, and I gave him a special place for his prayer mat, and I made sure he had a prayer space in the workplace. I also had someone work on my team who was Jewish, who said I need to be home Friday lunchtime so I can have Sabbath at home. So all we did was rearrange our working week to make sure that he had that opportunity. He was a great team player, but it seems to me with diversity with a little thought can really work for organisations, and it shouldn't be translated into gender all the time. I think it's about allowing people individual freedoms and respecting that. And I think those values of compassion, wisdom and respect are something that we shouldn't have to formulate in some ways, but somehow human nature being what it is, we'll have to do that.
Yeah. It's starting to be obvious sometimes.
Yeah. For me, being Russian, unfortunately, this year, with all the news, there was a lot of jokes. It's a bit of an icebreaker with the customers as well, Russian hackers and all that. Yeah. But it is what it is. It's just
that's right, but then that's,
it's a diversity of opinion, experiences as well.
And I stupidly assumed you were American. So.
I sound very American. Like I've become more and more aware of how I'm not actually American. But that's okay.
Yeah.
That's okay.
Yeah. Cool. I mean, obviously, we're a pretty diverse group.
We are, and I think it's great. I think in terms of the people that we work with, even if you are a local, because you work in such a diverse environment, it exposes you to different ideas. But I've learned a lot about English culture since moving here, so that's been very exciting for me.
Yeah, some people say that's an oxymoron, a contradiction.
Well,
I think you've also alluded to the fact you're all talked about time off for studying and so on and so forth. So I want to actually, just as we sort of spend the last 10 minutes, what are you learning at the moment and how are you learning that? So Galia, perhaps you could open the batting on that question.
Right. Well, so what I'm using, I've tried different online courses. Some of them, the format works for me, some of them doesn't. So the one I found so far the best is one of them called DataQuest.io, which is a set of exercises and missions where you actually code with, to solve a problem, a business value or smaller problem, to clean data, predict data. And that's very interesting because you actually get to use Python or R, depending on the course. So that kind of works for me. Videos, a little bit tricky because with attention span, it's a bit hard to keep track for an hour about things.
Well,
so
people are watching this for another 8 minutes.
I hope they still watch it. So that's my kind of hands-on exercises. That works for me.
Okay. Jen, what do you? I mean, you've got qualifications as long as your arm, haven't you? I think.
Well, I'm doing my MBA at the minute, so like Kate, I'm actually turning to the next thing. So I'm really enjoying it. I'm doing that online. And it just gives me freedom and flexibility to do it late at night. But I'm learning so much, and I'm reading so much, and I'm really enjoying it. And I'm finding out it's adding a value to my customers as well. I feel it's given me a bigger lens to look at problems through, so not just from the data, the technical angle, but to really talk about from the business perspective. So I'm finding that really useful, really helpful.
I'm actually learning Python.
Do you love it?
I can't say anything yet because I'm really
a
beginner.
I'm a total Pythonista, so.
I still love R, I must admit. I really struggle, but because at work, majority of my colleagues use Python, you know, to exchange code is just easier for me to learn Python.
And that is a problem sometimes. You've got to have like a repository of code so you can work off each other's ideas. And we heard earlier today the chaos about trying to recode something. You know, no one would rewrite a model in Java, would they? So we'd at least use a mature data science language. I think we'd agree on that. So how are you learning Python?
The majority of the time I watch videos on YouTube of exercises. I like those tutorials, very focused tutorials that explain you everything you need to do from A to B to solve a specific problem. And yeah, learn by examples.
And different question for you, Kate, because you've got the
Sure.
hard questions, because you've already got the MBA. Obviously, you're hiring people in and they've got gaps in their repertoire. What do you point them at to help them learn? So you mentioned Python. Where would you point your team to?
So because we have such a diverse team, it really is down to the individual. And what's really nice about our team as well is that each person has a different skill set. So there's a lot of cross-learning. We have a lot of resources, but also if they're interested in a particular topic and they want to sort of pursue that, there's nothing really stopping them. Right. So I think everything is there, and it is down to the individual as to how they want to go about it. And I think different people learn things in different ways. I can't sit in front of a video for an hour either. I get very antsy. So.
Can't believe you're subjecting the audience to this. Okay. Well, that's been pretty useful. Have you got anything you would sort of say to the guy that's sitting next to you at the desk, where I would be that guy that I could be, I could help you a little bit more with the stuff that you do. For example, what would I do? What should I be doing differently?
And I think for me, it's always been about decency. We shouldn't have to formulate it. And I think it's about being proactive. So actually, one reason I get into community, you probably don't remember this, Andrew, was it was a SQL conference in Birmingham. And I walked in and it was all guys. And I thought, I'm really nervous. I don't like crowds. I'm going to disappear. And I was just about to turn to go when someone came up and said, oh, one of my friends is talking. You have to stay for this session. Come and learn, come and sit with me. So that person was you. So thank you very, very much. Wow. So you're to blame for me being here. So I just want to say thank you, because I think you've been proactive, really set an example for me about community. And I think if we had more Andrew, then the community, I think...
I wasn't fishing for compliments.
No, that's all right. I just want to say thank you when I got the chance.
So, but you leave me with an interesting point. Obviously, Our Ladies exists. Did you set that up?
I didn't. Another person set it up. The original founder is Gabriela De Quiros, and she founded it in San Francisco. So when we met Chin, which is the lady that founded the London chapter, and we decided to help her, and altogether 6 of us wrote the first proposal to get funding, or to get the organization to expand globally.
Yeah, so I vaguely remember this. You had a bit of problems with the contracts and stuff, I think, to start with, and then eventually got there. But why did you get involved in Our Ladies? I mean, you're full on at work.
Well, because I come from academia. My background, I've worked in academia for a long time, and I love teaching. And then when I moved out of academia, I missed teaching. So I joined a meetup just to have the chance to teach again, R in this case. And then things evolved, and now we have a very successful organization that has got chapters in many countries. We have more than 100 chapters now.
So. Well done.
Thanks.
Obviously, you've got a pretty busy work life. I mean, your manager keeps you on, well, not this, okay, keeps you working hard. But you go to meetups. I mean, that's not part of the day job, is it?
No,
Just to be
it's
absolutely
not
clear.
part of my job at all.
No,
So
no,
this
you've
is
been doing this anyway, right?
Yes, I'm just passionate about community, about meetups, conferences. Again, I think it's that aspect of teaching as well as learning myself and being able to express it and help other people to digest that information and actually help them. And I think another part for me is I have a small daughter, so I want to show her that this is a normal thing to do. She was here, and she was actually here at this venue before when there was an event over the weekend for inspiring women in data science.
Cool.
And she saw me moderating the panel, and she was very impressed, and she was asking, and she was running her own panel later on in the nursery, so it's incredible.
Yeah. And Jen, we have this Microsoft Value Professional thing, and you're one of those, but you've got this other weird job title called Regional Director.
Yes,
what is that for the?
So the role is a role rather than an award, and I'm incredibly grateful and privileged and honoured to have received it. It's much more business focused, so it really means you feed back that strategic customer voice back to Microsoft, and I'm still working my way around it and trying to work out really what it means and how I can really contribute and do a really great job, so that I don't let people down, but so that I have a really big impact in a good way. So far it's been really, I'm just really honoured, I think. When I see some of the names, I just think, gosh, I can't believe I'm in the same group as these people. And then I realise, oh, that's imposter syndrome. And then I tell myself, actually, I'm not really clever enough to have imposter syndrome, so I've got whatever, I aspire to have imposter syndrome. So I think I'll just enjoy the privilege while it's there.
Okay. Well, ladies, thank you very much indeed. I hope that people won't be turning off YouTube after an hour of watching this. I've learnt a lot, and it's been a pleasure talking to you. And to close out the day now, we're going to have a chat with a guy called Norm Judah, who is the Chief Technology Officer of our Services Division. He's over from the United States. He can't be with us in the studio. Apparently he has an appointment somewhere in Downing Street. But we managed to get him on camera. So hopefully he's going to answer some questions about the future of AI from a Microsoft global perspective. So once again, thank you all for listening, and we're going to cut to a video break now, and we'll be back with Norm.
So hello, my name is Richard Potter. I am the CTO for Microsoft Services in the UK, and I'm reporting for Tech Days Online at the AI Summit in the ExCeL in London. And with me today, I've got Norm Judah, who is the worldwide CTO for services for Microsoft. And Norm has just been rocking the main stage.
Rocking the main stage with AI.
Yeah, how did it go? How was it?
It was very interesting looking at some of the earlier presentations, because I was trying to judge the audience ahead of time. And some of the earlier presentations were technical, getting into the algorithms of Bayesian decision theory.
Yeah.
And it's not what I was talking about. I was actually talking about the pragmatics, having built some of these things. What does it take?
Okay.
What does it mean for people? You can build systems in a couple of weeks.
Yeah.
And trying to make it very pragmatic to that audience. So we were at different altitudes. What for me was interesting was that there were a lot of people sort of watching.
Yeah.
I watched the body language and I present. You could actually see people engaged, because what I was talking about was skill set, competencies, culture, bias in models, ethics. Those are all big topics, because you could have people run away today and build an AI application.
And that's kind of the point, isn't it?
It is.
Because we can almost take for granted the horsepower that sits in the AI. It's about how the organizations harness that, really, isn't it?
It is. So when we built this maturity model, it has 4 sort of central categories. One of which is about technology. Do you have the right data scientists? Do you understand the algorithms? But the other 3 are about organization, strategy, and culture.
Yeah.
And if you're going to be successful, you've actually got to grow competencies in all 4 categories.
Yeah. So when organizations are successful, what are the real success stories that you're starting to see with AI? What does it look like when it's done well?
So there's many of the banks, for example, have been building learning systems for years, fraud detection, for example. And so you see these complex mission-critical systems running today. But the thing that I think we're seeing today that's even sort of much more interesting and more agile is the ability to actually build solutions quickly. We showed an example of a bridge maintenance, 4 weeks. Microsoft Treasury, looking at forecasts of accounts receivable, 6 weeks. Yeah. So the ability to develop solutions quickly and actually test them and value them. And so one of the major differences with AI is there's no such thing as a waterfall AI project. They have to be done in an agile, iterative way.
Yeah. That experimentation is
key,
isn't it?
Learn, try, reprogram the model, test it, get some more data. That iterative loop is what makes systems really successful, and you can get value quickly.
Which is a culture change. Which goes back to that. The horsepower is there, but that culture change to enable it, to release it.
It's actually culture across the organization, so it's culture in the technology group developing it, because this is different. It's culture on the business unit being integral to it, because the people you're trying to make better are actually the people in the business, and how do you know if they're better if they're not engaged? And so it's a big commitment from the business, not only IT, but from the business to be engaged in this iteration and to actually own the thing that's there, because the model that you build is the differentiated model that reflects our business compared to somebody else.
Yeah, absolutely.
IT can't do that.
No. So those are the great successes. I've just been in the AI and finance stream, and we've been talking there about the blockers, the things that get in the way of releasing AI. So when it doesn't succeed, what typically are the things that prevent people from harnessing the power of AI and turning it into great results?
There are a couple of key indicators about when things don't succeed. The first one is, do you have the right people? And so the first thing that I'll try and look at is, show me who's on the team. What does the team look like? How big is the team? How small is the team? That's a first indicator. But you quickly realize is that great AI needs, in fact, insists on great data. And so you do see people experimenting with models, but with data that's not truly reflective of the business problem. It's inherently systemically discriminating. I used an example earlier this morning where I talked about, let's say we're going to do brake pads, and we train it on a Jaguar F-Type. I love that car. It's not going to work for an E-Type. They're completely different cars, different generations. And so there you've actually got bias in the model. People tend to think of bias as about people and opinion, but it can be you're constraining the data set to reflect an audience, the F-Type, and it's not applicable to the E-Type, but certainly not to a Toyota Corolla either.
And is there something sort of above that in terms of a strategy, a purpose? So I mean, what are you looking to get out of this that will then frame what you get in that AI data set?
So one of the key questions I ask relative to that is, when you're undertaking the first step of an iteration, what's the hypothesis you're trying to prove or disprove? Do you actually have a hypothesis? If you don't know where you think you're going to go, you're not going to get there. And so you have to have what's the core hypothesis of each loop. And once you've solved that, you either prove or disprove, change the hypothesis or grow it. And so it's this combination of data, people, the understanding of the process, which is really the hypothesis. Can I solve this problem quicker? Can I actually decide who should or shouldn't get a mortgage? Is that biased? Is that not biased? So you have to have that view.
That compass, that direction of travel.
And it could be wrong. The whole point of having a hypothesis is to prove it or not prove it. And if you don't prove it, then change the hypothesis.
So let's talk ethics, because I mean you can't talk AI at the moment without talking about ethics.
Actually, I love that's happened in the Catalyst, because there have been certain events that have happened in the recent past where if we'd had this ethics conversation 6 months ago, it would have had a completely different light and lens on it than it does today, because suddenly people have woken up.
Sure. So let's unpack it a little bit. Let's think. So how does one begin to have the opportunity to make a reasoned ethical consideration about what we're doing with AI? How does one begin that?
So the way we've started it is actually with this book, which is looking at, in the book, a set of principles. So we've decided we're going to take a principled approach. We've articulated these 6 core principles. And by the way, privacy is actually just one of those principles. So GDPR and all the things related to that, you can actually think about the ethical way that I treat your data is sort of around privacy. So our approach is to actually establish these core principles. Now I can go and evaluate the activities that I'm under relative to those principles. Now what's interesting in principles is we're at the stage now where we're actually running water through those principles, testing it, and coming up with precedents. Because principles that you haven't tested are actually just a blank slate. Can you actually take solutions and decide this will work and this won't work? And so that notion of understanding, and so part of what I beg and plead, as I did this morning with companies, is that before anything happens, write your own ethical manifesto. What do you believe as a company about that? But a lot of it starts with people understanding their own information. Who do you give your information to? Are you giving it? Are you selling it? Are you getting value from it? There's this conversation about my value. And there's a generational question because my children think of the value of their data different to the way you and I might.
Exactly.
So
what's interesting is hearing you talk about it that way are the parallels between the ethics and the AI approach itself, that iterative experimental process that's guided by a North Star set of principles. And and that's a new way of framing philosophy and thinking through logic, isn't it?
But suddenly, what I love about this is suddenly you've got this principles being jammed on real work with businesses that's forcing them to do that. And I think some of the things that have happened publicly have suddenly caused companies, consumer companies, business companies across all industries to suddenly wake up and think about what might happen if something goes wrong. And what we know in the data is that all models are inherently biased because they're built by people, and people are inherently biased. And so how do you deal with that? And one of the ways we solved this years ago with autopilots and planes and stuff like that was by building multiple systems to vote. I'm going to put 3 teams in different rooms. They're all going to try and solve the same problem, but they have to solve them in different ways. And then I'm going to vote. And what would happen if we looked at that from an ethical behavior? We said, go off and develop these, and these 3 systems come back with different recommendations. Who's right? And so I think what's inherently happening in this is the role of people, the role of wisdom, of judgment, is actually accelerated. It's highlighted.
So now we're getting onto this connection between people and AI, which leads to this obvious other question that people always want to ask, which is that, are the machines going to replace the humans? And what's your perspective on that?
Not in the short term, and I don't know what the measure of that is, frankly. But today, most of the AI systems that we're looking at are what I call open loop. It's a system making a recommendation to a human. I'm looking at a picture. This looks like a dog in a road. This looks like a car in the road. This looks like a scooter. Those are all recommendations. It looks like with a probability. What we're seeing today with autonomous driving is closed loop AI, where machines are replacing people. But one of the interesting things is it comes inherently into the design of the system. So let's say I have an autonomous car that's driving, and somebody's sitting there supposedly as the driver, but they're having a cup of coffee, eating a sandwich, reading something, maybe making a phone call. And the autonomous car detects something and puts its hand up in some fashion and says, excuse me, Mr. Driver, I think something's going to happen. Does the driver do anything with that? No, as we've discovered in some recent events, the driver doesn't. The car comes back and says, I really, really, really think we need to do something, and the driver doesn't do something. Third time, the driver... So what should the car do? Should the car say, look, I'm terribly sorry, I tried, but I'm going to go get involved in an accident? Or, because this is an autonomous car that knows how to drive, does it go into a fail-safe mode? Which says, you know what? I'm going to pull off to the side of the road because I don't know. That's taking great design and layering that on, because if we make the assumption that the systems will fail under some condition, can you actually have a fail-safe outcome? That's going to take people to do that. Somebody's going to have to think about the fail-safe scenario.
And these bigger questions around, the ethics question and the design question and the cultural experimentation question that will release the competitive advantage that sits in the use case, they're human ingenuity, aren't they? And that's the point. Putting the two together.
I think putting the two together is where it is. It's absolutely about augmenting human ingenuity. It's about helping people better, helping systems that support people be better. We're starting to see systems being built that are what we're calling systems of intelligence that actually are assisting professionals, making sellers better, giving them more data. Because as a seller today, no matter whether you're in a consumer products or in an industrial business, how much information as you as a seller do you actually know about this customer, about this other customer, about the industry, about your competition? How much of that information can you ingest to help you make decisions? And the great thing about AI is that AI engines have the ability to ingest large amounts of information and make a recommendation. Now, as the seller, what are you going to do with that recommendation?
Yeah, absolutely.
What are you going to do? Now, we can suggest something.
Yeah.
We could suggest sell this product versus that product, or it looks like they're going to have a problem, preempt the problem. What does the seller do? Yeah. That's the human judgment and wisdom that comes from it. And that's going to be the differentiators. What are the decisions that made with this alternate form of information?
Great. Okay, so let's bring things to close with your view on where does AI go next for Microsoft? Yeah. So in terms of Microsoft's strategy moving forward, where do you imagine that AI will go in terms of the capability?
So I think it's actually on multiple threads. Yeah. One is this wonderful AI platform that we've got, and telling that platform story and making that platform richer and deeper in terms of the services provided, new kinds of AI services, but just as important is the tools, because you need great tools to build great applications. And so the platform and tools is our heritage, and making that better, I think, is actually where it'll come. So that's the first step we've got to do. The second step is building great solutions. And the strategy that we're on is what we call first party to third party. If we're building stuff for ourselves, how to make inside salespeople better, Microsoft's a big company like any other big company, and we should be able to help other people who have a similar setup in doing that. So we're going to build a platform, we're going to build solutions, but one of the things that we've done a lot is AI infused in everything that we do. The keyboard on your phone, load balancing in Azure, it's everywhere in what we do, and sort of telling that story. But I think the sort of architectural view of taking AI to the edge and doing wonderful things on this, so building in the cloud, putting it in a container, training it in the cloud, using Kubernetes to push that down. One of the most amazing demos that I saw at Build recently was automating a drone. Yeah. It sounds simple, and even if you think about radio-controlled aircraft of 10 years ago, and kids would go with their dads, and dads would play with the airplane. That's now got to the point of autonomous drones. And this demo that we saw at Build was people building models to help a drone find things, and actually figuring out how hard that is. Yeah. But the simple idea of being able to build a model in the cloud, download that into my drone, and have it go find some toy on a surface, that's amazing. The things that we can do as a consequence of that, of moving things to the edge. Yeah. So not only running these big models in the cloud, but putting models on the edge that are going to change the requirements of bandwidth. Yeah. Taking what we call real enough time is taking the processing as close to the process that's running it, and being able to deal with those real-time events. I think there's a huge amount of stuff that's going to go
this big ambition that we have to augment human ingenuity, I mean, there's a huge opportunity and a huge responsibility that comes with us to provide that capability to do that.
And I think it all comes back to AI for good. Yeah. Is actually really thinking about how can we actually make people better. Some great work around AI for accessibility, making people with varying levels of ability suddenly have access to a normal life, whatever that means, for them to be able to do things that everybody else does. Yeah. When you see that happening, that's amazing stuff.
Incredible, incredible.
It really is.
Norm, it's been an absolute pleasure having you here. Thanks so much.
Thank you.
Enjoy the rest of the conference, and I know you've got an incredibly busy day ahead of you. So for Tech Days Online, thank you very much.
Thanks.
And we are back. Thank you so much, Norm, for doing that. It's fantastic stuff. So day 2 is coming to a close, and obviously want to say thank you, all of us, for joining us today for Tech Days Online. All of this content is going to be available on YouTube afterwards, so if you want to go back and rewatch anything, see your great interview that you did with the Hidden Figures, or any of our other content, be sure to do that. So, Andrew, before we go, what excites you the most about our AI-driven future?
Well, I think it's the process we've gone through today of actually taking data science out of the lab and putting it into production. Because it's only going to get its real value when we do that. We need to make that super easy. We don't want to distract the people doing data science from what they do. Developers need to do what they do. Everybody stays focused on what they're doing, but we're all working together.
That makes a lot of sense. So, and kind of thinking about the future, we talked a lot about the future today. Taking an even further step into the future of computing, tomorrow is all about quantum computing, and we're going to kick off live right here on YouTube and Facebook at 10 a.m. From the London Reactor, and we are very fortunate to have Julie Love, who is the Director of Quantum Computing Business Development, joining us, and she's going to be talking to us about why this is the future of computing, and we're also going to have a lot of sessions for developers focused on how you can kind of get started, because to a lot of people, and I'm going to be very honest and say, especially myself, this is an area where so over my head, I don't even know where to start, but I'm very excited to learn.
Don't sweat it. The team that we have here in the UK have picked this up. Okay, they're physics and computer science graduates.
Well,
in about 9 months of working on this, and there is this brilliant language called Q#. It's just, if you know what you're doing, it's epic.
I love it. I love it. So be sure to come back tomorrow, 10 a.m. Right here at Tech Days Online, and we will see you later.
And keep following us, Tech Days Online.
Tech Days Online, hashtag Tech Days Online.